So welcome you all to this session. So please type in the chat box, guys. Is the audio and video fine? So फटाफट टाइप कीजिए चैट बॉक्स में, ऑडियो और वीडियो दोनों ठीक है या नहीं? Yes. Good evening, Priyansh, Shashi, all of you basically, yeah. Okay. Good evening, good evening, good evening. Fine, ठीक है. So मैं पहले दो चीज कंफर्म करना चाहता हूँ एक्चुअली. इसका शेड्यूल, महाविजन का शेड्यूल क्या होता है, लेकिन इस महाविजन सेशंस में मैं क्या पढ़ाता हूँ आपको. ओके, बहुत लोग ने मेरे को टेलीग्राम पे भी मैसेज किया था कि सर अगर एक्स्ट्रा टॉपिक्स कवर करते हैं या नहीं, लेकिन जो स्पेशल टॉपिक से PYQs आते हैं वो कवर करते हैं या नहीं. सो आई एम टेलिंग यू इन दिस टॉपिक, इन दिस पर्टिकुलर महाविजन, पर्टिकुलरली ये महाविजन इसलिए कर रहा हूँ कि जो XE में एक्स्ट्रा टॉपिक्स होते हैं, सो एक्स्ट्रा टॉपिक्स में स्पेशल एम्फोसिस करते हैं, एंड जो रेगुलर टॉपिक्स में नॉर्मली हम एक बार रिवाइज कर सकते हैं. ठीक है. सो अगर मैं स्पेशल टॉपिक्स नहीं कवर किया तो एक महाविजन ऑलरेडी मैकेनिकल के लिए हुआ था. सो लेकिन इस सेशंस का एम नहीं, ये नहीं है. ठीक है. सो वी विल कवर ईच एंड एवरी स्पेशल टॉपिक दैट इज इन XE syllabus, and if you see the schedule I am going to do in 3 parts actually. Okay, so total maths में 8 sections है. Okay, so starting from linear algebra, then calculus, and sequences and series is also included in calculus as of now, and ordinary differential equations and partial differential equations, then vector and complex calculus, probability and statistics, and numerical methods भी है. ठीक है. and in सब चीजों में डेफिनेटली एक्स्ट्रा टॉपिक्स भी होते हैं, एंड ऑल्सो देयर आर सम टॉपिक्स विच आर देयर इन मैकेनिकल बट नॉट देयर इन XE ऑल्सो. जैसे कॉम्प्लेक्स इंटीग्रेशन, कॉम्प्लेक्स कैलकुलस में कॉम्प्लेक्स इंटीग्रेशन देखा तो वो मैकेनिकल सिलेबस में है, लेकिन XE में नहीं है. ओके, सो अगर आपने सिलेबस ठीक से देखा तो डेफिनेटली दे वोंट बी देयर. एक्स्ट्रा टॉपिक्स कवर देना, या डेफिनेटली, व्हाई नॉट. ओके, सो what will be done in these sessions, that's what I am telling you. So if you see in this session 1, day 1, we will be having a look on calculus, of course both single variable and also multivariable. ठीक है, single plus multivariable calculus. linear algebra में जो डायगोनलाइजेशन का एक्स्ट्रा कॉन्सेप्ट है, प्रॉपर्टीज ऑफ सिमेट्रिक मैट्रिसेस होता है, सो जो एक्स्ट्रा चीज है वो चीज भी हम कवर करेंगे. वेक्टर कैलकुलस में आपको सिर्फ लाइन इंटीग्रल्स तक ही है सिलेबस में, अगर आपने देखा तो लाइन इंटीग्रल्स तक भी है, लेकिन जो सरफेस इंटीग्रल्स एंड वॉल्यूम इंटीग्रल्स एंड डाइवर्जेंस थ्योरम्स व्हिच कनेक्ट्स बोथ आर नॉट देयर. ओके, सो सिर्फ लाइन इंटीग्रल्स तक ही पढ़ाता हूं मैंने, एंड जो लाइन इंटीग्रल्स में थोड़ा स्पेशल इंपॉर्टेंट कॉन्सेप्चुअली जो इंपॉर्टेंट पॉइंट्स होता है, सो वो भी मैं डिस्कस करता हूं. कॉम्प्लेक्स कैलकुलस में भी कॉम्प्लेक्स इंटीग्रेशन तक ही है, जो क़ौची-रीमन कंडीशंस वहां तक ही है. सो कॉम्प्लेक्स कैलकुलस में कॉम्प्लेक्स इंटीग्रेशन नहीं है, सिर्फ डिफरेंशिएशन तक ही है सिलेबस में. ओके, सो अगर आपने देखा तो आपको पता चलेगा आसान से, आपने सिलेबस डॉक्यूमेंट देखा तो आपको आसान से पता चलेगा. एंड ऑर्डिनरी डिफरेंशियल इक्वेशंस भी मैं कवर करता हूं. ऑर्डिनरी डिफरेंशियल इक्वेशंस में जो नॉर्मली सॉल्विंग टेक्निक्स होते हैं वो सॉल्विंग टेक्निक्स में पढ़ाता हूं. उसके बाद हमारे पास जो आइगन वैल्यू प्रॉब्लम्स होता है, आइगन वैल्यू प्रॉब्लम्स, ओके, आइगन वैल्यू प्रॉब्लम्स, लास्ट ईयर भी एक क्वेश्चन आया था यहाँ से, आइगन वैल्यू प्रॉब्लम्स एंड पावर सीरीज सॉल्यूशंस जो होते हैं, सो पावर सीरीज सॉल्यूशंस भी मैं कवर करता हूँ. ठीक है. सो मतलब ऑयलर कॉची इक्वेशंस के बाद पावर सीरीज सॉल्यूशंस, सिंगुलर पॉइंट्स एंड ऑर्डिनरी पॉइंट्स, एंड उसके बाद आइगन वैल्यू प्रॉब्लम्स भी मैं कवर कर सकता हूँ. ठीक है. सो जो एक्स्ट्रा टॉपिक्स है किसी टॉपिक को हम नहीं छोड़ देते. करेक्ट, वी विल कवर ईच एंड एवरी टॉपिक्स. क्लियर. ये महाविजन्स में ये हो जाएगा. पहले ये 5 टॉपिक्स आज हो जाएगा, एंड कल we'll talk about the remaining 4 topics, basically sequences and series, then numerical methods, probability and statistics, and also partial differential equations. मुझे लगता है कि उतना ही है. So we will cover these things. Okay, and जो last Wednesday में सेशन होता है XE fluid mechanics का जो एक्स्ट्रा टॉपिक्स होता है, and also the most repeating topics, like मतलब कुछ टॉपिक्स मैकेनिकल एंड XE में दोनों में ही है, लेकिन मैकेनिकल में उतना एम्फोसिस नहीं है उस टॉपिक्स में, मतलब उतना सारे क्वेश्चंस नहीं आते हैं. सो लेकिन XE में ज्यादा क्वेश्चंस आते हैं. सो वैसा जो टॉपिक्स होता है उस टॉपिक्स में भी हम स्पेशली थोड़ा सा ध्यान रखते हैं. ठीक है. क्वेश्चंस भी होगा पक्का. ठीक है. मैंने क्या किया, मैं आपको थोड़ा सा एक फर्स्ट चैप्टर कैलकुलस का आउटलाइन दिखाता हूं. पहले मैं कैलकुलस का थोड़ा सा मतलब थोड़ा डेरिवेशन स्टार्ट नहीं करता हूं, थोड़ा लॉजिकली ज्योमेट्रिकली एक्सप्लेन करने की कोशिश करता हूं, एंड उसके बाद कैलकुलस का जो क्वेश्चंस होता है, सी लास्ट ईयर इसी चैनल पे हमने XE का अभ्यास सेशंस किया था. सो अभ्यास सेशंस में सिर्फ प्रॉब्लम सॉल्विंग ही एजेंडा होता है. सो इसमें मैंने क्या किया था, थोड़ा आसान क्वेश्चंस एंड डिफिकल्ट क्वेश्चंस दोनों किया था, लेकिन आज मतलब इस साल उतना टाइम नहीं है हमारे पास. सो जो क्वेश्चंस से थोड़ा सा कॉम्प्लिकेटेड, थोड़ा सा हेक्टिक होता है, सो उसी क्वेश्चंस मैं यहाँ सॉल्व करता हूँ. बाकी क्वेश्चंस आप उस वीडियोस में देख के थोड़ा सा एनालाइज कीजिए. ठीक है. सो सबको क्लैरिटी मिला इस सेशंस में क्या हो जाएगा. पहला 5 मिनट में मैं यही बोलने की प्लान किया था. सो I hope all of you are clear what's going to happen in these sessions for the next 3 days. ठीक है. एंड मैं आपको एक इंपॉर्टेंट चीज भी पढ़ाता हूँ. लास्ट ईयर मतलब इस साल 2023-24 एकेडमिक ईयर होता है ना, सो इस 23-24 एकेडमिक ईयर में मेजॉरिटी ऑफ द मैकेनिकल रिलेटेड एंड इंटरडिसिप्लिनरी ब्रांचेस में मैकेनिकल एंड एक्सी का स्कोर अगर कंपेयर किया तो 30 to 40% ऑफ द एडमिशंस एक्सी का स्कोर से हुआ था, ठीक है। सो एक्सी का स्कोर एक बहुत इंपॉर्टेंट चीज है। सो अगर किसी की रीजन से आपकी मैकेनिकल एग्जाम उतना अच्छा नहीं चला तो भी इतना फिक्र मत, डेफिनेटली एक्सी में आपको सक्सेस मिल जाएगा, ठीक है। सर कॉम्बिनेशन, हाँ जब प्रोबेबिलिटी पढ़ाता हूँ उस टाइम पे कॉम्बिनेशंस एंड परम्यूटेशंस भी पढ़ाता हूँ, ठीक है। सो बिना किसी लेट से सेशन स्टार्ट करेंगे एंड आज का सेशन लगभग मेरा एक्सपेक्टेशन कभी एवरी टाइम होता है, लेकिन डिपेंड्स ऑन योर डाउट्स एंड इंटरेक्शन। मैं प्लान करूँगा कि लगभग 5 to 6 आवर्स इट कैन गो ऑन एन एवरेज, ओके फाइन। सो चलो स्टार्ट करेंगे पहले। सो कैलकुलस से स्टार्ट करते हैं, ठीक है, क्योंकि अगर मैंने मैट्रिक्स से शुरू किया तो बहुत लोगों को लगता है कि अरे ये सब पता है, मैट्रिक्स मल्टीप्लिकेशन मुझे भी आता है, सो इस सेशन सुनने में क्या फायदा होता है। सो लेकिन इसलिए मैंने कैलकुलस से स्टार्ट करता हूँ, ठीक है। सो फर्स्ट ऑफ ऑल नॉर्मली ये डिटेल्ड कोर्स नहीं है, मैं फिर से रिपीट कर रहा हूँ, सो डेफिनेटली विल जस्ट गो इन ए क्विक वे एंड जो स्पेशल टॉपिक्स होते हैं उस वहाँ मैं थोड़ा सा एक्स्ट्रा टाइम स्पेंड करता हूँ, ठीक है। आप पूरा मैथ्स करवाएगा ना? हाँ पक्का करवाता हूँ भाई, पूरा मैथ्स डेफिनेटली, ओके ठीक है। चलिए सो पहले लिमिट का कॉन्सेप्ट आते हैं, मैं फटाफट से एक्सप्लेन करके लेता हूँ। जो ट्रेडिशनल डेफिनेशंस होते हैं मैं नहीं देता हूँ, लेकिन ग्राफ के लिए थोड़ा सा एक्सप्लेनेशन देता हूँ। देखिए मान लो कि आपके पास एक फंक्शन है, सो दिस इज x एंड दिस इज y, एंड मान लो कि आपके पास fy इज इक्वल टू f ऑफ x एक फंक्शन है, ठीक है। सो नॉर्मली लिमिट एक्सटेंड्स टू a f ऑफ x इज इक्वल टू l। मान लो कि एक लिमिट है आपके पास एंड आपने कैलकुलेट किया तो इसका वैल्यू l आया था। सो इसका मीनिंग क्या होता है देखिए, क्योंकि कुछ बार क्वेश्चंस ज्योमेट्रिकल व्यू से आते हैं, सो इसलिए सो दिस इज x इज इक्वल टू a, ठीक है, एंड x इज इक्वल टू a में दिस मीन्स दैट x इज टेंडिंग टू a एक्चुअली, ठीक है। सो x इज टेंडिंग टू a, x इज टेंडिंग टू a एंड x इज इक्वल टू a, दोनों में थोड़ा सा डिफरेंस है एक्चुअली, ओके। सो इफ यू सी x इक्वल टू a इज एग्जैक्टली एट दिस पॉइंट, लेकिन x टेंड्स टू a, इसका मतलब ये होता है कि x बिलोंग्स टू a माइनस डेल्टा कमा a प्लस डेल्टा, मतलब डेल्टा एक छोटा सा वैल्यू है, डेल्टा इज ग्रेटर देन 0। सो अगर आपने एक इंटरवल बनाया तो x एक्सिस में देखिए दिस इज a प्लस डेल्टा एंड ये होता है कि a माइनस डेल्टा, ठीक है। सो a प्लस डेल्टा एंड a माइनस डेल्टा, सो x बिलोंग्स टू दिस इंटरवल, लेकिन जब लिमिट डिफाइन होते हैं ना, सो विल सबट्रैक्ट दिस a एक्चुअली, ठीक है। सो a को सबट्रैक्ट करते हैं, दिस इज कॉल्ड द डिलेटेड नेबरहुड कॉन्सेप्ट, ठीक है। सो नाउ इफ यू सी इस लिमिट का वैल्यू क्या होता है when x is moving towards a, मान लो कि मैंने इस ग्राफ फिर से बनाया x y and you have y is equal to f of x like this, ठीक है। now if this is y equal to f of x and this is x is equal to a, so मान लो कि आप यहां स्टार्ट कर रहे हैं, so this point is x value, at this point the function is something like this, okay, and if you start moving towards a, यहां से यहां पहुंच गए, function is like this, यहां से यहां तक पहुंच गए, functional value is something like this। so एक चीज यहां आपने ऑब्जर्व किया तो as x is moving towards a, this f of x moves something close towards l, ठीक है। so ये लिमिट का डेफिनेशन होता है, as x is moving towards a, this f of x move towards l, that's the meaning, okay। and लेकिन this l and f of ये दोनों equal नहीं, मतलब if they are equal it's fine but not mandatory that they are equal, l may not be equal to f of a, l may not be equal to f of ये एक्चुअली, ठीक है, l may not be equal to f of a of course, ठीक है। so this is the case basically, and for the function to be continuous, for continuity l should be equal to f of a definitely। क्यों, मैं आपको थोड़ा सा एक्सप्लेनेशन देता हूं, देखिए x y, मान लो कि मेरे पास एक let's say for example I'm drawing shear force diagram, एक B में मेरे पास, so shear force diagram I'm doing, then when I'm doing the shear force diagram, let's say for example this is y actually, ठीक है। so let's say I have a curve something like this and something like this maybe, okay, and exactly at this point x is equal to a, function एक अलग वैल्यू से डिफाइन हुआ है, okay, so this point is y equal to f of a। आपने देखा था ना फंक्शंस ऐसे देते हैं 1 by x minus 2 for all x not equal to 2, when x not equal to 2, then 8 when x is equal to 2, ऐसा कुछ फंक्शंस देते हैं ना, they are called split functions, okay। so कुछ फंक्शंस में क्या होते हैं, at some finite number of points वो फंक्शन नहीं डिफाइन होता है, okay, so but we can have maybe some empirical fits and all, so we can have some function. लेकिन इस वैल्यू आपने एनालाइज किया तो यही L होगा, ओके, एंड दिस इक्वेशन इज ऑलवेज सैटिस्फाइड, f of x इज इक्वल टू L, क्योंकि अगर आपने दोनों साइड से x की मतलब इफ यू आर ट्राइंग टू अप्रोच a, दिस फंक्शनल वैल्यू विल ट्राई टू अप्रोच L, बट दिस L एंड f of a आर नॉट इक्वल. नाउ फॉर कंटिन्यूटी, सो फॉर दिस फंक्शन टू बी कंटिन्यूअस क्या होना चाहिए? मैंने अगर इस डॉट को यहां लाया तो क्या होता है? If I bring this dot here, then this dot will actually act as bridge between both the ends and it forms a continuous function, correct? So geometrically bringing this point from this point to here is nothing but bringing this f of a to L. That's why for continuity this L and f of a should be equal, and आपको ये formula ऐसा ही आता है, limit extends to a f of x is equal to f of a, बस. So this is the condition for the continuity. अगर फंक्शन at a given point continuous है या नहीं चेक करना है तो इस इक्वेशन whether satisfied और नहीं चेक करना पड़ेगा, ठीक है? So is this clear to all of you? Limits and continuity done, okay? Mathematically this is the equation. लेकिन इस लिमिट कैलकुलेट करने के टाइम पे एक थोड़ा सा इंपॉर्टेंट चीज है. There are two limits, x tends to a minus f of x and limit x tends to a plus f of x, okay? So this is called left hand limit एंड इसको बोलते हैं कि राइट हैंड लिमिट. एंड ये दोनों इक्वल होना चाहिए. क्यों? ये दोनों बिल्कुल इक्वल होना चाहिए. क्यों? बिकॉज जब मैंने लिमिट का डेफिनेशन बताया, आई टोल्ड यू x शुड मूव टुवर्ड्स a, लेकिन x टू मूव टुवर्ड्स a वी हैव टू पॉसिबिलिटीज, है ना? सो यहां से राइट साइड गया तो अभी a आएगा, यहां से लेफ्ट साइड जाए तो अभी a आएगा, लेकिन मैंने डायरेक्शन स्पेसिफाई नहीं किया. सो व्हेन वी आर डिफाइनिंग लिमिट, आई जस्ट टोल्ड यू लिमिट एक्सटेंड्स टू f of x शुड गो टू L, बट x कैन गो टू a इन एनी डायरेक्शन. दिस इज कॉल्ड द लेफ्ट हैंड लिमिट, मतलब x का वैल्यू है एंड वी आर गोइंग इन दिस डायरेक्शन. दिस इज कॉल्ड राइट हैंड लिमिट. मैं एक एग्जांपल बन के आपको थोड़ा सा फिर से एक्सप्लेन करता हूं. देखिए, y is equal to mod x by x, for example, okay? So y is equal to mod x by x actually here, okay? So if this function, can I ask you, limit x tends to 0 mod x by x actually, okay, mod x by x, and is mod x by x continuous at x is equal to 0? So बताइए चैट बॉक्स में इसका वैल्यू क्या होता है? पहले लिमिट देखते हैं. सो इस लिमिट का वैल्यू क्या होता है? किसी को पता है? लिमिट x tends to 0 mod x by x. कम ऑन फास्ट इन द चैट बॉक्स. लिमिट x tends to 0 mod x by x, इसका वैल्यू क्या होता है? 1 -1 0 does not exist, something? All of you. Gate में went very bad, very demotivated. अरे नहीं भाई. See, as this session goes on ना, आगे 5 घंटे या 6 घंटे तक, I'll give you few important things meanwhile, okay? So don't worry. Demotivate होने की कोई जरूरत ही नहीं है. Does not exist, correct? क्यों does not exist? Because देखिए, अगर मैंने लेफ्ट हैंड लिमिट कैलकुलेट किया तो लिमिट x tends to 0 minus mod x by x actually, okay? So यही आएगा आंसर. लिमिट x tends to 0 minus mod x by x, ठीक है? Yeah, does not exist is actually the correct answer, ठीक है? Does not exist is actually the correct answer. देखिए, क्यों does not exist? I'll just tell you. If you see limit x tends to 0 minus, tell me when x is tending to 0 minus, इसका मतलब क्या है? x is less than 0, ऐसा नो? क्योंकि मैंने बताया आपको when x is tending to a minus, we are somewhere in this region. अगर हमने इस region पे है तो a से थोड़ा कम है वैल्यू, so x is less than 0. So limit x tends to 0, मैंने इस माइनस साइन हटा दिया, लेकिन इस फंक्शन को मॉडिफाई करते हैं, ठीक है? कैसे मॉडिफाई करते हैं? व्हेन x इज लेस देन 0, मॉड x का वैल्यू प्लस x होता है या माइनस x होता है? सबको पता है ना ये चीज. व्हेन x ग्रेटर देन 0, x इज लेस देन और इक्वल टू 0, मॉड x फंक्शन इज डिफाइंड लाइक दिस, करेक्ट? सो जब x 0 से थोड़ा कम होता है, दिस मॉड x विल बी माइनस x, क्योंकि x का वैल्यू नेगेटिव है, ठीक है? सो इस वैल्यू इज -1. लेकिन अगर मैं राइट हैंड लिमिट कैलकुलेट किया तो, इफ यू कैलकुलेट द राइट हैंड लिमिट, लिमिट x टेंड्स टू 0 प्लस mod x by x आते हैं, करेक्ट? सो दिस इज इक्वल टू लिमिट x टेंड्स टू 0. जब x 0 से थोड़ा सा ज्यादा होते हैं, देन डेफिनेटली x इज अ पॉजिटिव वैल्यू, करेक्ट? अगर x पॉजिटिव है तो so this mod x function will become x divided by x, and this value is 1 actually. So if you see left hand limit and if you see right hand limit, ये दोनों चीज सेम नहीं है. So left hand limit is not equal to right hand limit, okay? So this implies limit x tends to 0 mod x by x, this value does not exist, okay? So this is does not exist. Clear? Non? immovable discontinuity, हाँ correct, okay, so it's called non-immovable discontinuity normally because we cannot eliminate it by cancelling and all. क्योंकि why this is non-immovable discontinuity and all, it is something similar to concept of poles in complex calculus. मान लो कि मैंने आपको एक फंक्शन दिया था, limit x tends to 0 और x tends to a sin x minus a divided by x minus a. यहां भी 0/0 फॉर्म आता है, लेकिन x माइनस ए को हम एलिमिनेट कर सकते हैं। कैसे? अगर आपने इसका पहले से इस एक्सपेंशन बनाया तो एक x माइनस ए कैंसिल होता है सारे टर्म्स पे, सो वी विल एंड अप विद नो डिनोमिनेटर हैविंग 0 टर्म, ओके, सो दैट्स व्हाई दिस इज कॉल्ड नॉन रिमूवेबल डिसकंटिन्यूटी. Anyway, in complex numbers we call it non-removable singularity. So this does not exist, and if this does not exist then continuous की कोई बात ही नहीं है, not continuous. ठीक है? क्यों? पहले कंटिन्यूटी शो करने के लिए इस कंडीशन को हम सेटिस्फाई करना पड़ेगा, लेकिन दिस इज नॉट एग्जिस्टिंग, ओके, सो व्हेन दिस डज नॉट एग्जिस्ट वी कैन नॉट टॉक अबाउट कंटिन्यूटी, ओके. सो हाउ टू स्कोर गुड मार्क्स इन एक्सी? टेक्निकल सब्जेक्ट्स, दो सब्जेक्ट्स आपने चूज करते हैं ना, सो वो सब्जेक्ट्स में कुछ गड़बड़ मत करना, ठीक है. एंड ऑल्सो मैथ्स एक कंपलसरी सब्जेक्ट है, सो मैथ्स में कई बार बच्चे बोलते हैं कि इवन टॉपर्स लोग, जो लोग फर्स्ट 20-30 रैंक्स में आते हैं, वो लोग भी बोलते हैं कि सर मैं से एक्सी में सिर्फ 8 मार्क्स आया था, 7 मार्क्स आया था, वैसा ही बोलते हैं, ओके. लेकिन एक्सी मैथ्स इफ यू सी इट्स नॉट कॉम्प्लिकेटेड, सिलेबस थोड़ा एक्सेसिव है, दैट्स ए फैक्ट एक्चुअली, लेकिन जो क्वेश्चंस आते हैं ना वो कॉन्सेप्चुअली स्ट्रांग होता है बस, ओके, मतलब क्वेश्चन कॉम्प्लिकेट नहीं होता है, कॉन्सेप्चुअली थोड़ा सा स्ट्रांग होता है बस, ठीक है. सो लेकिन आज और कल आपने ये दोनों सेशंस ठीक से अटेंड हुआ तो पक्का मैं आपको I cannot guarantee but I can say that you'll be able to get easily 10 to 12 मार्क्स पक्का, ओके, बिकॉज मैंने इतनी बार एक्सी एग्जाम दिया था, कहीं भी मेरा मार्क्स 12 से नीचे नहीं है एक्सी ए में, ठीक है. फाइन. हाईएस्ट इज 15 out of 15 once I got in 2022 I guess, least is 13, okay, one question happened sometimes, fine, so this does not exist actually, ठीक है. so मैं थोड़ा सा स्टैंडर्ड लिमिट्स देता हूं आपको, अगर एग्जाम में आए तो यूज हो जाएगा. कल सिविल में भी एक क्वेश्चन आया था इस लिमिट से. पहले सबको पता है कि एल हॉस्पिटल रूल है ना, ये पता है, ये बहुत इंपॉर्टेंट चीज है. जब आप टेक्निकल सब्जेक्ट्स में भी लिमिट्स कैलकुलेट करते हैं तब एल हॉस्पिटल रूल विल बी वेरी इंपॉर्टेंट, ओके. सो ये बोलता है कि लिमिट एक्स टेंड्स टू ए एफ ऑफ एक्स बाय जी ऑफ एक्स इज इफ इट्स कमिंग 0/0, इफ दिस इज 0/0 और इन्फिनिटी बाय इन्फिनिटी. लेकिन एल हॉस्पिटल रूल इस दोनों चीजों पे भी अप्लाई करना है, ओके. इफ यू आर गेटिंग 0/0 और इन्फिनिटी बाय इन्फिनिटी ओनली देन यू शुड अप्लाई एल हॉस्पिटल रूल. मान लो कि आपका फंक्शन 0 इन्फिनिटी, ऑफ कोर्स 0 एंड इन्फिनिटी आया तो 0 आता है, लेकिन इन्फिनिटी एंड 0 वैसा आया तो यू कैन नॉट अप्लाई एल हॉस्पिटल रूल, ओके. If you have this form infinity by 0 then you cannot apply this L hospital rule, clear. So then you know this is then limit x tends to a f of x by g of x is equal to x tends to a f dash of x by g dash of x, okay. And if this is also coming 0/0 or infinity by infinity then definitely you can get double dash of x by double dash of x. Similarly until and unless it gives some final value you can keep applying the loop actually, okay. So if this is also coming 0/0 or infinity by infinity you can go for x tends to a f double dash of x by g double dash of x. यहाँ बहुत सारे बच्चे ने एक गलती करते हैं, they will apply this formula, लेकिन यहाँ इस फॉर्मूला की मत अप्लाई करना, ओके. सो दिस इज इंडिविजुअल, नॉर्मली ये Cauchy's मीन वैल्यू थ्योरम से प्रूव होते हैं, लेकिन अभी मैं प्रूफ के साथ नहीं जाता हूँ, लेकिन please make sure you should differentiate the factors individually, okay. Then first limit x tends to a 0, let's say straight away, sin mx by sin x, sorry, ठीक है, is equal to m. Then limit x tends to 0 sin mx by x is also equal to limit x tends to 0 tan mx by x. ये सब चीज एल हॉस्पिटल रूल से होते हैं. Then limit x tends to 0 1 minus cos ax by x square, this is a square by 2, okay, and so on. If you can have a number of applications of this L hospital rule, but there are some forms actually which I want to give some emphasis. Limit x tends to a f of x power g of x, f of x power g of x. अगर इसका वैल्यू 1 power infinity आया तो then we have actually a technique. Then 1 power infinity का वैल्यू 1 नहीं है, ठीक है, so this is not equal to 1. If then limit x tends to a f of x power g of x is equal to e to the power limit x tends to infinity g of x times f of x minus 1. So this is actually the limit in this case, clear. ये limit बहुत important limit है. I think even in XC 3-4 बार क्वेश्चन आया था लास्ट 5-6 ईयर्स में. So दिस इज एन बिट इंपॉर्टेंट लिमिट. ओके, इसका प्रूव भी खा सकते हैं लेकिन अभी नहीं करते क्योंकि टाइम थोड़ा सा शॉर्ट है. सो ई पावर लिमिट एक्सटेंड्स टू इन्फिनिटी जी ऑफ एक्स इंटू एफ ऑफ एक्स माइनस 1. कल सिविल में एक क्वेश्चन आया था, मैं आपको इस स्टेटमेंट का एक एग्जाम्पल भी देता हूँ. लिमिट एम टेंड्स टू इन्फिनिटी 1 प्लस 0.05 बाई एम होल पावर एम. इसका वैल्यू कैलकुलेट करना पड़ेगा, मतलब थोड़ा सा डाटा दिया था. सो लेकिन वो क्वेश्चन इस वैल्यू से डिपेंड होता है. एम टेंड्स टू इन्फिनिटी, लिमिट m tends to infinity 1 plus 0.05 by m whole power m is equal to मैंने okay fine. So let's see, if you want to solve this, normally when you put m equal to infinity 0.05 divided by a very big value goes to 0, so 1 plus 0 1 power infinity आए थे, correct? So therefore this limit is equal to e power limit m tends to infinity this function m into this function f of x minus 1 actually. Okay, so अगर आपने सॉल्व किया तो e power 0.05 आते हैं. Okay, so you can use a calculator and get this value. Clear? कही है सिविल से, मतलब see this question came in actually civil last in yesterday's I think slot 2 maybe second session. Is there any civil students? If you are there, you can identify this, correct? Of course, यहाँ -1 भी है, so इससे -1 करना पड़ेगा. 5.21% something is coming because मैंने civil का solution दिया था last year. I mean last day actually. So this is one important property, and also मैं आपको थोड़ा सा techniques देता हूँ यहाँ. Limit x tends to a f of x power f of x. If this is coming 0 power 0, which is of course not equal to 1, but still the final answer, because of applying logarithm and L'Hospital rule, you will find out this value is 1. Okay, this value is 1. It's not because of 0 power 0 thing. There is a limit and L'Hospital which you have to apply. Like for example, I'll give you one thing which I think came in one of the exams actually. Limit x tends to 0 sin x power sin x. This is 1 actually. Okay, similarly limit x tends to 0, not 0, maybe 3, 1 x minus 3 whole power x minus 3. I think this is also came. So this also is 1. Okay, this one is not because of 0 power 0. Okay, 0 power 0 का value 1 नहीं है, लेकिन जो एक L'Hospital and logarithm का technique है, so normally it's called 2L technique. So if you apply that 2L technique, we'll end up with this results. Okay, so normally limits में जो standard questions आते हैं वो इससे ही आते हैं हर बार. मैंने थोड़ा सा एक क्वेश्चन सॉल्व करने की कोशिश करता हूँ, एक पोल भी कंडक्ट करता हूँ. सो ऑप्शंस है आपके पास, सो मल्टीपल चॉइस. इस क्वेश्चन को आप सॉल्व करना चाहिए. सो आई एम गिविंग यू 90 seconds. ओके, स्टार्ट. कम ऑन, सॉल्व दिस क्वेश्चन. लिमिट x टेंड्स टू इन्फिनिटी x माइनस sin x बाय x प्लस sin x प्लस ln x बाय x. ठीक है, सॉल्व कर लो. 1 मिनट में, लाइक आई थिंक 90 seconds आई हैव गिवन यू, सो प्लीज सॉल्व. सेम फंक्शन, हाँ सेम फंक्शन है तो इसलिए f of x पर f of x लिखा. ओके, एंड f of x शुड बी 0 एट लिमिट x टेंड्स टू a. ठीक है, b 1 पक्का. ठीक है, लेट्स गिव सम टाइम टू आवर फ्रेंड्स टू सॉल्व. ये एक्चुअली एक PYQ है. ठीक है, XC में PYQ. b, ठीक है, पोल है आपके पास, एंटर कर लो. ओके, आई नो. ठीक है, जो बच्चे अटेम्प्ट करते हैं वो बच्चों के लिए हम थोड़ा सा टाइम देते हैं. सो प्लीज सॉल्व. 100 पक्का, 1 पक्का आई थिंक. करेक्ट. सुष्मित, पतित, सागर, देवज्योति, आई थिंक बी. फाइन, चलो लेट्स सॉल्व करते हैं. बाकी लोग कोशिश कर लो जब तक पोल एंड होता है तब तक. लिमिट x टेंड्स टू इन्फिनिटी, I will split this into two parts. X minus sin x by x plus sin x plus limit x tends to infinity ln x divided by x actually. ठीक है, मैं दो लिमिट से स्प्लिट करता हूँ. ठीक है, सर वेयर इज पोल? You can just enter in the chat box. Okay, if you enter in the chat box, it automatically takes in the pole. Clear? So let's see. If you simplify this, इसका वैल्यू 1 आता है पक्का. क्यों? देखिए, मैं आपको थोड़ा सा चीज यहां देना चाहता हूं. देखिए, लिमिट x टेंड्स टू इन्फिनिटी a नॉट x पावर m प्लस b a1 x पावर m माइनस 1 and so on am plus f of x divided by b नॉट x पावर n plus b1 x power n minus 1 and so on plus bn plus g of x is equal to a naught by b naught if m is equal to n, 0 if m less than n, infinity if m greater than n actually. Okay, but there is a condition. These two functions f of x and g of x are finite valued functions. So what is the meaning of finite valued functions? मान लो कि मेरे पास sin x है, so sin x is a function actually. x में आप किसी भी वैल्यू सब्स्टिट्यूट कर लो, this sin x is always between -1 and +1, करेक्ट? इट इज बाउंडेड, मतलब x में जो ही वैल्यू सब्स्टिट्यूट करना तो इस sin x का वैल्यू फाइनाइट ही आएगा, करेक्ट? सो दैट्स हाउ. सिमिलरली यू कैन हैव cos x, cos 2x, sin 2x. You can have many functions like this. Whenever you have this is the simple result which you can see. Okay, I'll show you the general explanation how it happens. Limit x tends to infinity. Okay, so limit x tends to infinity. x minus sin x या plus sin x, ठीक है, कोई फर्क नहीं पड़ता. Minus sin x by x plus sin x. So अगर आपने सिंप्लीफाई किया तो limit x tends to infinity. I can take x common. 1 minus sin x by x. X common. 1 plus sin x by x actually, correct? So if you simplify this, x gets cancelled. Okay, then x gets cancelled. Limit x tends to infinity sin x by x का वैल्यू क्या होता है? Limit x tends to infinity sin x by x का वैल्यू क्या होता है? पता है किसी को? What is the value of limit x tends to infinity sin x by x? Limit x tends to infinity sin x by x. 1. Is it? I know. If I ask this question, I know majority of you will say 1 because you are feeling that it is 0. Then this is 1. Okay. लेकिन limit x tends to infinity sin x by x का वैल्यू आपने लिया तो this is not equal to 1 actually. हाँ 0. ठीक है, fantastic. This is actually 0. Explanation बहुत आसान है. Whatever you put in place of x, this value is always a finite value in -1 1 divided by infinity. Answer 0 ही होगा. Okay, so this answer is 0 whenever there is infinity here. ठीक है. Now let's see, when you have this 0, then definitely this is 1 because this term is 0, this is also 0. 1 by 1 is 1. So इस पहला पार्ट जो होता है, so इस पहला पार्ट का वैल्यू 1 होता है. Okay, now coming here, limit x tends to infinity sin x by x. ठीक है. So अगर आपने सब्स्टिट्यूट किया तो 0 by infinity, sorry, not sin x by x, log x by x. Okay, ln x by x actually here. मैं थोड़ा सा मैनिपुलेट करता हूँ, minus and minus sign, so that when you go to infinity, okay, it is not given 0, so fine. When you go to infinity, log infinity, अगर आपने log function देखा तो ऐसा होता है. So when it goes to infinity, this function also goes to infinity. So this is infinity by infinity form. So हम L hospital लेते हैं. Limit x tends to infinity. Differentiation of ln x 1 by x divided by derivative of x is 1. So limit x tends to infinity 1 by x. इसका value 0 आता है, correct? So this is infinity by infinity, but if you apply L hospital, this is 0. So this second part is 0 under this limit, and the first part is 1. 1 plus 0 is 1. B is the correct answer. Fantastic. Okay, so let's see. B सही answer है. Come on, 100%. बढ़िया, बहुत सारे लोग ने किया था क्वेश्चन 24 सेकंड्स में, 40 सेकंड्स में. देवज्योति, सुष्मित, विवेक, अभय, गुड. ओके, 90 सेकंड्स दिया था. सी, अभय ने एज 988.8 सेकंड्स पे आंसर दिया था. ठीक है. Having problem in remembering formulas in superposition of flows in potential flows. I'll give you. Okay, जब मैंने potential flows पढ़ा था, आपको थोड़ा सा रिमेंबर, मतलब you don't need anything to remember because complex numbers में पढ़ाता हूँ. ठीक है. And जो complex numbers background चाहिए, जब मैंने potential flows on Wednesday पढ़ाता हूँ. Okay, so जो potential flows पढ़ने का background चाहिए complex numbers में, वो मैं आज ही क्लास में देता हूँ. ठीक है. complex functions भी आज हम कवर कर सकते हैं. So आज ही मैं थोड़ा सा background भी देता हूँ. ठीक है. Okay, travel games with Panjal. Fine. So let's see. Fantastic. Yeah, this is the list. So anyway, let's move forward. I think we have one more question. लेकिन ये इंटीग्रेशन से है. ठीक है. Now let's see. We will continue our discussion basically. Differentiation. ठीक है. So differentiation, if you see, if you have a function like this, for example, y is equal to f of x actually. Okay, now this is again a point, x is equal to a. For example, x is equal to a, this is x and this is y axis. So if you see this expression dy by dx, this value is nothing but, many times you might have seen this, limit delta x tends to 0, delta y by delta x. Okay, so what this actually tells you, this expression is nothing but when you change x by small amount, what is the change in corresponding y? That's what. Okay, maths is little weak. Whatever I'm going to teach now, I will not assume that you know something already. Okay, whatever I teach, you know, just learn that. That will definitely make you exam course. Then after जब YouTube में हम descriptive course करते हैं, तब एक point थोड़ा सा ध्यान से, थोड़ा सा पूरा detail से सीखते हैं. ठीक है? So let's see. In this case, what is the meaning of this? If you have, for example, a value here, which is y, or let's say f of a, which is y1, for example, you call, and this is x1. If you take this value x2 is equal to a plus delta x, for example. Okay, so this value is x2 is equal to a plus delta x, and this is f of x2, which is y2, which is f of a plus delta x. Okay, f of a plus delta x. Okay, now let's see, if you want to take the derivative dy by dx at x is equal to a, for example, limit delta x tends to 0, limit delta x tends to 0, we can write f of a plus delta x minus f of a divided by delta x, correct? This is what you'll get, because the difference in y is this value, the difference in x is basically this value, which is just delta x actually. Okay, and if you apply the limit, you can also write this as limit x tends to a, f of a minus f of x divided by delta x, or you know, x you can h you can write the small step size. Okay, yeah, by a minus x we'll write better. Okay, so a minus x. Normally you might have seen x tends to a, f of x minus f of a by x minus a. That actually comes from this first principle of, or basically the first principle of differentiation. Okay, if you want to calculate the derivative dy by dx of any function, if you have a function y equal to f of x, okay, then how do you calculate the derivative? Limit h tends to 0, f of x plus h minus f of x divided by h. ऐसे ही कैलकुलेट करते हैं ना, आप सबने पढ़ाया था मैथ्स में, limit h tends to 0, f of x plus h minus f of x by h. Normally the same thing, if I change this coordinate to x, then this is x plus h. Okay, this is the small gap between these two, this is h. Then definitely these values will be f of x plus h, and this is f of x actually. So difference in y gives you f of x plus h minus f of x, difference in x gives you h, but this difference has to be very small, that's given by this limit, that's all. Okay, so this is the first principle of differentiation, and कई भी function को differentiation calculate करना है तो हम इसी formula से calculate करते हैं. ठीक है, so what is the physical meaning of this? Let's say for example, if I give you a function and if I calculate what is f dash of a is some point. Okay, so this value is nothing but f dash of x at the value x is equal to a. Like for example, you take 1 plus x square. Okay, then f of x is f dash of x is equal to 2x. Now if I keep f dash of 2 is equal to 4, what does this 4 actually tell you? Okay, so geometrically थोड़ा सा देखते हैं. X, y, if you have a function like this, this is y is equal to f of x. Now at this point x is equal to a, so somewhere here at this point x is equal to a. If you calculate f dash of a, what does this gives you? So derivative always gives you the slope of tangent. मतलब आपने अगर यहाँ एक tangent बनाया तो, then definitely this tangent will make some angle theta with x-axis. With the x-axis, because this expression means df by dx at x equal to a. Okay, so when you are differentiating with respect to x, the angle should be measured with respect to x-axis. Okay, this is nothing but tan theta. That's all. Okay, that's how both are connected actually. Okay, fine. Like for example, I'll ask you one simple thing actually. If you have the function mod x, okay, then mod x is not differentiable at x is equal to 0. Okay, mod x का ग्राफ सबको पता है. Let me draw it one last time before GATE 2024 XC. X, y, and if you plot the mod x graph, this comes like this. Okay, now let's see, this is the line y is equal to x, this is the line y is equal to minus x, and आप सबको पता है, if line is of the form y equal to mx, m is the slope, which is nothing but this quantity, so m is actually the slope. So slope of this line is 1 and slope of this line is actually minus 1. And when you have a sharp point, normally at any sharp points functions are not differentiable, because when you go slightly to the right of sharp point, slope will be positive because this theta is less than 90. If you go slightly here, this theta will be more than 90. So slopes won't match actually. So that's not differentiable at x equal to 0. Okay. So even if you check it using the limits, limit x tends to a minus f of x minus f of a divided by x minus a. Okay. Now if you substitute this, let's say I'm replacing a with 0 for example, okay, because at 0 I want to check whether it is differentiable or not. So 0 minus left hand limit is what I'm calculating firstly. Now when x is tending to, and I'm replacing this f of x as mod x actually, okay. And now let's see, when x tends to 0 minus x is less than 0. If x is less than 0, this expression can be written as minus x minus 0 divided by x, which is minus 1. And you can clearly see when x tends to 0 minus, मतलब x 0 से कम होता है, उस time पे slope minus 1 है, which is known from this equation y equal to minus x. Okay, so geometrical, no, it's not discontinuous, it's continuous actually. Okay, so you can see function में किसी point पे break नहीं है, मतलब function is actually continuous. You can see there is no breaking in the function. Okay, that's all. Clear? Normally discontinuous mathematically limit does not exist, but physically function should have a break actually. Okay, but अगर आपने mod x function देखा तो कहीं जगह पे break नहीं होते. Okay, it's a smooth continuous function. Clear to all of you? Did you all understand differentiation? Okay, because many times they'll ask you, if f of x is the function, then the slope of tangent to this function at x is equal to this. Okay, it is continuous. Okay, this function is continuous. Yeah, vertical tangent, all these are points of non-differentiability. Okay, because at that point the slope value can go to infinity and the derivative may not be equal on both the sides. Yes, सबको यहाँ तक clear है या नहीं? Clear? Fine. So let's go to the next case. Taylor series, थोड़ा सा important चीज है ये भी. Taylor series, questions आते हैं Taylor series से. So whenever we have a function such that a function कैसा होना चाहिए? Continuously derivable. Continuously derivable. Continuously derivable का मतलब क्या होता है? F dash of x, f double dash of x, and so on exist. Okay. Look, these values can be equal to 0, but it's not like they do not exist. Like for example, you take mod x. Mod x has the derivatives as +1 and -1 in the left hand limits and right hand limits. Okay, but since both of them are not equal, derivative does not exist. So in these cases, the values can be zeros. Okay, but they cannot. It's not like they cannot exist actually. Okay. Now let's see. If you want the terms of x minus a, then this expression is like f of a plus x minus a by 1 factorial into f dash of a plus x minus a whole square by 2 factorial into f double dash of a, and so on. This goes to infinity actually. Okay, it's an infinite series actually. Now I want to tell you one thing. So question practice नहीं हो गई series में, होता है ना, अभी एक question solve किया था पहले. Now let's see. In this case, when you have this f dash of a and f double dash of a, you can have doubt, what if there are a few functions which exist like this, but there are very few series cases. But right now what we are assuming is all these are very finite values. Okay, it's not like this value goes to infinity and all these exist, they are finite numbers. Okay, now when they are finite numbers, look, I want to tell you one thing. This is the generalized Taylor series expansion. Taylor series expansion actually. Taylor series expansion. And let's see, if I put x tends to a, matlab x minus a is very small, x minus a tends to 0. Okay, so let's say if I put this, concepts are clear hai bhai? Nahi, I'm telling you, as long as your concepts are strong, whatever might be the twist in the question, definitely you'll be able to solve that. Okay, fine. So let's see, in this case, if I put this, now can you tell me what will be this value of x minus a whole square? If x minus a is very very small, then what is x minus a whole square? Much small, and divided by 2 factorial. And if this is finite number, then this complete quantity will go to which value? What will be the value of this complete quantity when x minus a is tending to 0? If x is very close to a, then what is this value? 0, na? So if you neglect these higher order terms, neglecting higher order, then what we have, f of x is equal to f of a plus x minus a into f dash of a actually. So this can be written as f dash of a is equal to f of x minus f of a divided by x minus a. But when this is valid, when this expression is valid, only when x is tending to a. Okay, so limit x tends to a. This expression is same as this expression which you have studied somewhere. Okay, so maybe this, yeah, this one. Okay, so you can see these are same, and this is called linear approximation of Taylor series. Okay, linear approximation of Taylor series actually. Okay, so this is called linear approximation of Taylor series. Clear? Okay. So can you tell all high probability topic of maths? Just attend these 2 days, you'll come to know yourself. Okay, so see, and normally if you write the expansions for sin x is equal to x minus x square, sorry, x cube by 3 factorial plus x power 5 by 5 factorial and so on होता है. Cos x is equal to 1 plus x square, sorry, 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on. Okay, this goes on. Okay, and normally these things you might have seen in mechanical, civil, normally a syllabus common here, so that's why I'm not stressing much on this. Okay, we'll shift to maxima and minima. Clear? Is this clear to all of you? Yes or no? Please type in the chat box. लेकिन एक important चीज है मीन वैल्यू थ्योरम्स. सो मीन वैल्यू थ्योरम्स के बाद हम मैक्सिमा मिनिमा कॉन्सेप्ट पे जाते हैं. यहाँ तक सबको क्लियर है या नहीं? टाइप कीजिए चैट बॉक्स में. क्लियर? Because these are quite common topics which you see in normal in in your core branch syllabus, mechanical, civil, ECE, triple all over. Okay, so let's move on to mean value theorems. Mean value theorems. I'll tell you only one theorem, Lagrange's mean value theorem. Other two are just implications of this. Cauchy's and Wallis theorems are actually implications of this. So when you go for Lagrange's mean value theorem, so what does this Lagrange's mean value theorem tells you? F of x is continuous in a comma b, differentiable in a comma b, then if there exists at least one value of c, at least one value of c such that याद है किसी को इस कंडीशन क्या होता है? f dash of c is equal to f of b minus f of a divided by b minus a. This is the value. इसका मतलब क्या होता है? Okay, so please give a glimpse of Lagrangian multipliers also. पक्का जब मैं multivariable calculus पढ़ाता हूँ उस टाइम पे Lagrange's multipliers का constraint maxima and minima concept भी पढ़ाता हूँ. ठीक है, no issues. क्या चल रहा है सर? फ्लूइड मैकेनिक्स नहीं. ओके, एटीडी वो भी नहीं, मैथ्स चल रहा है प्योर. सो आफ्टर दिस महाविजन वी कैन फॉलो योर प्रीवियस ईयर्स एक्सी प्रीवियस पक्का बिल्कुल 100%. ओके, इसलिए मैंने सेशंस वेडनेसडे से वी हैव स्टॉप्ड द सेशंस ऑन वेडनेसडे बिकॉज सी आई विल बी कवरिंग कंप्लीट थियरी टुडे एंड टुमारो एंड मीनवेल विल आल्सो सॉल्व सम क्वेश्चंस. लेकिन जो लास्ट ईयर का सेशंस है महा एक्सी अभ्यास का सेशंस है, सो अगर आपने मैथ्स वहाँ देखा तो वो सेशन सिर्फ एंड सिर्फ कॉन्सेप्चुअल मतलब क्वेश्चंस प्रैक्टिस का सेशंस है. सो इफ यू कैन इंटरलिंक दीज टू ऑन थर्सडे एंड फ्राइडेज ऑन थर्सडे एंड फ्राइडे ऑफ कोर्स, देन यू विल हैव अ ग्रेट एडवांटेज. ओके, फाइन फाइन. ओके, clear? So let's see what is this value actually. Okay, ये इक्वेशन Lagrange ने कैसे दिया था? एक दिन सोया बेड पे, ठीक है, पूरा नींद में चला, then he got a dream that this is the formula, he has published this. Correct? No. See, actually there's a logic behind this. If you have a function origin x, y actually, if you have a function like this for example, okay, so let's say you have a function like this. This function y is equal to f of x. This is x is equal to a. This is x is equal to b. Okay, so x equal to a and also x equal to b actually. So will there be sessions for solid and demo? हाँ होता है. Let's see. I want to ask you one thing. This function is y equal to f of x. मान लो कि इस पॉइंट a से डिनोट होता है एंड इस पॉइंट b से डिनोट होता है. Can I write this coordinates as a comma f of a and b comma f of b? कैन आई राइट द कोऑर्डिनेट्स लाइक दिस? करेक्ट, क्योंकि अगर यहाँ इस पॉइंट पे x का वैल्यू है तो फंक्शन का वैल्यू f ऑफ a होता है. सिमिलरली इस पॉइंट में x का वैल्यू b है तो फंक्शनल वैल्यू f ऑफ b होता है. करेक्ट. नाउ इफ आई जॉइन these two lines, these two points with a straight line, मान लो कि मैं इस दोनों पॉइंट्स a एंड b को स्ट्राइट लाइन से जॉइन करते हैं, देन कैन यू टेल मी वेदर दिस इज करेक्ट और नॉट? स्लोप ऑफ ab, अगर दो पॉइंट्स x1 y1 और x2 पॉइंट से एक लाइन पास होता हो, सो स्लोप होता है कि y2 minus y1 by x2 minus x1, so f of b minus f of a by b minus a actually. Correct? So this is the value, f of b minus f of a divided by b minus a. That's the value actually. Correct? Slope of this line is nothing but this guy, y2 minus y1 divided by x2 minus x1, which is nothing but dy by dx, of course. Okay. Now let's see, if you, for example, make a tangent here at this point, if you make a tangent here, similarly maybe at this point, if you make a tangent here, similarly depending on the type of function you can make n number of tangents. Can anyone tell me, if this point, if I call it c, then slope of this tangent, slope of tangent is nothing but f dash of c. Correct? f dash of c. Correct? इस point पे अगर एक tangent बनाए तो tangent का slope कितना होता है? f dash of c भी आता है. So if two lines are parallel, मान लो कि इस yellow line and this green line are parallel to each other, okay, then definitely their slopes has to be equal. That's what this equation tells you. Okay, means if you have a curve, continuous smooth curve, then definitely there exists a point here, somewhere here, such that the slope of the tangent is exactly same as the slope of line connecting the points. That's what Lagrange's mean value theorem tells you physically. मैं इस geometrical explanation क्यों दिया पता है? एक बार एग्जाम में क्वेश्चन ऐसा आया कि let's say for example there are 2 points, they have given you these 2 points, then they asked at least at one point on the curve the slope of the tangent is dash. That's what, मतलब they want you to use this theorem, but they didn't mention directly to use this. Okay, they told if there is a smooth curve which is passing through these 2 points a and b, then at least at one point the slope of the tangent is equal to dash, which is nothing but slope of the line. That's what this Lagrange's mean value theorem tells you actually. Is tan x has some series, sir? Huh, it has actually x minus I think 2 by 15 x cube, things like that. Okay, you can just generate any series as long as it's continuous and differentiable using Taylor series. Okay, now if f of a is equal to f of b for a not equal to b, let's say if there is a function for which f of a and f of b are equal, then at least at one point f dash of c is equal to 0. This is called Rolle's theorem actually. Rolle's theorem. बहुत लोगों को लगता है कि सर सिर्फ ये एप्लीकेशन है, f of a and f of b 0 है तो सबको पता है कि f dash of c is equal to 0. लेकिन इस theorem का इतना इंपॉर्टेंस क्यों है? Because initially before Lagrange's, Rolle's gave this theorem, and this Rolle's theorem is actually the background for concept of can anyone tell me? This theorem is actually the background for concept of third law of thermodynamics. Correct? No, this is actually the concept of maxima and minima. Okay, and that's why because of this, whenever there is a maxima or minima, you will always have a differentiation at that point equal to 0. Okay, which we'll see now, which is basically the this concept of maxima and minima. Okay, now let's see one more interesting thing. Cauchy's mean value theorem. Cauchy's mean value theorem. Again, same conditions. F of x and g of x are 2 functions. All these things, differentiable continuity, same conditions hold. This is g of b minus g of a divided by f of b minus f of a actually. Okay, so f of b g of b minus g of a divided by f of b minus f of a actually here. ठीक है, एक बार Rolle's theorem फिर से please. हाँ, बढ़ाता हूँ. Okay, just give me a minute. After this I will give some small time on Rolle's theorem, then we'll go to maxima and minima. Okay, fine. Let's see. I'll ask you one thing. You should be able to answer this. If these two are zeros, for example, okay, if these two are zeros, and let's say this is also giving you 0 by 0 form, then definitely this should also give you some derivatives at this point. Okay, means if you plot these functions geometrically, you might have seen log graphs. Normally we are always habituated to plot x and y, but normally you can also plot something like f of x and maybe some other function g of x here. Many of you, I think nowadays you are using or not, but you have something called log graphs, in which x-axis is not just the x-axis. X-axis is actually some log function, and on y-axis we'll plot some other thing. Okay, so when you apply the Lagrange's mean value theorem on this graph, this is what it comes out. Okay, maybe if you have some function something like e power x is equal to 1 plus x square, 1 plus x by x plus x square, let's say you have something like this, okay, then you can plot between two values. Okay, so let's see. Now coming to the Rolle's theorem once again. Rolle's theorem, it tells you this is x and this is y, and let's say you have some function, continuous function, for example, continuous function such that this is x is equal to a again, so this is f of a. So if this point is capital A, इसका coordinates होता है कि a comma f of a, okay. Similarly this point is b comma f of b actually, okay, b comma f of b actually in this case, okay. Now whenever you see these two values f of a and f of b are equal, for example, I think it's not looking straight, but assume it's a straight line, okay. Better. So this is point B actually. Then whenever these two are on same values, then definitely f of b minus f of a will be 0. So definitely there exist few points such that the slope of tangent is definitely 0 actually, okay. Slope of the tangent is actually 0, and from here we'll connect it to the maxima and minima. Sine curve, even if you take sine curve, 0 to 2 pi, okay, even that can give you, then definitely at pi by 2 and 3 pi by 2 you have 0 slopes, okay. So something similar to that. Fine. So is this clear to all of you? Okay, so let's go to the concept of maxima and minima, then after we'll move to integration, okay. Then we'll try to finish the first single variable calculus. So let's see concept of maxima and minima. यहाँ थोड़ा सा ध्यान से सुनना है क्योंकि there are two things which is local maxima and also global maxima. Similarly, local maxima and local minima and also global minima. So what is the difference between these two? Okay, so let's see what we understand here. First of all, if you have a function f of x, then if you want to calculate the maximum value or minimum value, like for example, let's say मेरे पास efficiency है, okay, and efficiency is depending on, let's say for example, some temperature. Then if I want to calculate what is the maximum efficiency, I have to differentiate the function with respect to temperature, correct? Or rather than differentiating, first of all I want to know what could be the maximum performance of the systems, okay. So not only that, even in case of control systems, what could be the maximum control that I can adopt to a system. So if you want to talk about these things, if you want to calculate this extreme of this, firstly f dash of x has to be 0, okay. So once you get this, we'll get stationary points from here. Stationary points. Number of stationary points depends on this function. Like for example, if I have a quadratic function, okay, then if I differentiate a quadratic function, I'll get a linear function. Equating linear function is equal to 0, I'll get only one stationary point. Let's say I have cubic function, and if I differentiate it, I'll get quadratic. Equating quadratic to 0, I'll get two stationary points. If I have trigonometric sin x, differentiating it, I'll have cos x, and equating it to 0, I have infinite number of stationary points, okay. So therefore you can have stationary points, n number of stationary points, that depends upon basically this function f of x actually, okay. Now I'm doing analysis for one stationary point. x0 is stationary. If this x0 is actually stationary, then this stationary point, then for f double dash of x0 negative, you know, f of x has maximum, global, max at x is equal to x0. Similarly, f double dash of x0 is greater than 0, then f of x has minimum at x0, and if this is equal to 0, then it can be a point of inflection. Point of inflection, normally call this critical point inflection, where first and second derivatives both are 0. And this point of inflection, I want to take 1 minute. Is there anyone, sir, Cauchy pe f dash of c by g dash of c? It's okay, fine. If this is f dash of c by g dash of c, just a minute. If this is f dash of c by g dash of c, this difference will also get flipped, okay. A by b equal to c by d means b by a is equal to d by c also, no? That's what. Okay, Shekhar, look, let me tell you one important piece here. Is there anyone other than mechanical? Because I want to spend one time depending on mechanical actually, okay, fine. Okay, so I think everyone is there. Anyone other than mechanical? Yes? Yes? Okay, fine. I just want to tell you one point. This is also sometimes called critical point. Critical point, actually. Okay, so it's passing through this, let's say. This is called critical isotherm. Okay, and at this point, so normally if you see, this point is called the critical point, and it's called critical because first derivative, second derivative equal to 0. That's how we actually calculate the values of van der Waals constants. Okay, of course it can be any state function, equation of state, but if the equation of state is van der Waals equation, then we'll calculate A and B basically by these two equations. Two equations and two unknowns, we'll get the values of A and B, so we can calculate. Okay, we calculate A and B now? Yes, of course. Okay, so basically from this concept of critical point or point of inflection, many of you might have seen this. This is called the point of inflection. Okay, same thing. Okay, so let's see. I also want to give you one important point. If there is a maximum or minimum, if there is a maximum or minimum, first derivative at that point is definitely 0. First derivative at that point is definitely 0, but converse is not 2. Converse is not 2 actually. Okay, example I'd like to show you. F of x is equal to x cube. Okay, so if you see f dash of x, you'll calculate, this becomes 3x square, u equal to 0, x is equal to 0. F double dash of x is 6x, so at stationary point x equal to 0, this is also 0, so this is 0. So first derivative is 0, second derivative is 0. Since this first derivative is 0 at x equal to 0, at x equal to 0 this function is neither maximum nor minimum. Okay, which you can understand easily. Okay, third differentiation is not 0. We'll see. Okay, normally if you go, there is normally this is given for the single variable, and even if you calculate third derivatives, there could be few functions where the third derivative also fails. It becomes 0 again in that case also. Okay, like for example, you see this, instead of x cube, if I place x power 6, then till 5 derivatives I'll keep on getting zeros. Okay, so that's why third derivative, fourth derivative, this test keeps going. There's nothing like a limit basically. Okay, in analyzing the functions. Clear? So anyway, let's see. So fine, I think we have some questions actually which we can okay, fine, we will start integration. Okay, then once we start integration we have some questions. Let's see integration. Then you all know how to integrate and all, so basic stuff I'm just skipping quickly. So one thing that I want to say here is Newton-Leibniz. This is very important for XC. Many times questions turn up. Okay, Newton-Leibniz. Oh, someone is asking now most probable topics. Maybe this is one. Okay, Newton-Leibniz rule. So what is this Newton's-Leibniz rule? Let's see. Will there be session for core subjects also? Huh? Okay. What happens at critical point for the same? Is the point of inflection same as that of point of contact flexure in BMD? Yeah, basically it changes the sign. Okay, at that point from positive, the slope changes from positive to negative. Okay, basically normally if you see V is nothing but dm by dx. You know, this is shear force, this is the bending moment actually, you have this equation. So basically where the shear force changes its sign, at that point what happens, this point of contact flexure actually comes. Okay, means basically dm by dx has to be m has to change its sign. Okay, so if m is changing its sign, then definitely derivative also changes its sign, which is the shear force also changes its sign. Clear? So coming here, this talks about derivative of integration. Like for example, you say phi of x, psi of x, and you have some f of x dx, for example. This is only for single variable. Okay, actually if you write it in general vector form, the equation is something different. Okay, so in differentiation to Newton-Leibniz, Newton-Leibniz rule. No, it's here. Okay, for the change in nature of the curve. Yeah. Okay, that's basically the point of inflection or the beam quantum flexure points. So here if you see, this gives you f of psi of x into psi dash of x. This I am giving you straight away for single variable minus f of phi of x into phi dash of x actually. Okay, so this is actual differentiation. It's not multiplication, it's a composite function. You all might have studied about composites. F of x is equal to sin x, and psi, maybe let's say g of x is equal to x square. Then f of g of x is nothing but f of g of x is actually x square. So f of x is sin x, so f of x square should be sin x square. This is actually the function. Okay, now this is a Newton-Leibniz rule, which is very, very common and frequently coming question in XE actually. Okay, and also let's see, second is mean value theorem. Mean value theorem of integration, which we use in Rankine cycles and all. So basically, if I tell the same story, f of x is continuous in a comma b, differentiable in a comma b, then there exists at least one c such that c belongs to a comma b, and f of c is equal to spacing is not sufficient, maybe I'll just erase it here and maybe I'll write it here. F of c is equal to integral a to b f of x dx divided by b minus a actually. Okay, so this is what you have. Normally there it is f of b minus f of a divided by b minus a. Last year 4 questions. Last year भी question आया था इसमें mean value theorem से. So f of c is equal to integral a to b f of x dx divided by b minus a actually. Okay, so this can also be geometrically explained if you see, which I do many times when I have taught you Rankine cycles or something in ATD, applied thermodynamics. If you have a function like this function is positive. Okay, so x is equal to a, x is equal to b. Now when this function is positive, this area is given by integral a to b f of x dx. Okay, so this is the area actually, whatever might be the function, but it's positive. Now you can generate at least at one c, you can identify at least some value of c, maybe something like this, where this area which is lost by considering this rectangle, if you take this as the rectangle, okay, then whatever the area you are losing by considering this rectangle is equal to the compensation here. Okay, such that if this value is c, then definitely this function is f of c, and this gap is b minus a. So area of this rectangle will be same as the total area, so f of c times b minus a actually. Okay, so that's what you have. That's all. Okay, clear? So this is the mean value theorem, of course. Yeah, in turbulent flow also, when we are normalizing the curves, this mean value theorem of integration is greatly used. Okay, basically you might have seen integral t to t plus dt, u dash dt divided by dt, all these things you might have seen. Okay, so anyway, that's again a bit interesting things. So once you have this mean value theorem of integration, then you all know how to integrate the functions and all. I just like to give you one important integration. Normally when circles and all given in paths, this is helpful. X by 2 root of a square minus x square plus a square by 2 times sine inverse x by a. This is actually because I keep using this many times in my life, so that's why I've given you this. Okay, so normally let's see if you're analyzing any circular path. Okay, then you know circle is given by x square plus y square equal to a square, then y is equal to root of a square minus x square. So that integration will be in need so many times in your life, so I've just given you this. Okay, now I'll give you some properties of definite integrals which you can use to analyze. Properties of definite integrals. Properties of definite integrals actually. So let's see. So first, all of you know, I can flip the limits using a minus. Okay, and secondly, I can replace this guy always. Whenever you have this, you can always replace this with f of a plus b minus x. This is a this actually sometimes in many integrals this second point gives a drastic simplification. Okay, like at just before that it looks like the integration is unsolvable, but whenever you just imply this particular property, the complete integration gets converted to a simple integration actually. Okay, so this is a very drastic simplifying property which many times it holds, and which you all know, f of x dx is equal to 2 times integral 0 to a f of x dx if f of x is even 0 if f of x is odd, if f of x is odd function. Okay, so like for example, if I do minus pi to pi sin x, then definitely this value turns out to be 0, because even graphically if you see the sin x function, minus pi is somewhere here, 0 is somewhere here, pi is also somewhere here. This is how the graph comes out, minus pi to pi, and this area and this area cancels each other. Okay, so that's a practical thing actually. So this is what we have here. Good. Okay, so these are some basic properties which you keep in day in and day out. Also few more I would like to mention here. Integral 0 to pi by 2 sin power mx dx. This value can be calculated by m minus 1, m minus 2, m minus 3, and so on. This sequence or this multiplication goes until you get a 2 by 3 or 1 by 2, depending on this m is even or odd, into k. So what is k? K is 1 if m is odd, and k equal to pi by 2 if m is even actually. This is the reduction formula. Normally you can have this many times, you will encounter that again, integral 0 to pi by 2 sin power sin square sin cube sin power 4, whatever they want they'll ask you. So in this case you can also understand something, sin power mx dx is also same as sin power nx dx, sorry, cos power mx dx. Okay, again as I told you, this happens because of this drastic simplification. Okay, so that's what. Also I'll give you the product combination 0 to pi by 2 sin power mx into cos power nx dx is equal to m plus n into m plus n minus 2 into and so on 2 or 1 depending on the things, then m minus 1, m minus 3, and so on 2 or 1 again, into n minus 1, n minus 3, and so on 2 or 1 again. This value multiplied with k, where k is pi by 2 if both m n are even, and this is 1 otherwise. Normally this pi by 2 and 1, how it comes I'll show you in just some 5-10 minutes. We talk something about gamma and beta functions. Okay, so again gamma functions are most frequently asked topic in XE. So gamma functions and beta functions is again one certain important thing, so we will use it there. Okay, beta function form में भी लिख सकते हैं, हाँ correct. Normally if you see this, we'll see anyway when I'm teaching you beta functions next time I'll see, but if some of you want I'll give you the expression. Okay, fine. So that's what the beta function, but first of all to understand this formula you should know what is this beta. Okay, so let's solve some questions which could help you actually. This we'll solve later. Come on, solve this question, tell me what is the answer. I'll conduct a poll again. So numerical answer type, integer type I'm giving. Okay, so integer type I'm giving, and yeah, maybe some 90 seconds. Okay, good. Come on, solve this. Integral minus 5 by 2 to 5 pi by 2 f of x dx, where f of x is e power pi x square sin cube x plus 4 cos x. Okay, how many of you are here for the okay, finish the poll, I'll ask you. I'm telling you again and again, if you attend thoroughly, okay, and if you keep in touch with this 2 days and also this week with us, pakka I'll make sure that you'll at least get some 10 to 12 marks. Okay, next 16 is the answer. पता नहीं मुझे, solve करके देखना है. Minus 5 pi by 2 to 5 pi by 2. ठीक है, that will go down. Then after 5 pi by 2, 4 plus 4, 8, 8 into 2, 16. I think 16 could be correct. Yeah, 8 is coming. I am doing mistake somewhere. 0 to pi by 2. Sin x dx minus cos x pi by 2 0 1. So one loop is 1. So 5 pi by 2 to 5 pi by 2. So basically there's a 4 pi complete interval. No, 2 pi plus pi by 2. So I think 2 pi plus pi by 2 gives you 5 2 pi. Okay, anyway, we'll solve. Okay, so let's see. Okay, 8 is the answer. Let's check it out. 8 or 16, because some of you are typing 16. So integral minus 5 pi by 2 to 5 pi by 2. This is also a previous x equation. Pi x square sin cube x plus 4 cos x dx. Okay, now if I split this, this becomes minus 5 pi by 2, 5 pi by 2 e power pi x square sin cube x dx plus integral minus 5 pi by 2 to 5 pi by 2, 4 cos x, 4 I am writing outside, cos x dx actually. Now straight away this guy goes to 0, because why this goes to 0? Pi x square is even function, this part is even function, but this is odd. If sin x is odd function, then definitely sin cube x is also odd function, because it's odd power. Let's say sin of minus x is minus sin x. If you raise power 3 on both sides, still you will get a negative sign. So this is the odd function, that goes to 0. So 4 into, using 2 times of this property, I can write as 8 into integral 0 to 5 pi by 2 cos x dx actually. Okay, so this is what you get, 8 into integral 0 to 5 pi by 2 cos x dx. If you integrate this 8 times minus cos x within the limits, minus sin x within the limits 0 to 5 pi by 2 actually. Okay, so minus 8 into sin 5 pi by 2. So 5 pi by 2, if you see 5 pi by 2 is there, no? Yeah. So if you have 5 pi by 2, so what is sin 5 pi by 2? This can be written as sin pi by 2 pi plus pi by 2, correct? So you can write this actually. So sin 2 pi plus pi by 2. So 2 pi plus pi by 2, that's again comes to the first quadrant. So sin pi by 2 is 1, minus of sin 0 is 0 actually. So you are coming, it's coming out to be minus 8, right? Minus is coming. Integration of cos, this is plus sign. Yeah. So then definitely this is plus. Yes. Integration of cos is sign, no? Yes. Okay. Correct. 8 is the correct answer. Okay. Yeah, because integration of cos should be sign. Okay, because derivative of sin is cos, obviously. Sin positive hoga, pakka. Correct. So 8 is the correct answer. Let's see. कितने लोग ने solve किया? 75%. Nice. Ram Prasad, Sushmit, Sagar, Vinit, Deepak. Good. Fine. 8. एक क्वेश्चन भी बनते हैं यहाँ से, देखिए. Okay, I think I have closed results leaderboard. If you see, ranked up Sushmit Gupta. Fine. I'll announce the leaderboard after some 10-15 seconds. After every 15-20 minutes, I'll announce the leaderboard. Newly joined. Nice. Okay. Good. So let's solve one more question on integration, if time permits. Yeah. Come on, solve this question. The value of I is dash. Integer type. I am giving you 3 integrals nikalne. So I am giving you 150 seconds. Come on, solve this. I is a constant, okay? Square root of minus 1, that's a constant. So please solve. Let I is equal to integral 0 to 1, 1 by 1 plus t dt plus pi I by 2 into integral 0 to 1 e power I pi t by 2 divided by 1 plus e power I pi 2 by t dt minus I into integral 0 to 1, 1 by 1 plus I t dt. Solve this. All these questions are some nice XC questions, okay? PYQs, of course. So I am in 3rd year getting 50 plus marks in GATE ME. What should I do now? First of all, finish final year, then give one more attempt in final year, okay? If it's something very close to 60 or 65 beyond, then definitely you have good chances for everything. Okay, Jatin? Shall I solve this question? Sorry. Come on, already 1 hour 15 minutes. We have to be fast. If it's late, I'll keep you guys awake for till 3 AM. Okay, which we don't want, correct? Why minus? Here. Minus is not there, okay? In last question. Fine. Okay. So, meanwhile, by the time Poland you keep attempting, I'll solve this question. I is equal to integral 0 to 1, 1 by 1 plus t dt plus pi I by 2 into integral 0 to 1 e power I pi by 2 t by 1 plus e power I pi by 2 t dt minus I times of integral 0 to 1 by 1 plus it dt actually. Okay. Now let's simplify this. This integration is directly ln 1 plus t within the limits 0 to 1, which actually gives you ln 2. Okay. So this is ln 2 minus log 1, which is 0. That's all. Okay. So ln 2 is what you'll have here. Now coming here, plus pi I by 2 into, try to understand something. If I send this pi by 2, I pi by 2 inside, okay, 1 into I pi by 2, I am sending it inside. If I send this pi I by 2 inside, this numerator is nothing but the differentiation of this denominator. So no, correct? Because if you see, if you differentiate this, differentiation of 1 is 0, derivative of e power something is e power that thing into this inner derivative is pi by I into pi by 2. Okay, so this complete numerator is the differentiation of denominator. So ln 1 plus e power I pi t by 2 within the limits 0 to 1 minus. Similarly, again if I send this I inside, this is ln 1 plus it within the limits 0 to 1. That's all. Okay, simple differentiations. So let's see, ln 2 minus 0 plus this pi by 2, pi I by 2 is not there now because I have just eliminated. This is completely the differentiation inside. Now when you put t is equal to 1, okay, so let's see, when you put t equal to 1, what happens? When you put t is equal to 1, this becomes I pi by 2. So ln 1 plus, what is the value of e power I pi by 2 cos pi by 2 plus I sin pi by 2. So this is I actually. Okay, so ln 1 plus I is what you will get, minus ln, when you put t equal to 0, this is 2 of course, minus, coming here, when you put t equal to 1, we have ln 1 plus I minus, when you put t equal to 0, this is log 1 actually, okay, which is 0 of course. This expression is 0. Now try to understand this. This 1 plus I and minus of ln 1 plus I gets cancelled. Ln 2 and ln 2 also gets cancelled, and zeros also gets cancelled by default. So the answer is 0. That's it. Fine. So this is 0. Is it? Seriously? None of you are able to solve, or poll is not working? Did any of you enter 0? I think by the time poll finished, none of you entered, right? Now the poll is finished. Okay, fine. So this is basically 0. It's a straight value 0. Okay, so let's solve one more question. Fine, you have to answer this. Okay, integer type. I'm giving you only 90 seconds. No, 60 seconds I'll give you. Solve. लिमिट एक्सटेंड्स टू 0 1 by x. ठीक है, अब सॉल्व कर लो. लिमिट एक्सटेंड्स टू 0 इंटीग्रल 2 to 2 plus x t plus root of t square plus 5 dt. Solve this. Poll time was less. ठीक है, टाइम थोड़ा बढ़ता हूँ. लेकिन एग्जाम में माइंड फटाफट काम करना चाहिए, ठीक है, फास्ट, नहीं तो ऑल इंडिया 10 नहीं मिलेगा। डन, पोल स्टॉप्ड, चलो आई थिंक ओनली 1 or 2 to 3 people were able to enter, good। so let's see guys, ये बहुत इंपॉर्टेंट क्वेश्चन है, देखिए, if you keep x equal to 0, this integration is from 2 to 2, okay, so whenever limits of integration are same, okay, if limits of integration are same, then definitely this numerator will be 0 and x is also 0 here, okay, see, I'm just giving you a simple hint, if you put x equal to 0 here, this lower limit and upper limit becomes same. If you integrate a function and if you keep same limits of integration, then definitely there is no span, answer is 0, okay, so this x is 0, so it's 0 by 0 form, applying L'Hospital, applying L'Hospital actually, okay, now if you apply L'Hospital, this is limit x tends to 0, so first differentiate this, I told you how to differentiate an integration, okay, Newton-Leibniz rule, so apply, if you differentiate this, let's see, d by dx of this function, so 2 plus x plus root of 2 plus x whole square plus 5 into, because wherever there is t you have to replace with 2 plus x, okay, into differentiation of this function with respect to x, which is 1, minus at 2 you keep this, and also differentiation of 2 gives you 0 anyhow, okay, so this value divided with here differentiation of this is 1, that's all, okay, so if you put x equal to 0 in this, we have 2 plus root of 2 square plus 5, which is 4 plus 5 is 9, square root of 9 is 3, 2 plus 3 is 5, that's all, so 5 is the correct answer, okay. So where we will get this pole, just enter in the chat box, okay, if you enter in the chat box before the pole limit, then definitely your response will be taken by the pole, okay. How many of you enjoyed this question? Simple question, no? Just 5 is the answer, so let's see 5, अब देख लेंगे, I think only 2-3 people attempted before the poll time ended, Sanket, Vinit, Sushmit, nice, 55 seconds, 60, good enough, but if you have the concept to solve this, hardly it takes 1 minute, okay, or 1.5 minutes, fine. So let's continue our discussion. So some problems like this I'll go, okay, so some theory and some problems, we have a mix of these things, okay, will that be okay to all? Fine, we will solve some, we'll learn something, then we will solve some problems, then again we'll learn something, and this sequence goes on, okay, because I know if I keep teaching the theory purely, then definitely it can't happen. सर आप यूपीएससी सीएससी का प्रिपरेशन करते हैं क्या? नहीं, फाइन, poll in the PW apply by, you can just enter in the chat box, okay, if you enter in the chat box before the poll time ends, then definitely your response will be taken by the poll, okay. So let's see gamma functions, gamma function, okay, so you know, like gamma of n is how it is denoted, integral 0 to infinity e power minus x into x power n minus 1 dx, this is f of x actually, okay, so practically this is the values what you have. Normally you have tables, okay, gamma function tables is what you have. Whenever you have integers, you can get the answer easily, but whenever this is some, you know, let's say for example 1.5, 1.8, things like that, you have to go for numerical integrations, okay, but anyway this value is finite because this guy is, you know, very it decreases very fastly, okay, e power minus x, exponential decay is there, so that's why this combination is always some finite value, fine. So let's see, this value is actually equal to n minus 1 factorial if n belongs to natural numbers, okay, and normally if you calculate these values, gamma function, this gamma of n plus 1, oh sorry, gamma of n plus 1 can be written as n times gamma n, which you can see basically from this, your n factorial, for example if I have integral 0 to infinity e power minus x into x power n, okay, dx, this is equal to n factorial, this is actually gamma of n plus 1, so this is equal to n factorial, of course this n factorial can be written as n into n minus 1 factorial, and this n minus 1 factorial here can be again replaced with gamma n, that's all, okay, so n times of gamma n is what we have. So that's why basically this property holds good. Okay, and integral, else I would like to say whether gamma of 1 by 2. This is a very important guy. Okay, so this is square root of pi. Gamma of 1 by 2 is equal to square root of pi actually. Okay, it looks very little to see, but actually to prove this you need 2-3 pages. Okay, because normally this is calculated from polar coordinates by applying e power minus x square plus y square dx dy. This is the integral. Of course you can do conversion Cartesian to polar, and you can deal it a bit carefully, because this can be written as integral 0 to infinity e power minus x square dx, integral 0 to infinity e power minus y square dy. But actually these two guys are same, because just the limit, I mean the variable difference. So this can be written as e power minus x square dx, 2 on the top. Okay, so basically evaluating this integral and taking square root gives you this value, and this if you keep x square is equal to t substitution, you will finally end up with gamma of 1 by 2. Okay, so this business you have to do, but right now we are not doing that. So this value is actually square root of pi. Okay, so let us solve this question. Straight away hint, solve this question and tell me what is the answer. I'll give you some options for this if needed. Okay, so 120 sec, no, 120 will be huge. Okay, fine, I'll let me be some kind people. Come on, I've given you 120 seconds. If you get the answer, you can enter. Gamma of 1 by 2, yeah. What is integration? Don't go on guessing basis. Okay, please solve. I've given you some time. You can work out. Guessing doesn't work in gate normally. Okay. Ashik, you told A, then B, then C, then you want to say D. Babul, Fatihah, B. Chalo, do this. Okay, so by the time poll ends, I'll also solve this. So basically, whenever there is a minus in the square root, but we are dealing with real functions, we'll try to eliminate that minus sign. Okay, so let minus log t to the base e is equal to x actually. Okay, so t is equal to e power minus x. That's what we have. So t equal to e power minus x. If t, this is the value, then what about lower limit? In definite integrals, whenever you are making substitution, limits also should be changed. Okay, so minus log 0 to the base e. This gives you x is equal to infinity. X tends to infinity. Okay, because log 0 is minus infinity, so minus of minus, that gives you plus. Upper limit minus log 1 to the base e. So this implies x is equal to 0. So therefore, this integral 0 to 1 dt by minus root log t, square root of minus log t to the base e is equal to lower limit got infinity, upper limit got 0. Then this value is 1 by root x. What about dt? If you differentiate this, dt is equal to minus e power minus x. Okay, so now what you'll do using this minus, let us swap these limits. So by eliminating this minus sign, we can write this integral 0 to infinity e power minus x into dx is also there. Okay, here dx is also there. So this value is into 1 by root x. 1 by root x can be written as x power 1 by 2 minus 1 dx, and this is nothing but gamma 1 by 2. That's all. Okay, clear? Simple. One substitution, everything gets clear. So correct answer is, as many of you anticipated, it's A, 55.44%. Okay, Ashik, fine. Sanak Banerjee, unknown, Sanket, Sushmit Gupta. Let's see the leaderboard if you want. Yeah, good. Sushmit is on the top. Yeah, okay. So let's see beta functions. Let's talk a bit about your beta functions also. That could be helpful. Beta functions. Beta functions. Okay. If it's a full-time descriptive course, I would have shown you how this value is square root of pi. Okay. Basically, I would have done this and I would have shown you, but it's okay. Fine. So let's see beta functions. Beta function of m comma n is normally in this format: 0 to 1 x power m minus 1 by x plus 1 whole power m plus n dx actually here. Okay. And you will surprisingly find out if you do little analysis, if you apply that formula a to b is equal to integral a to b f of a plus b minus x dx, if you apply all those things, you will find out beta of m comma n is actually equal to beta of n comma m actually. This can also be written as 0 to 1 x power n minus 1 divided by x plus 1 whole power m plus n dx actually. Okay. So if you interchange m and n, the value turns out to be same actually in case of beta functions. And beta of m comma n is normally given by gamma of m, gamma of n divided by gamma of m plus n actually. Okay. And normally if you see, if you take this integral, firstly I will give you integral 0 to pi by 2 sine power p theta cos power q theta d theta is equal to half times of beta of p plus 1 by 2 comma q plus 1 by 2 actually. Okay. And obviously if you take this m and if you take this n and if you apply this, what happens here, I'll just tell you one important thing. Look, for example, if I want to calculate gamma 7 by 2, okay, so what is this value? If I want to calculate this, how would I calculate this? So level of questions is very high in XC. So whole syllabus revision होने वाला क्या पक्का, इसलिए इसका बोलता है कि Maha revision. Okay, level of questions is very tough. Tough नहीं है लेकिन थोड़ा सा presence बस. Okay, fine. So let's see how to get this value. You can write this as 5 by 2 plus 1. So immediately you can write this as 5 by 2 into gamma of 5 by 2. Okay, this can be written as 5 by 2 into gamma of 3 by 2 plus 1. So you can write this as 5 by 2 into 3 by 2 into gamma of 3 by 2. Okay, so 15 by 4 into this gamma of 3 by 2 can be written as 1 by 2 plus 1. So 15 by 4 into 1 by 2 into gamma of 1 by 2. Okay, and gamma of 1 by 2 का value है हमारे पास square root of pi. So this is 15 root pi by 8. Okay, so this is the value. Means if you numerically calculate integral 0 to infinity e power minus x into x power 5 by 2 dx, this you will end up with 15 root pi by 8 actually. Okay, so that's what the meaning actually. And 15 by 8 root pi, of course 15 by 8 root pi. So normally if you see in integrations I have given you, let's say for example this is also giving you 1 by 2 and this is also giving you 1 by 2. That happens only when this p and q are even numbers. Okay, see I'll just give you one small connection. Look, anyway p plus 1, if p and q are two integers, let's say for example 2, 3, things like that, p plus 1 will be odd number. See, if I add this is the case. For example, sum of two even numbers is even, sum of two odd numbers is also even. So whenever these two are odd numbers, for example, then this complete term gives a even and here you will get a integer. But individually these two will be left with 1 by 2 and 1 by 2. That's why root pi by 2, root pi and root pi, when you multiply you will have pi by 2 actually in one of the options. Okay, when both are even. Otherwise you will have, if both are odd or if one of them is odd, that root pi will not be there, it gets cancelled between numerator and denominator. So you'll have just a constant 1 in the integration. Okay, so that's why if both p and q are even numbers, you'll have pi by 2 in the k value. If one of them is odd or both are odd, you'll have only 1 basically. Okay, now let us see some small bit of applications of integration. Applications which are very, applications of integration. Questions comes from here. They'll ask you length of the curves, all these things. Applications of integration. Single variable integration. Firstly we are dealing single variable, then we'll go for multivariables, then we'll see moment of inertia, polar moment of inertia, centroids calculations, all these things we'll see. So right now if you see applications of integrations, firstly undoubtedly you can calculate areas. Like for example you have two curves. Okay, and let's say I want to calculate this area which is bounded. Then this is f of x, and let's say this is g of x. Then if this point is a and this is b, then this shaded area a is nothing but integral a to b f of x minus g of x dx. Okay, and for this formula to be valid, definitely your f of x should be above this g of x. Clear? So let's see, for all, you know, f of x is greater than g of x actually. Okay, why? Because if you don't consider this, initially you will get the area under the top curve. If you consider only g of x, you will get area under the bottom curve. If you subtract those two, then only you will get the bounded area. That's what. Okay, now let's explain again. I mean, this one you're talking about, this, not this, sorry, yeah, this one. See, I'll tell you, even, then what happens? This becomes even, okay, because this is m. Okay, so this is m and this is n. So if both these are even, this complete thing becomes an even number. Okay, you won't have a matlab, it is exactly divisible. This 2 p plus q plus 2 is exactly divisible by 2, and you don't have any 1 by 2 here. Okay, and here also you won't have any 1 by 2s. Then definitely, you know, we have square root of this. If p is even, then p plus 1 is odd. P plus 1 by 2 gives you a 1 by 2. Okay, so in this you will have root pi by 2. In this also you will have root pi by 2. So both gets multiplied and it becomes pi by 2. Okay, but let's say in any of the other cases, you will see whatever is 1 by 2 getting, you know, left here, that same 1 by 2 also gets left here. Understood? Like for example, in this way, you can see this root pi is getting left here, na? So like that, if one of them is odd or if both are odd, root pi gets left here and they'll get cancelled. That's how k is equal to 1 in the definite integral. Okay, so this is areas. Then calculating length of curve. Calculating length of curve. How do you calculate the length of a curve? One of my BARC interview questions also. Okay, x is equal to a, x is equal to b. Okay, now let's say this length is L, for example. Okay, this is b minus a, for example. Okay, so b minus a, you take it, b minus a. Then you take a small portion ds. Okay, for a very small portion of the strip. Okay, so can you share my Telegram channel? Huh? I can share what song? My Telegram channel is t.me/pw Vinay sir. That's all. This is my Telegram ID. Okay, so anyway, coming here, first of all, if you want to calculate the total length, what you will do is you take a small part of it. Okay, so you take a ds initially, ds. So what is the ds? Some small portion of the length. So if you take ds like this, for example, I can resolve this ds always. Okay, dx and dy actually. Dx is the projection of ds onto x-axis. Dy is the projection of ds onto y-axis. Okay, now for a small length, very small length, you can connect it with a straight line. So if you can connect it with a straight line like this, okay, so if you connect it with a straight line, then ds is approximately equal to dx whole square plus dy whole square, Pythagoras theorem. Okay, then if you want the total length, you have to integrate it between x equal to a and x equal to b and x equal to b. So therefore, integration of total length gives you the total length L is equal to integral a to b. For example, if I take dx common, okay, dx whole square common, I will be left with root of 1 plus dy by dx whole square dx. That's all, because square root of dx whole square gives you a dx. This is how the length is calculated actually, simple length. Ganesh, right now maths standard increased. See, basically, I'm telling you one thing. I always tell you, if you learn 1 hour in class, you should definitely work out for one and a half hour more in outside. Okay, using some PDF or something. Okay, you should practice. You should open textbooks, because when I teach concepts, you will understand it. Later, you will forget many points. Okay, so that recollect should be there. Clear? Basically, it's like leaving and forgetting. Then it's not good for both of us. Okay. PDF will be available in Telegram group. Okay, I'll upload, no issue. Okay. So let's see. This is the length. Similarly, if you calculate surface areas, all these are simple applications. You might have seen them many times in engineering mechanics. Surface areas of solids of evolution. Solids of evolution actually, okay, surface areas of solids of evolution. Like for example, you have this xy axis, okay, and you have a curve y is equal to f of x. This is the curve. So let's say this is x is equal to a and this is x is equal to b. Then definitely when you evolve this curve about x axis, let's say you are evolving okay, if you evolve this curve, then what would be the surface area actually? So that you can get it from integral x equal to a to x equal to b again. So if you take a small strip, ds, and if you evolve that small strip, for example, okay, let's see, for example, if you have a strip like this of small thickness ds, okay, so this is ds, then you can understand something. You can feel something that this part is one face of this and the other part is also there, okay. So this disk is of, let's say for example, if this is function y equal to f of x, so at some random value of x this is y, then this is actually y. So this circumference is actually 2 pi y into ds, so 2 pi y into ds actually, and this you can write as integral x equal to a to x equal to b, 2 pi y into root of 1 plus dy by dx whole square ds. That's all. Yeah, cylindrical strip. Maths book for reference, I would say 𝐵𝐴 could be good. Okay, 𝐵𝐴 as of now for gate. Clear? Okay. Yeah. So let's see one more thing. Volume. If you're going to calculate volume, we in actual case this is something like a to b pi y square, because if you take the volume of this guy, this cross sectional area of the disk is pi y square multiplied with ds, so pi y square into root of 1 plus dy by dx whole square dx. Okay, but normally in case of majority of the solids like cone and all, this value is very small as compared to 1. So we ideal what they give you is something like integral a to b pi y square dx is what they give you. Okay, in gate exam please use this one, okay, because this is the actual expression, you can clearly understand ds into the volume, but this is basically Rakesh, volume of evolution का formula है. हाँ. So will there be back exam practice by gate wala and your faculties? The exam is next month and last year it came tough. No, I think back is like almost the same level, since because I generally see of course people keep sharing the questions and all with us on a regular basis, so I think it's fine. Okay, but anyway, this is how you can calculate the surface area, volume and whatnot, length, areas, everything you want. Okay, so anyway, let's go for single variable calculus has taken certain time, so let's go quickly for multi. Okay, in 20 minutes roughly we can finish off multivariables and we'll have some relaxation. We'll talk about linear algebra. Okay, because if I started with hi Amna, look, so let's see one of my old friend. Okay, so we'll look at multivariable calculus. Okay, so we'll see multivariable calculus. So in polar coordinates basically you can convert. Okay, sir, can you share your number at the end of the class? No, I cannot share, sorry. Fine. Anyhow, you have the Telegram channel, no? So you can get in touch with me there. In fact, you can get in touch in any one of with us. Okay, so multivariable calculus. So whatever I told you till now is for single. Okay, conversion, that's it. Okay, someone want conversion about polar coordinates, I'll just tell you. I'll take a moment to talk how to convert not only polar, any system actually. Okay, so let's see, if you have a function, for example, in multivariables I can talk about, but anyway, if you just see, if you have a function like this, you are integrating over some area A. Okay, there is some domain on which you are integrating. If you make any parameterization, okay, polar coordinates is just one special way of parameterizing, but normally in general, if you have any characteristic form, x is function of u comma v, v is also function of, or y is also some function of u comma v. Okay, like for example, you know, when you are doing polar coordinates, you assume r cos theta, y equal to r sin theta. Okay, you know this. So this is basically some function of r and theta, and this is some function of r and theta. Okay, so this is also some function of r and theta. Now if you see this value, if you want to convert in terms of u comma v, anyhow you will manipulate the domain because the domain remains same. So a into this function can be written as r comma theta. This elemental area can be replaced. Okay, I'll just write the general form u comma v. This can be written as du dv, and here comes the Jacobian value. Okay, so what is the Jacobian? Let's see. This j is called Jacobian, which some of you might have studied rather. Jacobian. So this Jacobian value, determinant of Jacobian, is nothing but when x is depending on u and v, this becomes dou x by dou u, dou x by dou v, dou y by dou u, and dou y by dou v actually. Like normally in case of this polar coordinates, it comes out to be r actually. Okay, Jacobian value comes out to be r. I'll show you anyhow. If you calculate determinant of Jacobian, det of dou x by dou r, this gives you cos theta, dou x by dou theta minus r sin theta. Okay, then this value with respect to r gives sin theta, and this is r cos theta. So if you simplify this determinant, r cos square theta minus of minus plus r sin square theta. So r times of cos square plus sin square, this gives you r. That's why in all these integrations you'll write it f of r comma theta r dr d theta. Okay, basically this r comes from this Jacobian. Okay, see, I've seen many times in exams people waste time. They feel like this is here and this is here, means they're always confused between these two things. Can anyone tell me out of these two which is correct? Can anyone tell me out of these two which is correct? First or second? I've already used first, so first is correct. Yes? Yes or no? Both are correct. Okay, because determinant of a matrix is same as its transpose. Okay, so in exam don't waste time. Whatever the way you like, you put it and calculate the determinant if you want to replace. Okay, clear? Let me have some water here meanwhile. Yeah, both are correct. Okay, because this is just transpose of this. Both give same result, no? It is transpose. Yeah, exactly. Okay, so in exam don't spend time on deciding what to put on horizontal rows and columns. Okay, you put anything, but do the calculation correctly. Okay, then you'll get the correct answer. Chalo. Anyway, this is a part of multivariable calculus only. Again, you can even convert to spherical if you want. R cos theta sin phi, R cos theta cos phi, R sin theta. If you have this, then you can convert even for spherical. But anyway, just some basic idea. Multivariable calculus. So calculating limits. Again, same story. Let's say if you have limit x tends to 0, y tends to 0, x square minus y square divided by x square plus y square, for example. Let's say I have given you this value. Okay, so when I give you this value, you can understand something. If you have a plane x and y, and let's say z I am plotting outside of the board. This is z, right-handed coordinate system. If z is coming out like this, then such a polar curve का volume of evolution पूछे तो just convert. Okay, I have told you now how to convert. Any integration using any dx dy you can convert always. Fine. So let's see. Here you have this point. Okay, so this is origin, and you are somewhere in space, for example. Then if you want to approach origin, there are n number of ways. For maths, I think in no, not yet. Okay, so anyway, very soon it happens. I'll start some maths course on YouTube channels after getting proper intimation from my team. Okay, so what we are talking? This limits. So what we'll do is, see, let's say if this is the point origin. Now if you take the neighborhood of this origin, you have a sphere. Okay, you can come to this origin from, or basically in this plane. If you see, in this plane you have a circle. This is a neighborhood. You can start at any point and you can come towards this in n number of paths. Okay, so what we'll do is we'll take a random way, limit x tends to 0, y tends to m, or limit y tends to mx, limit y tends to mx, and x tends to 0. M value can be arbitrary, okay, because let's say you are somewhere here and you are pursuing this horizon along the first line and also along the second line, then definitely these two have different values of m. Okay, ये वाले का आंसर -1 होगा. Actually limit does not exist. I'll show you. Okay, just a minute. So see, look, in this neighborhood these are two possibilities. This is my point. I can travel basically here like this, or basically in any paths. In I'll have basically some n number of paths. I can even connect a parabola, things like that. So let's see if you calculate along this limit, x square minus m square x square divided by x square plus m square x square actually. Okay, so let's see, limit y tends to mx, or anyhow we have converted only to x. So limit x tends to 0, x square times 1 minus m square by x square times 1 plus m square actually. If you cancel this, you are left with 1 minus m square by 1 plus m square actually. Okay, and this value is not unique. It depends on m. It depends on m. Means if that value is depending on m and m is depending on path which I am following, this limit is not unique. Like for example, in single variable case you have only two paths, left hand limit and right hand limit, but here you can have n number of paths from a particular point to each here. Okay, so therefore it depends on the path what we follow, so therefore this limit do not exist. Clear? Okay, so limit does not exist. Got it? Yeah. Similarly, all the continuation and all continuous, everything is same. So differentiations, basically if there is a function f of x comma y, in this case we go for partial differentiations. These are the normal syntaxes which we denote, or it can be dou by dou x also. Even if you flap, nothing changes for a smooth function, of course. Okay, so these are the things. Okay, and I hope you know how to do the partial differentiations. Okay, all of you know how to do the partial differentiations. I'm not stressing much. Okay, so please type in the chat box. Are you all aware with this partial differentiations? All of you can do it, right? Let's say for example, if I give you some function and if I ask you any of those 5 quantities, I hope all of you can do. Okay, so I'm not stressing much. Okay, now also there is a concept of total derivative which is basically important. Total derivative, which we normally do many times in fluid mechanics. So let's say you have a function which is depending on some variables x1, x2, x3 and so on. Say xn, it depends on some n number of variables. So when this function depends on n number of variables, if you calculate the total derivative of this is summation dou f by dou xi into dxi. That's it, correct? Because if you just expand it, you'll yeah, I hope all of you can do the partial differentiation. But so let's see, if you just expand this is normally called the initial notation, which we can do. So if you see, we have something like dou f by dou x1 into dx1 plus dou f by dou x2 into dx2 and so on, plus dou f by dou xn into dxn actually here. Okay, so this is some of the partial derivatives. Basically, can anyone tell me what is this? What does this term physically tells you? Look, I'll just give you some basic idea. Whenever a function is depending on these things, let's say for example you have temperature. Okay, so temperature is depending on specific volume and pressure, for example, any function in general. So whenever this temperature is depending upon function and potential, or basically current, function of voltage and resistance, things like this, you have a number of things. So let's see, if I want to calculate the change in total temperature, this total temperature, let's say for example you have a field. Okay, fine, let's say you have temperature is dependence on V and P. This gives you change in temperature due to volume plus change in temperature due to pressure, correct? Because when this quantity is depending on these two, definitely change of any of this can actually give you the change in dt. But when things are changing simultaneously, it's not easy for us to calculate the collective change of all the quantities at a given time. So what we do, we will try to calculate the effect of each parameter on this t and then we will sum up. That's what this is basically. Okay, whenever you all know, whenever if I ask you dou f by dou x1, that means you treat x2, x3 and so on xn are constants, correct? You make this assumption. Similarly here, you will make x1, x3 and so on xn are constants. So this term actually gives you the gradient of f in that particular direction multiplied by the change in the direction value. That's it. Okay. Did you understand physically what it's actually telling you? Means let's say if you have xy coordinate system and let's say you are moving from this point to this point. Let's say this is x and this is y, and this is the change in x and this is the change in y, for example. And let's say there is some function which is changing on both dependence on x comma y. Normally if you have unsteady conduction, then temperature is actually different at different locations, and two-dimensional conduction. So then the change in temperature because of moving from this point to this point is actually written in component space. Temperature gradient along x direction into dx, that gives you this vector, plus temperature gradient along y direction into dy, that gives you this vector. So this is basically sum. That's all. Yeah, gradient times the certain direction. That's all. Okay, nothing complicated stuff. So let's see. Let's pick into one very important theorem, which is Euler's theorem. So first of all, before going for Euler's, I would like to give you homogeneous functions. Homogeneous functions actually. Okay. So what is this homogeneous functions? Let's check it up. If you have a function f of x comma y, this function is said to be homogeneous of degree n. Homogeneous of degree n if f of kx comma ky is equal to k power n times of f of x comma y. I will just give you with an example. If you have x cube minus y cube by x square plus y square, let's say, then definitely this function is a homogeneous function of single degree, because if you replace x with kx and y with ky, you can take a k common. Okay. So what will be the duration of Maha divisions? Actually complicated question, but guys, I want to ask you, you should actually confirm this. My plan for today, to be honest, frankly speaking, with heart, is until I finish this, I am not going to stop. That's the plan. But don't worry, calculus is a heavy module, so that's why I'm, anyhow, sequences and series also I'll do in the next class, basically in tomorrow's session, because some nice questions I'm framing on the way. So by tomorrow they'll get typed and we can work out. So this calculus is done after multivariable. Then this takes a short time comparatively. Vector calculus and complex calculus have very small syllabus. Okay, so hopefully by 11 o'clock or 11:30 we can end, no issue. Okay, because someone is much interested to know what is the duration. So because tab theek hai na, 11:30 or 12 maximum. It's not like morning 3 AM 4 AM. No, I understand the importance of sleep and biological cycle, so I don't want to disturb that. Okay, as I told you, 5 to 6 hours. We started at 6, so maximum will go up to 12. Even then after, if something is left, we'll take it up in the next class. Okay, but I think nothing will be left. Okay, because now exam is only 4 or 5 days. At this point, if you feel of your own comfort, then things don't happen in a positive way. Okay, so anyway, let's see. Let's see. Where is this page? Let me pull it down a bit. Here, yeah. So if you see, this function is homogeneous of degree 1. Of degree 1. So what is so special about these homogeneous functions? That's the next question. So if you see, if f of x comma y, or any number of variables actually, is homogeneous of degree n, then summation xi into dou f by dou xi is equal to n times f. I would like to better write this as f of x1, x2 and so on xn, okay, is a homogeneous function of degree n, then summation xi times dou f by dou xi is equal to nf. So अब तो नींद भी नहीं आती, कल मैकेनिकल एग्जाम हुआ ना, so definitely नींद नहीं आएगा, because XC is also coming close. Sir 27 for mechanical papers is sir, but lack of practice. Yeah, practice बहुत important है गेट के लिए, ठीक है. क्वेश्चंस प्रैक्टिस भी होते हैं ना, Euler's theorem on partial derivatives. Yeah, basically this is called Euler's theorem on partial differentiation. Euler's theorem actually. Okay, and normally you can extend this using Taylor series for multiple, for even second order. But just if you see, I'd like to give you, if f of x comma y is homogeneous of degree n, then x square dou square f by dou x square plus 2xy times dou square f by dou x dou y, or maybe dou y by dou x, plus y square times dou square f by dou y square. This is equal to n into n minus 1 into f actually. Okay, so n into n minus 1 into f, second derivative. Okay, so the second derivative gives you n into n minus 1 into f basically here. Okay, so sometimes what happens, there is a combination of functions basically. Look, I'll just give you a hint. Let's say you have a function f which is sum of three functions g, h, n. Okay, g, h, maybe I like m, I'll put m. Okay, so f is equal to g plus h plus m. Now if you apply this property, for example, let's say this function is of homogeneous of degree m, this is homogeneous of degree a, or basically n. M I have already used, na? So let's take some other v, for example. Okay, m, n and p. So these are degrees of homogeneity of these functions. Degrees of homogeneity. Okay, so if these are degrees of homogeneity, then what happens? If you do this summation, xi times dou f by dou xi, this can be written as, if I put f here as g plus h plus v, since summation can be broken at broken up at all plus signs, this is equal to xi dou g by dou xi, xi dou h by dou xi, xi dou v by dou xi actually. Okay, now as per Euler's theorem, when this function is homogeneous of degree n, this combination is equal to nf. Now similarly, if this function is a homogeneous of degree m, this can be written as m into m minus 1 times of g, n minus 1 times of h plus p minus 1 times of b. That's all. Okay, so summation is distributed. Yeah, summation can be distributed basically. So if you just split this summation over here, you can write these things. Okay, so anyway, you can have, similarly I would like to tell you one thing. If f of u is homogeneous, sometimes what happens, the function itself is not directly homogeneous, okay, but some function of that is homogeneous. Like, let's see example, I'll give you an example here. U is equal to tan inverse x cube minus y cube by x plus y. Let's say you have this, then clearly if you take only this part is actually homogeneous of degree 2, but tan inverse of that is not homogeneous. Okay, so unfortunately tan inverse of that is not homogeneous. Then what we should do, you can make this as tan u is equal to x cube minus y cube by x plus y. Now tan u is homogeneous, yes or no? So this implies tan u is homogeneous. Tan u is homogeneous of degree 2. Okay, so tan u is homogeneous of degree 2. So whenever tan u is homogeneous, what you can do is, I'll just tell you something. F of u, for example, okay, if you have f of u which is homogeneous actually, then x into dou u by dou x, because I have taken only two variables here to explain you, so I am writing this, plus y into dou u by dou y is equal to n times f of u by f dash of u actually. Okay, so n times f of u by f dash of u actually. So clear? How this happens is just, if you see, if f of u is homogeneous, I can write x into dou f of u by dou x plus y into dou f of u by dou y is equal to n times f of u is what I can write. Okay, now you take this guy's partial out. Differentiation of this function is f dash of u into dou u by dou x plus y into f dash of u into dou u by dou y is equal to n times of f of u. So what you're gonna do? You're gonna just divide this guy all over. It becomes a division here. That's it. Okay. So basically for this example, if you see, if I ask you this quantity x into dou by dou x plus y into dou by dou y, because if you don't know these properties now, differentiating this with respect to x partially and with respect to y partially is not very easy. Okay, it's a very complicated process. Okay, so that's why these things can actually help you out. Okay, so this is normally called f of u, capital F of u sometimes. Okay, and similarly, if you differentiate it one more times and if you do certain algebra, you will end up with x square dou square u by dou x square 2xy dou square u by dou x dou y square dou square u by dou y square. If you have this value is f of u into f dash of u minus 1 is what you'll have finally. Okay, normally I keep using these things many times, okay, day to day, so I remember all these things as a single go. But anyway, this is the basic idea of the homogeneous functions. Okay, and normally when you are identifying these relations and all, having homogeneity for a function is very important. Okay, because using simple results you will get this, like how in differential equations today itself we will see, when you have the basically this exact differential equations. Okay, when you have exact differential equations, solving those things are very easy. Okay, if something is not in exact form, we'll try to get it in exact form. Okay, by doing some manipulations. Okay, so similarly here, having homogeneity for a function is very powerful. Okay, fine. So I wanna tell you something now. It's been almost 2 hours. We started at 6. It's 8:05, 8:07 already. 2 hours has passed. If you wanna ask anything about general gate examination or anything in general, except my phone number, you can ask, because someone has asked me that recently. If you want to know anything from me, you can just ask it, because I understand continuous stretch things are slightly concept heavy, so I understand. But if you want to ask something, you can ask me. For 5 minutes we'll sort of do some gyan kind of this thing, and then we will continue. Class khatam? No. 12 AM. Okay. Normally if you have any doubts or regarding anything, you can ask. So maths important topics for GATE XE. I was marking star marks at some points. Okay. As we are going, I'm marking some star points at some locations. So please put some special interest on them. Speed and accuracy, how to avoid silly mistakes. Just practice. Okay. Practice से ही speed आता है, accuracy भी. सर बाग के लिए गेट सिलेबस सफिशिएंट है, पक्का सफिशिएंट, लेकिन इंटरव्यूज के लिए हाँ इंटरव्यूज के लिए सफिशिएंट है. आई कुड हैव बेटर इन एमई बट मेस्ड अप, नाउ अनएबल टू फोकस. ठीक है संदीप, व्हाट हैपेंड इट हैपेंड. ओके, इट्स नथिंग लाइक यू कैन अगेन गेट बैक. सर व्हाई डोंट यू डू रिसर्च? मे बी आई एम डूइंग, मे बी यू डोंट नो. इस ईयर में 505 गेट स्कोर पे क्या मिलेगा? 505, मे बी सम लास्ट IITs, very recent IITs, that too very recent branches. Okay, in order to have certain important things, basically to get some good branches in IITs and IISc, I think good score will be something around 700 and plus. Okay, मतलब 60 marks से ज़्यादा आना चाहिए पक्का. 65 could be safe side. हाँ, I told you ना 700 could be the good gate score. So subscribe बढ़वा दो, मतलब sir make a session how to master higher mathematics after GATE. Okay, practice questions can be provided or not, sir. I told you na. Meanwhile we are using some practice. See, for example, this is like a question. Okay, so you solve. In math it's never like the perfect theory than some question. Okay, आपसे maths पढ़ना है मुझसे? Yeah, you can learn, no issue. Okay, we'll start some session soon. Fine. You want me to give practice questions? Fine. So let's see. U is equal to x square minus y square plus 2xy. Okay, then calculate, or basically if I say if x into dou u by dou x plus y into dou u by dou y is equal to 2x square minus 2y square plus k times of xy, then k equal to dash. Now all of you will be able to tell easily, because it's a Taylor, it's a Euler's equation, okay, I mean Euler's theorem. But if you don't know Euler's theorem, then what you'll do is you'll practically enter these values and calculate dou e by dou x, dou e by dou y, all these things, okay, fine. I'm telling you now, for practice, what are the videos we have made, you can go through all those things, okay, or else you can easily download any of the previous year paper from Get official website, okay. I'm telling you, the key for cracking any exam is PYQs. If you don't solve PYQs, doesn't matter how effective you study, no, undoubtedly you cannot excel in that exam, clear. So PYQ is both important, and have well, basically has all paper, like if you see like 30, I won't say 30, rather 60 to 70% replicate from PYQs, okay. Maybe it's not directly from PYQs, but if you solve all the PYQs, you'll have enough knowledge for solving that year paper, okay. So 60 to 70% of the marks easily you can get if you are thorough through all the PYQs. As you yourself are telling na, sir, mechanical ka paper आसान है, लेकिन practice नहीं किया हमने. So that's the reason. Definitely, if you see, majority of you might not have solved all PYQs even at least once, okay. So that's why that's the mistake. So PYQs are the key for cracking any exam, clear. So chalo, we'll continue. Yeah, of course, this is 4. Just this has to be multiplied with 2 times of u. That's it, okay. So this is 2 times of 2, which is 4. Fine. Let's go to the concept of maxima and minima in case of multivariables. Maximum, this chapter will take 15 more minutes. Then after we'll go for linear algebra, okay, matrices. Then we'll again solve some questions, concepts, and whatnot, everything. So let's see maxima and minima. Maxima and minima actually, okay. So maxima and minima. So if you say maxima and minima in this case, if you have a function f of x comma y, okay, then again you do p dou f by dou x, q dou f by dou y, r dou square f by dou x square, s dou square f by dou x dou y, and t dou square f by dou y square actually, okay. Now as you know, the first variation, basically the first derivative should be 0 if you want to have maxima or minima. So equating p equal to 0 comma q equal to 0 gives stationary points, actually, okay. So this gives you stationary points actually. So stationary points can be again can be of any number depending on this function. So let x0 y0 be a stationary point, okay. So if this is actually a stationary point, then let's see what happens if you calculate this r at x0 y0, yes, at x0 y0, and also t at x0 y0. If you calculate this, then first, if r greater than 0 and rt minus s square less than 0, this implies f of x comma y has maximum at x0 y0, maximum at x0 y0 actually, clear. So it should have x0 y0. Similarly, if rt minus s square, sorry, if r greater than 0 and rt minus s square is actually positive, this implies minimum at x0 y0, okay. If r equal to 0, or basically you can say in all other cases you will end up with rt minus s square less than or equal to 0, saddle point. You have a saddle point, like it's the point of inflection in the first, in the single variable case. Here you have something called the saddle point actually, okay. Basically if you plot the graph at that point, you'll see it's like a horse saddle, that's it, okay. That's how the name came, saddle point. So depending on this, you will decide easily whether the function has a maximum or minimum or a saddle point and all. Anyway, tomorrow things could be little of shorter duration, so tomorrow we'll spend last 1-2 hours of maths for only solving problems, okay. No issue. Even now, after watching this video, tomorrow morning you can just go for this Abhyas batch of last year, which you can find out, okay. Now let's see, there is one important concept of constrained maxima and minima. constrained maxima and minima. This is also called, which is again one of the important topic for XC. This is also called method of Lagrange's multipliers. Method of Lagrange's multipliers. This is the last concept in differentiation. Of course, I'll give you also Taylor series. So after this, then RT minus S square should be greater than 0. So in first part, conditions are flipped. Is it? Let me check. Less than 0 maximum, greater than 0 minimum. Correct now? Didn't get you. RT minus S square should be greater than 0. Where? Here. Yeah, sorry. This is greater than 0. This is greater than 0. R less than 0. No, this is less than. Yeah, okay. Yeah, I think they are flipped. Correct. They got flipped actually. Now I hope it's correct. Okay. It's fine now. Yeah, because you know, in shorthand I have flipped them, but I think yes. R is what we check. Sorry, these got flipped actually. Yeah, correct. This is the correct condition. Okay. Yes, this is the correct thing, because you know, in shorthand I have flipped those notations, but actually this is the correct way of writing things. Okay. Basically, second derivative is what we'll check now. So this second derivative has to be checked. So this sign should be checked. Yes. Okay. Fine. So let's see constraint maxima and minima. I'll just straight away talk about an example. What is the answer? What is the answer? So please tell me. What is the answer here? The minimum value of x square plus y square plus z square when x, y, z are real numbers. They are real numbers. Okay. Then what is the answer? What is the minimum value of sum of squares? X square plus y square plus z square. Come on. Zero. Correct. Infinity. Hey, minimum. Yeah, not maximum. Minimum. Minimum value. Okay. Since all they are squares, so definitely they have to be zeros. Okay. So this is 0. But when if I ask you this question, is the answer still 0? If I put this condition on the variables x plus y plus z is equal to 1, अगर मैंने इस constraint लगाया तो इस equation के variables पे, then will it be still 0? Will it be still 0? No, correct? Because now I'm not supposed to take x equal to 0, y equal to 0 and z equal to 0, because if I take x, y, z is equal to 0s, then this equation will not get satisfied. Okay, so therefore this is basically the case of constraints, Lagrange's multipliers. So this is some function phi of x comma y comma z. This is the function to be optimized, means basically to be for which we calculate the maximum or minimum, and x plus y plus z plus 1. So let's say this is psi, for example. Okay, psi of x, y, z equal to constant or minus constant is equal to 0. So this is constraint on variables. Constraint on variables actually. So when this is constraint on variables, what we do? Look, I'll explain simultaneously. 3/4 is the wrong answer. 1/9 is actually correct answer. I'll show you how it happens. Okay. So see, to be optimized, constraint on variables, then we form f of x, y, z is equal to phi of x, y, z plus lambda times psi of x, y, z minus constant, of course. Okay, so this is what you have, and this factor which you are multiplying to the constraint is called Lagrange multiplier. Lagrange multiplier actually. Okay, so that's called the Lagrange multiplier. Now if you see how you'll simplify this, firstly first derivative has to be 0. Dou f by dou x is equal to 0. Dou f by dou y is equal to 0, and dou f by dou z is equal to 0. The first derivative has to be 0 actually. So let us take this example. If you take this example, then what you have, f of xyz is equal to x square plus y square plus z square plus lambda times of x plus y plus z minus 1. Okay, so let's say this is the equation we have. Now if you simplify this, if you calculate dou f by dou x, 2x plus lambda is equal to 0, 2y plus lambda is equal to 0, and 2z plus lambda is equal to 0 actually. So this gives you lambda is equal to minus 2x minus 2y minus 2z. So this actually gives you x is equal to y is equal to z, means the first derivative equal to 0 gives the relation between x, y and z. It's 1 by 9, sir, already said. It's 1 by 9, so I already told, no? Yes, correct. Sorry, I have already told. So see, let's see this. This first derivative equal to 0 gives you this relation between the variables. In case of Lagrange's multipliers, what happens is, see, equating first derivative is equal to 0 and equating lambda from different equations gives you what should be the relation between these variables such that this function is having minimum or maximum. Okay, and one very important thing, this method of Lagrange's multipliers is utilized only for those functions where there is either maximum or minimum. It's not like the function has a minimum at some point and also maximum at some point, then we can go for Lagrange's multipliers. Normally if you want to do that, you have to go for second derivative test and all, but within the gate syllabus limits, we deal only functions where we have either maximum or minimum. That's it. Okay, sorry, didn't get you. सर मैकेनिकल इंजीनियरिंग में थैंक यू सर, आपकी वजह से ATD वाला सब क्वेश्चन अच्छा है, ठीक है, थैंक यू, फाइन. सो x is equal to y equal to z. Now if you see, put this relation of the variables in this constraint equation. Okay, so put x is equal to y equal to z, जो relation आपको आया था इस constraint equation से. So in x plus y plus z is equal to 1 actually. So if you keep, you'll easily identify x equal to y equal to z is equal to 1 by 3. Therefore y basically minimum of x square plus y square plus z square is equal to, yeah, correct, it's not 1 by 9, 3 times of 1 by 9 actually, so which is 1 by 3. Correct, 1 by 3 is actually correct. Okay, because 1 by 9 comes in each term, so 3 terms of 1 by 9 are there, so 3 into 1 by 9, so that's equal to 1 by 3. Okay, so this is how you actually calculate using Lagrange's multipliers. Got it? Is the method of Lagrange's multipliers clear to all of you? Because session ki starting pe, I think someone of you have asked me. Did you all understand how we do the method of Lagrange's multipliers? Basically, you formulate the function 5 plus lambda psi, then equate first derivatives to 0. Once you equate the first derivatives to 0, you'll get the relation between the variables. Okay, so agar ek bar is relation mila hai to, so put this relation in constraint equation and then solve for the values of x minimum, y minimum and z minimum. Put it there, you'll get the answer. Okay, fine. Clear to all of you? Okay, I want to give you one more question. Maximum of xy plus 2xz plus 2xy when x, y, z is equal to 8. Let's say if you have this. Okay, so when x, y, z is equal to 8 and xy plus 2xz plus 2xy is dash. Okay, so solve this. Come on, I'm connecting a poll actually. You can enter the integer type. I'm giving you 150 seconds. Solve. Under some constraint equation meaning kya hai? Physical meaning, I'll tell you. You solve this question, you'll understand this. How to find a maximum in the same question? Infinity. Okay, I'll tell you how it's infinity. Just a minute. Please solve this. How many of you are listening maths for the first time from me? How many of you haven't seen me before teaching maths anywhere? guys, it is minimum actually. Maximum can be very large value, but minimum. For real symmetric matrix, nullity of A minus lambda and distinct eigenvalues is equal to linearly independent. No, I'll just tell you, Tushar. Just wait till when I reach eigenvalues. Next chapter I'm going to start is eigenvalues. Okay, just 10 more minutes. After solving multiple integrals, we'll start linear algebra. Okay. Yeah, Junaid Alam, I remember your name. Someone is asking me now what is the physical meaning of the constraint equation. I have some value, so I'll show you. Okay. Just a minute, some pop-up came actually. Let me delete that. Hey, where is this chat box? Good. Okay, so fine. Anyway, this got finished. So let's see. First of all, I want to tell you 116, 20, 20, 116. Okay, let's see. Okay, 16. Okay, not 20, 116, it's 16. Okay, let's solve this question. First of all, I told you, let's see the meaning. What is the meaning of this? Because someone has asked me for the meaning now, so let's see. Okay, so let's say this is a box. Let's say this length is x, this length is y, and this length is z. So I want to make a box such that material required for the box is minimum. Required to make the box is minimum, but the condition is x, y, z volume should be 8, maybe meter cube, let's say. Okay, I want to make a box of volume 8 meter cube, but it should actually contain the minimum material. Material is actually signified by the surface area, correct? So if you see at every point there is material, then definitely there is some surface that gets generated. So surface area is measure of material required to construct the box actually. Okay, and this volume, this is actually the volume, V is equal to 8 meters cube actually. Okay, so let's see if this is 8 meters cube, then now did you understand what does this physical condition tells you? Someone has asked me a question before. What does this equation physically tells you? This is what the equation actually physically tells me. Okay, x, y, z is equal to 8 is basically the box should have a volume of 8 meter cube. That's my logic, or basically that's my constraint on the variables, but I want to look for the minimum surface area of the box actually. Okay, so let's see if you solve this directly. I'm framing f of x, y, z is equal to xy plus 2xz plus 2xy plus lambda times x, y, z minus a. Okay, then dou f by dou x is equal to 0, dou f by dou y is equal to 0, dou f by dou z is equal to 0 actually. Okay, so this gives you, if you differentiate partially with respect to x, you have sorry, did I do something wrong? 2xy and this is 2yz. Okay, sorry, this is 2yz. Yeah, because surface area, no? So 2yz. Okay, because surface area will be yz and yz, 2yz, xy, xz and xz, 2xz plus xy, because top is open. Okay, so top is open. Okay, so that should be xy. Okay, पहले इक्वेशन का मतलब क्या है? कंस्टेंट का. That's what, na? Whenever your variables are defined, like for example in this case geometry, x is y, x1, x, y and z are defined by geometries. Okay, such that the product of these three should not cause 8. Okay, that's what. Okay, yeah, you can start. because this yz is the surface area in this case. Okay, so so that's what xz xy. Fine. If this is xz, previously I have given xy now here. Did I give xy? Did I give xy actually there? Then definitely, you know, please correct it. It should be yz. Okay. So anyway, if you solve this, then if you're differentiating with respect to x, first of all, we have y plus 2z plus lambda into yz is equal to 0. Similarly here, x plus 2z plus lambda into xz is equal to 0. This is one equation. And last equation with respect to z, if you see, 2x plus 2y plus lambda into xy is equal to 0 actually. Okay, so these are the three equations actually. So if you simplify these three equations, let's see what you will get. Lambda is equal to minus yz by y plus 2z. Here lambda is equal to minus xz divided by x plus 2z. Lambda is equal to minus xy divided by 2 times of x plus y is what you have. So you can start equating the things, like for example, if you first equate maybe these two things. Okay, so let's say if you are equating these two things, minus xz by x plus 2z is equal to minus xy divided by 2 times of x plus y actually. Okay, then this minus x gets cancelled. Then you can have 2xz plus 2yz is equal to xy plus 2yz actually. So this and this gets cancelled. So x also gets cancelled. So y is equal to 2z. So this is one relation. Okay, so y equal to 2z. Then but understood by pattern, huh? Yes, of course. So if you see, so y equal to 2z is one equation. So let's again equate maybe these two guys. Okay, so if you equate this, minus z and minus z cancels. Y by y plus 2z is equal to x by x plus 2z. So if you simplify this, xy plus 2yz is equal to xy plus 2xz actually. Okay, xy gets cancelled, and this implies y should be equal to sorry, z is same, so x should be equal to y. X should be equal to y actually. Okay, so x should be equal to y and y should be equal to 2z. We got the relation between variables. Okay, so let's see if relation between the variables is obtained. X is equal to y, so xyz is equal to 8 is what we have. But in this, by doing this differentiation and equating, we got y is same as x, z is same as y by 2, which means it's same as x by 2, 8 actually. Okay, so x cube is equal to 16. So x is equal to 16 power 1 by 3. This is the value. Similarly, this is y, and z is equal to what about z actually? 16 power 1 by 3 by 2. That's it. You got the values. Just put it in that expression. You'll get the answers. That's all. Okay. Got it? Did you all understand the method of Lagrange's multipliers clearly? Yes or no? Please type in the chat box. Is that clear to each and every one of you? Everyone. So please type in the chat box. Did you all understand how to work out the method of Lagrange's multipliers? If some equation and some constant equation is given, then how are you gonna progress? Okay. Fine. Yeah. So anyway, this is for the previous question. 0.33 could be that answer. Okay, when I have given you that. Fine. Anyway, time could be short. So anyway, we'll discuss one last concept before we go for linear algebra, which is the multiple integrals. There is one important concept actually in this, which is method of, or basically change of order of integration. Multiple integrals. Okay, so you know very clearly, if you have a function f of x comma y dy dx, now this limits on the inner integral should be functions. Okay, like for example, you see phi of x to psi of x, and here it is maybe some constants a to b actually. This actually tells you whenever these are functions of x, that means these are limits of y. Means whenever you are integrating this function, you have to integrate first with respect to y actually. Okay, if you want to integrate first with respect to y, then the limits on the inner integral should be y limits, but those y limits should be in functions of x actually. Okay, So this is what you have, and obviously these are y limits and these are x limits. Okay, so that's all clear. Change of order of integration, I'll tell you with the help of an example. Let's see, for example, I have x square dy dx. Okay, so let's say I have x square dy dx. So previous question, AMGM से different क्यों आ रहे? Can you please check? Arithmetic में AMGM मतलब didn't get you. What is AMGM? So please elaborate your question. So let's see. In this case, let's say I have defined the integration like this. Maybe this is how much we shall keep. Shall we keep 12? Okay, this is 12. And this is also 12. For example, this is the line y equal to x. So let's say this height is also 12 actually. Okay. So this is 12 actually. Okay. So this is also 12. Okay. So let's say if you want to calculate this integration, and let's say I have given you limit something like limits. Let's say I have given something like 0 to x, then 0 to 12. Let's say I have given you something like this. Okay, so if you want to calculate this, then let's see integration of this value. Clearly these are functions of x, actually these are function of x, so these are y limits. So if you simplify this, integral 0 to 12, when you are integrating with respect to y, treating x as constant, so this function is constant itself, x square into integration of dy gives you y within the limits 0 to x dx actually. Okay, so integral 0 to 12 x cube dx is what you have here. Okay, so integral 0 to 12 x cube dx is what you have. So if you simplify this, okay, so if you simplify this, then x power 4 by 4 within the limits 0 to 12 actually. Okay, then this gives you 12 power 4 by 4. Okay, so this is what the value you have. So 12 into 12 cube divided by 3. So this is 4 of course. Okay, so 4 into 12 cube is what you have. Okay, now let's see 4 into 12 cube is what you get, right? Correct. So this is 12. This is the line y is equal to x, of course. This is origin and this is 12. This limit is also 12. So this point is 12 comma 12 actually. Okay, so let's say you are calculating this integration x square dy dx, for example, x square dy dx. So if you integrate x square into y within the limit 0 to x dx x cube, so this is what you will get the answer. Yes or no? 4 into 12 cube is the answer you get. Yes or no? So please type in the chat box. Are you all clear with this? To get minimum value of that function, yeah, we can get actually. Okay, so here if you see these variables, but problem is you cannot take out this 2 actually common. Okay, because there is no 2 here, that's all. Okay, if there is 2, then we would have got the answer. So anyway, please tell me what is this answer? 4 into 12 cube. Okay, 4 into 12 cube is what? Sequence is also cover. Yeah, we'll cover, but not today, tomorrow. Okay, 12 cube divided by 12 cube by 4. Now I want to explain you something here, which is physically what this integration actually told you. Okay, I've given you some integration, you have calculated. I want to tell you what physically this equation tells you, and also I'll apply the change of order of integration and we'll solve this question again and we will get the same answer. Okay, I just want you to understand how we apply the change of order of integration. See, first of all, can anyone tell me, if I take this triangle, for example, can someone tell me what is the moment of inertia of this triangle about this axis? About this axis, what is the moment of inertia of this triangle? Can anyone tell me? Can anyone tell me what is the moment of inertia of that axis, about that axis? This is 12 and this is also 12. Okay, so 12 and 12, these lengths are 12. BH cube by 36 now. So let's see about, if I mark this OAB, you all know I moment of inertia about AB is equal to, because it's a this is 12 and the right hand, this vertical edge is also 12, so B h cube by 36. Okay, this is what you have. Now let's understand something. If this is the centroid G, for example, then this value is 8, of course, 2/3 of this, and this value is 4. Okay, then if you have in a parallel axis about passing through the centroid, for example, you have this axis which is passing through the centroid, okay, which is passing through the centroid, clear? So this is passing through the centroid. You can understand something. IAB can be written as IXX plus area into 4 square by parallel axis theorem, okay? Similarly, I along this OY, you call this OY, for example, I along OY is equal to IXX, this is IG passing through the centroid, okay, IG passing through the centroid plus IG again here, IG plus area into 8 square. Now can anyone tell me, if I want to calculate IOY, if I subtract, this is equation 2 and this is equation 1, if I do 2 minus 1 for example, then these terms gets cancelled. IOY is equal to IAB plus area into 8 square minus 4 square, okay, this is what you get, correct? IAB, because I want to just keep some relaxation a bit, okay, so that's why I'm explaining you physically what's happening here. Moment of inertia about this axis OY is equal to moment of inertia about AB plus A into 8 square minus 4 square is what we are getting, okay. Now let's see, if you have this IAB, we have calculated IAB is 12 into 12 cube by 36 plus area half into base into height into 8 square minus 4 square can be written as 4 into 12, of course, okay. So here also we have 12 cube actually in this term, here also we have 12 cube. So if you take 12 cube common, we have this cancel this couple of times and this cancel this 3 times actually, okay. So correct, so 2 can actually cancel 4 2 times, 2 can actually cancel, guys just a minute, this is 4 square, we have subtracted this, so 8 square minus 4 square is what you have. Actually the distance between these two axes is 12, no? So this should be 12 square, no? Sorry, because the distance between parallel axis is actually 12 square, okay. So this is actually 12 square, because even though you are subtracting, but this is towards the opposite side, okay. So we have 12 square, so this is not something, so 12 into 12 into 12 square actually, okay. So 12 square is what you get, okay. So this is 12 square, half into 12 into 12 into 12 square, because 12 is the distance between these two axes actually, okay. This axis OY and AB, of course. So if you see, this becomes 6, so 6 plus, okay, so 6 plus, here you have 1 by 3, okay. So 6 plus 1 by 3 actually, just a minute, I think I messed up somewhere. Basically if you calculate this integration, you are getting 4 into 12 cube, right? So we have taken x square, so x is measured from this, so about y axis, if you take for example a small elemental area dA, this integration over the complete region gives you moment of inertia about OY, okay. So this value is actually IOY, okay. So you please work out this maths bit carefully, you will finally end up seeing this IOY value whatever you are calculating will become 4 into 12 cube, okay, because this is the expression for the moment of inertia about y axis, that's it, okay, fine. Yeah, 3 into 12 cube is coming, right? 3 plus some more is here, okay, one more quantity will be here, so that's why. So one more quantity will be here, so we can add up. So I think somewhere I have messed up with the numbers, but if you just put it correctly, you will see you will end up with IOY, okay, because integration of y is always measured from this integration of x square di, and x is always measured from this y axis, okay. So when you measure x from that y axis, then this value is the moment of inertia about this value. 12 square because AB axis is not G axis. AB axis, this is 12 square, right? Yeah, this should be 12 square, okay. So if you put the things correctly, you will finally see 12 cube into 6, but this is on the opposite side, so I think some minus sign actually comes, but this value actually is nothing but moment of inertia of this plane about y axis, okay. That's what, fine. So I just want to give you one more thing. Let's say for example if you have a curve like this, x, y, and this is y is equal to x, and this is y is equal to x square, y is equal to x square. If you have this integration something like this is 0, this is 1 comma 1. If you have this integration something like integral 0 to 1 x square to x, some function f of x comma y, something we are evaluating, maybe centroid or anything. So this value, if you want to change the order of integration, how do you change? Let's see. dy dx. Okay, so first of all, if you want to change the order of integration, okay, if you want to perform the change of order, of integration, how you do this is actually, look, whenever on the inner integral, if the limits of integration are functions of x, that means these are y limits, yes or no? These are functions of x, that means they are y limits. So here if they are y limits, the first variable of integration is actually y. Maybe this product is written in any way, but when the limits are y limits on the inner integral, the first variable of integration should be y. So here what we write, let's say dy dx, if you write here, for example, just for, because dx into dy can be written as dy into dx. Similarly here also you can write dx into dy, no, it doesn't matter, dx into dy. Now if you want to have the first variable of integration as x, actually x minus y to root y, we'll see. Okay, so f of x comma y dx dy, if the first variable of integration is actually x, then what you'll do is you consider a horizontal step at any location. Okay, so here x is equal to y, and this implies x is equal to square root of y. Okay, so x is equal to square root of y. So whenever you move this step from bottom to top, left hand side or the lower value of x is always bounded by x is equal to y. The upper value of x is always bounded by square root of y. So what you write is least value of x is bounded by y, and upper value is bounded by square root of y. Okay, and y changes from 0 to 1 at maximum. So therefore this integration 0 to 1 x square to x f of x comma y dy dx, this is same as 0 to 1 y to square root of y f of x comma y dx dy actually. Okay, so this is how basically you change the order of integration. You plot the curves. First of all, let's say for example, if I give you this integration, then y equal to x square, y equal to x equal to 0, and x is equal to 1. So these are the curves actually. So x equal to 0 is clearly this, x equal to 1 is clearly this. Okay, so in between these two, the area bounded by this curve. So if you want to convert this into x, take a horizontal step and see what would be the limits of that horizontal step. Okay, so that's all. If you do that, you can shift the order of integration. Clear? And many questions in GATE, they come basically on this order of change of order of integration in XC explicitly. Okay, so this or change of order of integration concept is also a bit important actually. Okay, fine. So is this clear to all of you? Did you all understand how to write the limits? Of course, integration is known to you, but how to write the limits when you are changing the order of integration? Is this clear to each and every one of you? Dx dy means first with respect to x and with respect to y, that's horizontal step. Basically with respect to x first, with respect to x first is basically horizontal step. Okay, this product can be in any way depending on the way we write. Okay, you can see this product can be dy dx or dx dy, but accordingly we'll write correctly when you are placing the limits. Okay, normally we write this as dA, that's it. Okay, dA can be dx dy or dy dx, doesn't matter. Clear? So with this in a nutshell, I would like to close the calculus part for single and multivariable calculus actually. Okay, so we will start with linear algebra. Is this clear to all of you? Probability is also included, but tomorrow. Okay, so basically today I'm going to take 5 things: calculus, single variable and multivariable. Calculus is the biggest module, so that's finished. Okay, so remaining vector calculus, complex calculus, these are very small parts. Okay, basically in XC, vector calculus syllabus is very small, and also complex calculus syllabus is also very small. Okay, so these two will hardly take 1 hour, and then linear algebra and of course ordinary differential equations. Okay, ordinary differential equations again take some time, roughly some 40-45 minutes will take. So after that, so 16 power 1 by 3 y by 2, where in this? Yeah, here you please work out. Okay, I think in this when showing geometry I messed up something, but this could be the correct thing. Okay, fine. Now I know I have kept you in stressed mind for so much time, so we'll do some linear algebra. Okay, so after linear algebra you have to tell me, okay, you got relaxed or you got stressed more, because majority people never talk about the diagonalization concepts and all. So we will look at diagonalization of matrices, which is a very important thing actually, and then eigenvectors and all. So have you solved XC type questions somewhere? Yes, I'm telling you now. See, basically this is what I'm talking about. We'll open YouTube sometime. see, I'll just show you because the time is actually a bit short. So you can see 𝐂𝐸, gate. Just a minute, something happened. 𝐂𝐸 gate maths. Maths. If you see, these are basically the practice sessions which you can see. I guess we have done it last time. 𝐂𝐸 maths PYQs gate Wallah. Okay, so you can see, yeah, these are the lectures basically. So lecture 1, basically I have done it in 3 modules. Then at that time it's completely Abhyas sessions. Okay, each session could be of roughly 3 hours or beyond that. You see some 9,000 people have got benefit out of it last year. So we have 3 sessions basically. So 𝐂𝐸 1, okay, then after if you see 𝐂𝐸 2, then third session is also there. So basically you can go there. Okay, so you just type 𝐂𝐸 gate maths questions, then definitely it could show you. Is there any course from you in English only for gate 𝐂𝐸 or ME? I have taken so many. Clear? So please go to the 3 videos once these sessions are finished so that you can have enough practice. Okay, so anyway, let us see. So matrices, which is one of the most powerful but most underrated again. So matrices, instead of talking about all the things, I'll ask you a few things. Okay, matrix addition, do you all know? Or subtraction, do you know how to do this? Every one of you. Matrix addition and subtraction. I'll ask you a few things. If you know that, then I'll skip this. Okay, because anyhow people might have done this so many times. Okay, so tell me, matrix addition and subtraction, you all know this, right? Yes or no? If I give you 2 matrices, you know how to add or no? Yes? That kids thing. Oh, really? Fine. So let's see. Matrix multiplication. Okay. This is also kids thing. Matrix multiplication. But here I want to make a few points very clear. If I want to multiply 2 matrices, total number of multiplications required. Can anyone tell me? Total number of multiplications required to calculate AB. So tell me, how many multiplications you need to get this? Like for example, if I take 2 by 2, okay, A, B, C, D, E, F, G, H. Then to get the matrix, what I should do? First of all, I should multiply A with this E, 1 multiplication, plus B with the G, so 2 multiplications. So to get one element, I need 2 multiplications. Okay, to get the first element, I need 2 multiplications. So total there are 4 elements. To get the 4 elements, I should do 8 multiplications. Similarly, here, can anyone tell me? 17 into 4 into 18. 17 into 4 into 18. Good. It's not 17 into 18, 17 into 4 into 18. Okay, yeah, 17 into 4 into 18, of course, because the logic is same. Okay, if you have, see, I'll just tell you, if you have a matrix A of size m by n and matrix B of size n by p, this actually means that you have m rows such that there are n columns here. Okay, similarly n columns here and p n rows and also p columns actually. Okay, so whenever you finally calculate this, you will have a matrix which is of size m by p. So total you have m into p elements. Okay, m into p elements is what you have totally. Okay, now if this is m into p elements, now to get the first element, how many operations you have to do, how many multiplications? So clearly you know there are n columns here and n rows here, so definitely one element gets multiplied to each element. So like that you'll have n multiplications totally. So therefore n multiplications for getting one element, and in this there are m into p elements, so total m n p multiplications is what you have to perform. Okay, so this n is actually can be multiplied here, so n into mp multiplications. Now can someone talk about number of additions? Number of additions, any idea? How do you do the number of additions in this? Number of additions you do. One thing is very clear, mp should also be there, because again that's the number of additions. Now here instead of n you have to do n minus 1, because to add 3 numbers you need to do 2 additions. Okay, like for example if you want a plus b plus c, to add 3 numbers how many additions you do? 1, and then after 2, that's it. Okay, so therefore number of additions will be 1 less than the number of multiplications, so n minus 1 has to be there, that's it. Okay, yeah, m into n minus 1 into p. Basically guys, these formulas are very valid when we are writing programming. Okay, so let's say I have 2 matrices, okay, or 3 matrices for example. Okay, so if I have 3 matrices, if I want to calculate this product ABC, I can calculate AB into C, or maybe I can also calculate A into BC. In both the ways, because matrix multiplication is associative, I can calculate in any of the ways, but the number of operations computer has to perform to get this guy is different. Okay, so therefore before starting the programming, what we do, we make this simple analysis of m into n minus 1 into p and also m and p. We will decide the least number of operations is in which case, and we write the coding as per that order. Okay, so that it saves the computation time. Clear? So let's see. So types of matrices and all, I just go through quickly. Types of matrices. Types of matrices. Okay, so types of matrices. So symmetric aij element is equal to aji element, and anti-symmetric or skew symmetric, anti or skew symmetric aij is equal to minus ji. Okay, basically aij denotes the ith and jth column of an element, so aji denotes ab is not equal to ba, ab not equal to ba, correct, but here I have given you c, 3 matrices. Okay, okay, so that's what. So let's see, this is skew symmetric. Then every matrix A can be multiplied, can be split into 2 parts, a symmetric part and a skew symmetric part. This is actually very important when we are doing fluid mechanics, normally not at your level, but when we are doing this Navier-Stokes equation and all, your level means don't feel bad, undergrad level is what I mean. Okay, so A minus A transpose, so this A minus A transpose is skew symmetric. Okay, skew symmetric. How do you know it is skew symmetric? Because if you take C for example, which is A minus A transpose, then if you consider C transpose, this gives you A minus A transpose whole transpose, A transpose minus, applying transpose twice gives A. So if you take minus sign, A minus A transpose, so this is minus C. Okay, so C transpose is equal to minus C, so therefore that part is actually skew symmetric. Okay, and this guy is symmetric. Okay, so whenever there's a matrix, you can break it up into 2 parts. One is the symmetric part and one is the skew symmetric part actually. Okay, and so let's see. Let us see certain interesting stuff. If basically product of 2 non-zero matrices can be a zero matrix. Product of 2 non-zero matrices can be a zero matrix. Okay, so how do you know this? Straight away I'll just show an example. Okay, so definitely you see 0 0 0 3 4 0 0 0 is equal to 0 0 0 0. That's all. Okay, so it's basically not these two matrices are not 0, but still the resultant is 0. Okay, because in real numbers this doesn't happen. If product is 0, we equate one of the numbers to 0 or maybe both, but here even if both are non zeros, still it can be 0 actually. Okay, so let's see. One important thing I would like to talk in terms of determinants. Okay, you all know what is a determinant, how to do, and all basic properties of determinants. Okay, so how to calculate the determinant and all, but of course I would like to put some light here to talk about the determinants. This is there. So if you see, if product of two non-zero matrices non-zero matrices A and B is 0, then I'll give you options, so please try to work out. Option A, C, come on, type the answer, type in the chat box. XC का PVQ देखिए, पता चला क्वेश्चंस का लेवल. हाँ, इतना इजी नहीं है, आता है XCA में. फाइन, एलजी डिकम्पोजिशन भी पढ़ाता हूँ, लेकिन पहले इस चीज पर बताइए, इस 4 ऑप्शंस में किस ऑप्शन करेक्ट है? Come on, type it in the chat box. Out of those 4, which is correct? A and B are two non-zero matrices, but their product is 0. Then out of these things, which should happen? Come on, think. Yeah, all of you can do it. Okay, no issues. C. C is the correct. Okay, so C, why I'll tell you. A not equal to 0, B is also not equal to 0, but AB is equal to 0. That's what they have given you. Okay, this is what they have given. Okay, now we know one thing. So XC ka PYQ ka Y. Basically I have done that just 5 minutes back. I have shown you the videos. Okay, so let's see here. So let's say let det A not equal to 0, for example. This implies A inverse exists. Okay, if A inverse exists, then AB is equal to 0 is already given in the question. So if you multiply A inverse on both sides, okay, if you multiply A inverse into A is I into B is B is equal to A inverse into 0 is 0, which is contradiction. Contradiction, correct? Because it's clearly given B is not equal to 0, but by taking det A not equal to 0 is telling you B is 0. Or maybe let det B not equal to 0, then this implies B inverse exists. Then this finally will lead to A equal to 0, which is again a controversy. Okay, so this is again a contradiction. Clear? So if this is again a contradiction, then definitely this can also not happen. So therefore det A and det B both should be zeros, which I have also shown you basically in this example. These two matrices are of 0 determinants. Clear? So C is the correct answer. Clear? These are nice conceptual points. Okay, then I would like to tell you one more things. If A and B are symmetric matrices, then AB plus BA is always symmetric. Okay, this is always symmetric. Like for example, you see A is equal to A transpose and B is equal to B transpose, for example. Okay, if A is equal to A transpose and B equal to B transpose, consider that guy. Let C is equal to AB plus BA. If you have this, you consider transpose, whole transpose, then you break it up at plus sign. Then you know product of two matrices is nothing but B transpose into A transpose plus A transpose into B transpose. but individually A and B are symmetric, so I can replace this with BA plus AB actually. Okay, this expression can also be written as AB plus BA, not because the multiplication is commutative, but I bring this term here and I bring this term here, that's it. Okay, because of commutation in addition I am replacing, not because of commutation in multiplication. Okay, so matlab I cannot write BA as AB, no I cannot write, but I can bring this AB here and BA here because the plus sign is there. So this is equal to C, so C transpose and C are same, so definitely this matrix is symmetric. Similarly, we have a minus sign, you will end up with skew symmetric. Okay, because then a minus sign comes common. So all these things are basic fundas. Then we talk about one important matrix, orthogonal matrix. So you know, basically matrix which preserves length, actually here. So basically, you know, I'll just ask you one thing. Normally if I give you two matrices, for example 1 2 3 4 and let's say 3 8, some matrix, if I give you, then immediately you know 3 plus 16 19, 9 plus 24 33, this is the matrix. Okay, so practically what does this tell you? Okay, there's a matrix, then there's a vector, this is the vector, this is the vector, then if you apply this matrix on this vector, finally this is something it's coming. So what does this actually tells you? Look, I'll tell you. If you have a plane, okay, this is x and y, and you take any vector which is 3, 8, so let's say this is 3i plus 8j, 3i plus 8j, so this is the vector actually. Okay, so let's say this point is, for example, you know, small a you take. Okay, so this is point A, this is O. Now what does this matrix done? If you apply this matrix on this vector, this matrix is changing this vector to 19, 33 actually. Okay, so 19, 33 is actually somewhere like this. Let's say this is point B, for example, so 19, 33. This tells you that when you apply this matrix on this vector, this matrix will change the length of this vector, it is stretching, and also it is rotating this vector, yes or no? But orthogonal matrices never actually stretches the length. Length will remain as it is. Okay, like for example, you see here the length of this OA is square root of 3 square plus 8 square, but length of OB is square root of 19 square plus 33 square, and obviously OB's length is large. Okay, 19 and 41, 19 and 41 coming, 9 plus 32, yeah, 41. Okay, that's 41, so here it is 41. Now you might have understood now why I have missed all India rank 1 many times. Okay, 9 plus 32 is 40, 33 is what as per me. Fine. So OA and OB you have. So basically if you see, whenever you apply this vector, when you apply this matrix on this vector, this matrix is changing the length of that vector and it's also rotating. Okay, this is called linear transformation normally. Okay, so linearly this matrix is getting, this vector is getting transformed. But now if you see the case of orthogonal vectors will keep the length as it is. Like you see, first of all, the meaning of orthogonal vector is actually A into A transpose is equal to I. So this implies transpose is equal to inverse. Okay, so transpose is equal to inverse. If you talk of an example, in an example, you see, for example, you have cos theta of, like for example, theta is you know, you take 0, so cos theta 0. Okay, directly use identity matrix. So 90 you take 0, minus 1, 1, 0. So this is actually an orthogonal matrix. Okay, you can see just by applying some get ka hi PYQ cover. Basically I'm doing now all the majority of the questions are all these PYQs. Okay, you have these questions again, these all are PYQs of XC. So let's see. Anyway, 0, minus 1 and 1, 0. If you multiply with transpose 0, 1, minus 1, 0. So let's see what you will end up. 0 into 0 plus minus 1 into minus 1, we have 1. 0 into 1 plus minus 1 into 0, this is 0. Then 1 into 0 plus 0 into minus 1, 0. 1 into 1 plus 0 into 0, this is 0 actually. So you see, when I multiply transpose of a matrix with itself, I got a identity matrix. Okay, but you can understand, if you apply this matrix A, if you apply this matrix on any vector, it just rotates that, but it never changes the length. Okay, like you can see, for example, if I am applying this matrix on some vector, let's say 2, 3, then undoubtedly this becomes minus 3 and this becomes 2, means whenever you have this vector x and y, so let's say this is 2 comma 3 is the initial vector, so 2 comma 3 is this vector actually. Now when you apply this matrix on this vector, it's turning out to be minus 3 comma 2, means this vector is being rotated something like this, minus 3 comma 2 actually. Okay, so this is minus 3 comma 2 in this case. Okay, basically I have taken theta equal to 90. Normally the actual standard form of the orthogonal matrix is cos theta minus sin theta cos theta is what you have in a 2 by 2. Okay, in a 3 by 3 you have cos theta sin theta 0 minus sin theta cos theta 0 0 0 1 is what you have. So here if you put theta equal to 90, this is the matrix what I get, because cos 90 0 minus sin 90 minus 1 sin 90 1 cos 90 0. So definitely if you apply this matrix on this vector, it rotates this vector by 90 degrees. Clearly you can see this angle is 90, because if you do dot product of these two vectors it will be 0. Okay, so it got rotated by 90 degrees. This not identity matrix, sir. Sorry, didn't get. Sorry, 1 आएगा कहाँ? Yeah, it's 1. Fine. Okay. Yeah, 1 into 1 plus 0 into 0, so that's 1. Okay, no issue. Yeah, it's 1, na? 1 0 0 1. So if you see, this rotation is by 90 degrees, but if you take the length of this vector is root of 2 square plus 3 square, and if you take the length of this vector, this is minus 3 square plus 2 square, so this is the same, so this value are same. Okay, so orthogonal matrices will never do any stretching or shortening of the vectors, they purely rotate, they preserve the length actually. Clear? Did you all understand what is the physical meaning of orthogonal matrix? Okay, and if you take basically the rows or columns, any two rows and any two columns, and if you do the dot product you will get 0 straight away. Okay, because orthogonal matrix is basically formed from the orthonormal rows and columns. Okay, so if you take dot product of any two rows or any two columns, definitely the value turns out to be zeros. Okay, so let's see. Similarly we have idempotent. Idempotent, you have a square is equal to a, and involutory a square is equal to I. Okay, so let's see if this is a square is equal to a. Now coming to properties of determinants, I just wanna speak few things. Determinant of Ka power n is equal to, determinant of Ka is equal to Kn by n is equal to k power n times of determinant of a actually. Okay, so all these properties and all you might have studied already. So determinant of k power n into determinant of a actually. Okay, now if you see the every skew-symmetric matrix, of odd order has 0 determinant. What is the meaning of odd order? If I have a matrix, for example, if I have a skew-symmetric matrix a n by n, then n is odd. Okay, so n is odd actually. So whenever n is odd, like for example if I take 3 by 3, 5 by 5, 7 by 7, all these matrices will have 0 determinants. Okay, like for example I'll show you using example first, then I'll apply my general style and I'll show you. Okay, so if you see, if you take this matrix 0 0 0 minus 3 3 4 minus 4 4 minus 4, maybe minus 5 and 5 here. Okay, so this is a 3 by 3 matrix. So if you take this 3 by 3 matrix, if you calculate the determinant, pakka you will get 0. Okay, so why? 0 into something 0 minus 3, that minus becomes plus 3 times of 20 minus or plus 4 times of minus 15. So 60 minus 60, 0 is the answer. Okay, you take any odd order skew symmetric, definitely answer 0 aayega. Look, I'll show you how this can happen. You take a skew symmetric, A is equal to minus A transpose, correct? And you all know that A is equal to that of A transpose. This is known to you, so I'm not doing any shufflings. If you take the determinant on both sides, okay, so this is n by n, this is also n by n. Dat A is equal to this minus 1. If I want to take out of determinant, I should write minus 1 power n times dat of A transpose. Yes or no? Will you all agree with me? So please type in the chat box. if I want to calculate this, det A is equal to, if I take this minus 1 out, minus 1 power n into det A whole transpose is what you have. Yes or no? Correct? Type in the chat box. So please type in the chat box. Is this correct? Okay. Now, det of A transpose is same as det A. So this I am replacing again with det A. So if I replace this, you will have det A times of 1 minus minus 1 power n is equal to 0 actually. Okay. Now, when n is odd, this value is 2 definitely. Okay. So this implies that A should be 0 for any odd order. As long as n is odd, doesn't matter 3, 5, 7, 9, whatever, definitely this matrix will have a 0 determinant. Okay. This statement is very important actually. Even in test series I have given many questions based on this. Okay. So skew symmetric has 0 determinant actually here. Okay, because of this simple understanding. Clear? And so determinant properties are n numbers. You can apply row transformations, column transformations, you will get zeros. Okay, you know all these things, basic things you might have done, applying row transformations, column transformations. Okay, if two rows are equal, then determinant is 0. If two rows are proportional or columns are proportional, then also determinant is 0. You might have seen all these things. Okay, so let's move to one important part, which is the rank of a matrix. Rank of a matrix actually. Okay, so rank of a matrix. So definitely, you know, rank of A is nothing but number of linearly independent rows of A, or maybe columns, because column rank is same as row rank of a matrix. So, or this can also be written as number of non-zero rows in row echelon form. In row echelon form actually here. Okay, so if you convert any matrix into row echelon form, then definitely number of non-zero rows in that matrix is nothing but the rank of the matrix. Okay, and total dimension minus rank is called nullity. That's it. Okay, so nullity is basically the number of dependent rows in this case. So rank plus nullity is dimension. Nullity is number of linearly dependent rows. That's it. Okay, dimensions of matrix. Dimension of the matrix. Okay, so let's see actually one more thing. So if you have this rank of a matrix, then this rank plays a very powerful role in talking about consistency of the system of equations. Okay, so consistency, if you talk about consistency, if you see certain small properties of rank actually, if A and B are two matrices, rank of AB will be less than or equal to minimum of rank of A comma rank of B actually. Okay, again I can prove this using indicial notations and all, but right now I'm not showing. So please you know, you can take this rank of A is same as rank of A transpose, all these things. Okay, least. Okay, when it's m by n, then if m is less than n, we'll compare with respect to m in that case. Okay, Vivek. So let's see. So this is less than or equal to minimum of A comma of B actually in this case. Now consistency, if you talk about consistency of system of solutions, consistency of system of equations, actually, number of solutions. If you have a matrix system, Ax is equal to B, for example. Okay, so you have equations A11 x1 and so on, plus A1n xn is equal to B1 and so on, like this, AM1 x1 and so on, plus AMN xn is equal to Bn. Okay, so if you can generate a system like this, okay, Ax is equal to B, then depending on ranks we decide the number of solutions. Okay, like rank of A is equal to rank of A augmented B. So what is this augmentation? You take A, then the last column you add one more, like can you keep question solving? Yeah, just after this is the last point. After this I'll start question. Okay, so if you see rank of A is equal to rank of A augmented B is equal to n. Okay, then this implies unique solution. Unique solution and rank of A is equal to rank of A augmented B is less than n, then we have infinitely many solutions. And finally, if these two are not equal, then you have no solutions actually. Okay, so these are the three conditions which you can actually show with the help of examples in 2D by plotting different lines and all. So but we will talk about this no solutions actually. Okay, yeah, I hope I have answered your question, right? So the minimum of the values. So let's solve this question. I'll give you some time. And the poll, single choice, so maybe I'm giving you 120 seconds. Start. You enter in the chat box. Okay, so we will see. There's a system A and B is also given. Then the system of linear equations Ax equal to B has which of these things? Unique solution, infinitely many, no solutions, all these things. Okay, so fine. Okay, so let's solve this. If you take A augmented B directly, okay, let's work with A augmented B. So if you take this A augmented B, 1 2 0 1 2 0 3 1 R S 0 S minus 1 actually. Okay, so this is R S 0 S minus 1 actually here. Okay, now let's see if you want to make this into a row echelon form. Okay, if you want to convert this into a row echelon form, let's see. First choice will be making these two elements zeros actually. Okay, so if you make this first two elements zeros, of course, then let's see, R2 changes to R2 minus R1, R3 changes to R3 minus small r times, R times R1 actually. So if you make this transformation, this gives you A augmented B is equal to 1 2 0 1. Okay, 1 2 0 1. Then 2 minus make it 2 here so that it becomes 0. So 2 minus 2 times of 1 0, 0 minus 2 times of 2 minus 4, 3 minus 2 times of 0, this is 3, 1 minus 2 times of 1, this is minus 1 minus 1. Okay, r minus r times of this, which is 0. Then s minus 2r, so this is s minus 2r actually. Okay, then 0 minus 0, this is 0, s minus 1 minus r actually. Okay, so s minus 1 minus r is what we have. Now let's see s minus 1 minus r, and also this is not in row echelon form yet because these two elements these two elements are still present. So let us convert this to row echelon form actually. So first of all, before converting to row echelon form, let's say if s minus 2r is equal to 0, if s minus 2r is equal to 0 actually, which means if s is equal to 2r, let's see what happens. If this term is equal to 0, that means it tells you 0 into x plus 0 into y plus 0 into z is equal to s minus 1 minus r. Okay, means if this is s is equal to r, then definitely s minus r should be equal to 1 actually. Okay, if s minus I is not equal to 1, for example, okay, and it's not mandatory that s minus I should be equal to 1 always. So if s is equal to 2r, that tells you giving zeros, I mean these three are coefficients of zeros, is giving you some constant, which is not possible actually. Okay, so if s is equal to 2r, then let's see, if s is equal to 2r, then definitely we don't have any solutions for this. Okay, so s is equal to 2r, not equal to 2. If this is equal to 2, for example, let's see, if s is equal to 2r is equal to 2, this implies s is equal to 2 and r is equal to 1 actually. Okay, so when s is equal to 2 and r is equal to 1, 2 minus 1, this becomes 0. This also becomes 0 actually. Okay, when s is equal to 2r is equal to 2. So in such case, you can see when this is equal to 2, then definitely this complete O becomes 0. Then you have only 2 equations for 3 unknowns actually. Okay, only 2 equations for 3 unknowns. That means you can have infinitely 2 equations for 3 unknowns. So it's a 1 parameter system. So basically you can have infinitely many solutions. So here this leads to infinitely many solutions. Okay, so this leads to infinitely many solutions because under these conditions we have 2 equations for 3 unknowns. So then definitely we can have multiple options. Okay, so therefore this option can be correct option, infinitely many solutions, if this is equal to 2. This infinitely many solutions for not equal to is wrong actually, because in this case it don't have any solution. It should be no solution actually, because if this is not equal to 2, that means these 3 coefficients are zeros, but this is not 0. Okay, which is not possible actually. Clear? So therefore these 3 being zeros and this non-zero is not possible when you have a system clearly. Okay, so that's why this B is not valid. And a unique solution for s is equal to y equal to, no, just now we have seen if this is the case we have infinitely many solutions, so this is wrong. No solution for s not equal to 2r. If s is not equal to 2r, then definitely this is non-zero, you have some constant, here also you have some constant, then 3 equations, 3 unknowns, definitely you would have got certain solution. So no solution is also wrong. So this option here is also wrong here in this case. Clear? Did you understand the reason behind these things? This is a nice question actually. If s is not equal to 2, then definitely we can have no solution. Okay, because of this. If these two are equal, but if s is not equal to and r is not equal to 1, then definitely it becomes 0, but this won't be 0. In such case there is no solution which is possible actually. Okay, so therefore D is the correct answer in this case. Okay, is the understanding clear? You know these points actually. Okay, but you have to do little clear cut understanding to put the correct choice. Okay, Vijay, did you understand? This is no solution actually in this case. It's not infinitely many solutions, because if these two are equal but not equal to, this will be 0, but this won't be equal to 0. Then in such case no solution. Okay, it's not infinitely many. Clear? So let's solve one more question. Yeah, this question, eigenvalues. So we all know basically eigenvalues, x is equal to lambda x. So if x is an eigenvector, this is eigenvalue, of course, eigenvalue, and corresponding eigenvector. Okay, now clearly if you see a power m, I would like to give some properties here. A power m and a have same eigenvectors, have same eigenvectors actually. How do you know? Because let's say for example if I have ax is equal to lambda x, okay, and if I multiply a on both sides, because this is a matrix, at least a vector, then this is also a matrix. Okay, this gives you a square into x is equal to, if you take lambda here, we can write this a into x, which is lambda times of lambda x, which is lambda square x actually. Okay, so you can understand this a square x is equal to lambda square x. That means x is the eigenvalue. So how to find how many solutions? As per this, as per this. Okay, so as per this we decide the number of solutions. Clear? So let's see in this case. So therefore see, similarly if you multiply cube, okay, a cube x, then again lambda square into ax gives you lambda cube x. Okay, so like that basically what happens is your eigenvectors of a and a power m will remain same. Okay, but eigenvalues, you can see a square has an eigenvalue which is lambda square, so eigenvalues will go in powers. Okay, and eigenvalues of adjoint a, eigenvalues of adjoint of A is det A by lambda 1 actually. Okay, so is det A by lambda 1 actually in this case. Clear? So anyway, now coming to this question, basically you know this properties, sum of eigenvalues is equal to trace of the matrix, product of eigenvalues is equal to, product of eigenvalues is basically determinant of the matrix, these points. So coming here, let's see. The eigenvalues of a 3 by 3 matrix P are 2, 2 and minus 1. Then P inverse is equal to dash. Okay. So first of all, we know something called Cayley-Hamilton theorem. Yes. Cayley-Hamilton theorem actually. Okay. So what this Cayley-Hamilton theorem talks about? Every matrix satisfies its characteristic equation. Every matrix satisfies its characteristic equation actually. So you know what is the characteristic equation? Basically that of A minus lambda I is equal to 0. So if you have that equation, how that equation comes? Basically from here. Okay. In this, if you see, I'd like to just show some small bit of analysis. Look, if you have Ax is equal to lambda x, this implies Ax minus lambda x is equal to 0. Okay. So you can write this as A minus lambda I into x is equal to 0. So this is a homogeneous equations, homogeneous system of equations. You have some matrix into some unknown vector is equal to 0 actually. Okay. Now you can see for this system to have non-trivial solution, okay, if this system has to have non-trivial solution, then you all know if normally if you take this case, okay, so here in this, let's say for example B is 0, then definitely rank of A augmented B and rank of A depends only on rank of A actually. Okay, because this column of 0 vectors will make all other determinants 0. Now if this system has to have because if I have a Ax is equal to 0, one of the solution will be definitely x equal to 0. Okay, this 0 vector is a solution, but this is called the trivial solution. Okay, so this is called trivial solution actually. Okay, so this is called the trivial solution. But if you want to have a non-trivial solution, then definitely this rank of A should be less than n, which means this determinant of A should be definitely 0 actually, for rank of A to be less than n and have non-trivial solution. Actually. Okay, so to have the non-trivial solution. Okay, I'll upload it in the Telegram channel maybe. Okay, so that could be fine. Clear? So let's see, this is called non-trivial solutions. Similarly, whenever you are talking about this combination, if this combination has to have some eigenvectors, not the zeros, x is not equal to 0. Okay, you will write this clearly, x is not equal to 0. So that means this equation is having a solution such that x is not equal to 0, then definitely this coefficient matrix has to be 0, that of A minus lambda I is equal to 0. That's how you actually get the characteristic equation from the consistency condition of homogeneous systems. Okay, so clear to all of you? Did you all understand how this det of A minus lambda I is coming? Okay, and if you solve that, it's a polynomial equation, you will get some roots. Okay, normally calculating this characteristic equation is very simple. Many times what people do is, I'll just tell you, for example, if I want to form a characteristic equation for this matrix 1 3 2 1 4 3 3 8 1, for example, let's say if I want to form the characteristic equation for this, what people do is they'll put this equation and try to simplify. After so much of simplification and meanwhile doing some calculation mistakes, you'll get some equation. But I'll give you some small technique to calculate this this equation, characteristic equation, directly. Let's see. Characteristic equation, if A is equal to this, det of A minus lambda I is equal to, look how we can write. It's a third order matrix, so definitely lambda cube minus, now trace of the matrix 1 plus 4 5, 5 plus 1 6, 6 lambda square plus, now taking the second order traces, like you take this element, eliminate this column and this row, then determinant of this matrix 4 minus 24 minus 20 plus, then take this element again, eliminate this column and this row, 1 minus 6 minus 5 plus, Then again consider this element, eliminate third column and third row. 4 minus 3, 1. So minus 20 minus 5 minus 25 plus 1 minus 24 times lambda minus determinant. Now take all the element, complete matrix. So 1 times of 4 minus 24, which is minus 20 minus 3 times of 1 minus 9 minus 8 plus 2 times of 8 minus 12 minus 4 is equal to 0. Sorry, this is actually the determinant of the matrix. Okay, so minus 20 plus 24 minus 8 actually. Okay, so 24 minus 20 is 4, so this is minus 4. So minus of minus 4. So the equation is lambda cube minus 6 lambda square minus 24 lambda plus 4 is equal to 0. This is the characteristic equation of this matrix. Okay. Achha, Telegram channel name I'd give you t.me/pw. So this is the matrix name. Okay. So this is how we can form the characteristic equation just by taking, see, this is called the first variant, second variant and the third variant. Okay, even if you transform the matrix into some other coordinate systems, these values will not change. Okay, so lambda has a constant, this equation, characteristic equation is actually a constant equation. Now anyway, coming back to our discussion here, in this case, let's see, eigenvalues of matrix P are 2, 2 and minus 1, then P inverse is equal to dash. Okay, so let's see what are the eigenvalues of P inverse first. So P has eigenvalues of 2, 2, minus 1. So P inverse got eigenvalues of minus 1 by 2, sorry, 1 by 2, 1 by 2 and minus 1 actually. Okay, so just reciprocate that, you will have the values. Okay, so these are the eigenvalues. Now let's see if these are the eigenvalues. P inverse, let us go by checking the options directly if it's fine. First of all, sum of eigenvalues of P inverse is 0. Okay, then product of eigenvalues of P inverse is equal to minus 1 by 4. Okay, and considering two product at a time, 1 by 2 into 1 by 2, 1 by 4 plus 1 by 2 into minus 1, minus 1 by 2 plus 1 by 2 into minus 1, minus 1 by 2. Okay, so this is the three product, which is basically this is minus 1 by 2, minus 1 by 2, minus 1 plus 3 by 4. So this is minus 3 by 4 actually. Okay, so this is minus 3 by 4, which means if you form the equation for P inverse cube, okay, because these are eigenvalues of P inverse, or basically you can also form for P and then calculate P inverse. Let's see, if these are the three eigenvalues of this, what you can have, P cube minus 4 minus 1, 3 P square plus 2 2s are 4, 4 minus 2 plus minus 2, so this is 0 plus product of the matrices is minus 4, so this is minus of minus 4, so which is plus 4, is plus 4 times I is equal to 0 actually. So if you multiply with P inverse, we have P square minus 3P plus 4P inverse is equal to 0. So P inverse will become 1 by 4 times of 3P minus P square. It should be somewhere here. So 3P minus P square, which is in option A. Clear? I think no need of doing this part, because directly from eigenvalues of P you can form characteristic equation of P actually. Okay, so I think no need to do this part. So this simple part can actually help you. Okay, yeah, A is the correct answer. Clear? Okay, so A is the correct answer. 1 by 4 times of 3P minus P square. So let's go to the next question. Diagonalization. Okay, so let's look into the concepts of diagonalization a bit. If first of all, before going to this question, let's discuss small things on diagonalization. So you take a matrix A, for example, then we will see whether this matrix is diagonalizable or not. Diagonalizable. Diagonalizable or not. Okay, so let's see, how do we determine whether matrix is diagonalizable or not actually here. So for deciding that, you have to calculate the eigenvectors of that matrix. Okay, and eigenvectors are linearly, if all the eigenvectors are linearly independent, then that matrix is diagonalizable actually. Okay, so let's see, for example, if A, you have this matrix A, actually A can be expressed as P inverse or P into D times P inverse actually here. Okay, so this is normally called the diagonalization or the diagonalization split up of the matrix, actually diagonal decomposition or eigenvalue decompositions. So let's see, in this case this can also be written as AP is equal to PD, where what are these matrices P and D? Let's see, where P is equal to, or first of all D is equal to diagonal matrix formed by lambda 1 0 0, for example if it's 3 by 3, 0 lambda 2 0 0 0 lambda 3 actually. Okay, and what about P actually? So P consists of eigenvector x1 bar, x2 bar and x3 bar actually in this case. Okay, so where x1, normally x1 has n components, so this becomes like this, x2 is here, x3 is also here. 6, what is 6 actually? Acha, here in this next question you are telling. So anyway, let's see, if this is x1 x2 x3 are the vectors, so this has some 3 components, this has some 3 components. Let's, for example, x1 a1 b1 c1, x2 you got your eigenvector a2 b2 c2, okay, and x3, you know, for x3 you got a3 b3 and also c3 actually in this case. Now whenever you have this matrix P, model matrix, yeah, basically this is the model matrix. So P is actually given by a1 b1 c1, a2 b2 c2 and a3 b3 c3 actually here. Okay, so these are the vectors. Now why we do diagonalization? What is the point of doing diagonalization actually? Okay, when you have the matrix split up in the diagonal form, it's very much easy for you to calculate inverse, higher powers of a, any power of a in general. Okay, so let's see, if for example if I want to calculate a square, how do you calculate? A square is equal to a into a, which is p d p inverse times of p d p inverse actually. So when you are multiplying, these two multiplication will give you I, so p d into d square, because this is I anyhow, so d into d gives you d square times p inverse. So a square just gives you p d square p inverse, and calculating the square of diagonal matrix is very easy, like d square is just lambda 1 square 0 lambda 0 lambda 2 square 0 and 0 0 lambda 3 square actually here. Okay, so that's how we actually do the diagonalization very easily. You can see this. Similarly, if you want to calculate any higher powers or inverse, for example, okay, if you want to calculate inverse, this can be easily calculated. Okay, like for example you have a inverse. Okay, you have a inverse is nothing but p d inverse p inverse. In general, any power with even power minus 1, anything can be calculated, and calculating the diagonal matrix of this calculating the inverse of this diagonal matrix is very easy. 1 by lambda 1 0 0 0, 1 by lambda 2 0 0 0, 1 by lambda 3, that's it. Okay, so anyway, just if you see this, so basically diagonalization is there. Then we define something called algebraic multiplicity and geometric multiplicity of eigenvalues. Algebraic multiplicity is nothing but directly simple. If you solve this, this is nothing but actually number of appearances of an eigenvalue in a matrix, or appearances, or instead of this, let's say number of frequency, better right, frequency of an eigenvalue, frequency of an eigenvalue. Like for example, you see, you can see, for example, like you take any matrix, for example if the eigenvalues are 1 1 3 like this, okay, then we say 1 has appeared 2 times, so algebraic multiplicity of 1 is actually 2, okay, because 1 is coming 2 times. Similarly, geometric multiplicity, if you see, geometric multiplicity. So if you take geometric multiplicity, for example for lambda, eigenvalue lambda, this is eigenvalue lambda actually. So this geometric multiplicity of lambda is nothing but rank of a minus lambda I. Okay, so this is basically the null space of this a minus lambda I is what you have here. Okay, so rank of a minus lambda I is actually the n minus, okay, sorry, n minus rank of lambda I. rank of A minus lambda I is the geometric multiplicity, because it's a null space, dimension of the null space of A actually. Okay, so that's why if rank plus nullity is equal to dimension, so n minus rank of A minus lambda I is called the dimensions of the matrix actually. Okay, now let's see, let's solve these two questions. I think we have some two nice questions. So let us solve this question first. If Q is equal to 3, 2, 4, 2, 0, 2, 4, 2, 3, this is symmetric matrix clearly. Okay, so this is a symmetric matrix. So if this is actually a symmetric matrix, and P is equal to V1, V2, V3 is the matrix where V1, V2, V3 are linearly independent eigenvectors of matrix Q, then the sum of absolute values of all elements of the matrix, sum of absolute values of all elements of the matrix P inverse QP actually. Okay, so let's see P inverse QP. So can anyone tell me, if you multiply this, then again we will get this matrix P inverse QP. Like, you see, whenever you are diagonalizing, we have AP is equal to AP is equal to P times the diagonal matrix. Okay, so you can write this as P inverse AP is equal to D, the diagonal matrix actually. Okay, so in this diagonal matrix, it's a 3 by 3 matrix clearly. So we have 3 eigenvalues, lambda 1 0 0 0 lambda 2 0 and 0 0 lambda 3 actually here. Okay, so when you have these elements, then this Q is P inverse QP is same as the diagonal matrix actually. So in the diagonal matrix, they're asking you sum of absolute all elements. Okay, like for example, if you take the absolute values, sum of the absolute values of all elements, sum of the absolute values of all elements is nothing but mod lambda 1 plus mod lambda 2 plus mod lambda 3. Okay, and since this matrix is actually symmetric matrix, okay, so this since this matrix is actually the basically symmetric matrix, this particular summation is called nuclear norm. Okay, which is not generally talked about. This diagonalization concept is not talked in mechanical normally, but this is called nuclear norm of the matrix. Okay, nuclear norm of the matrix. And so definitely only one thing we have to do, if you know this concept of diagonalization till this part, if you can understand, that means you should know what is the sum of absolute eigenvalues of this matrix. That's all. Okay, so let's see. As I told you, you can start simplifying the equation. Characteristic equation, lambda cube minus 6 lambda square plus then 3. If you take 3 into 0 minus 4, so minus 4 minus 2 into this is the first element, then eliminating this column and this, so 9 minus 16 minus 7. Okay, so 9 minus 16 is minus 7, then plus 3, this and this if you eliminate, then minus 4. So this is minus 4. So you can see minus 12 minus 7 minus 12 minus 7 minus 19 minus 4. Okay, minus 23 I guess, correct? So let us do once again. 3 times of this value is minus 4 plus eliminating this column and this, so 9 minus 16. So this gives you minus 7 plus 3 is not there here, right? So 3 should not be there. Basically minus 4. Okay, if you eliminate this, then you have minus 4 plus eliminating this column and this, so 9 minus 16 minus 7 plus eliminating this column and this, so minus 4. So they have minus 4 here in this case. Okay, so minus 4 minus 11 minus 11 minus 11 minus 4 minus 15. So this becomes minus 15 times lambda plus, okay, plus determinant. Coming to determinant, 3 times of minus 4 minus 2 times of 6 minus 8 minus 2 plus 4 times of 4 actually. Okay, so 16 plus 4 20 minus 12, so 8 is what you have, plus 8 lambda plus 8 is equal to 0. Okay, so plus 8 is equal to 0. That's what you have. So this is the characteristic equation which you can form. Even if you apply mod 3 minus lambda 2 4 like this, if you calculate, you will get the same answer. So if you solve this equation, definitely you can understand one thing. This coefficient is 1 minus 6 minus 5 or basically 1 minus I think there's a plus sign. This determinant is coming plus 8, so it should be minus actually. Okay, so 1 minus 15 is minus 14, minus 6 minus 8 is also minus 14. So lambda equal to minus 1 is Fine. So lambda is equal to -1 is a solution. Lambda is equal to -1 is a solution actually for this matrix. Okay. Yeah. Similarly, if you see, if you calculate the roots, -1, 8 is other eigenvalues because sum should be 6. So -1 plus -1 plus 8 is 6. And if you use the determinant, you can identify that this the two eigenvalues are -1, 8 is other eigenvalues. That's all. Okay. So these are other eigenvalues. Therefore, lambda 1 plus lambda 2 plus lambda 3 modulus signs is equal to 10. So this value is 10. So basically, you have to calculate eigenvalues, then add the absolute values of the eigenvalues. That's it. Okay. So basically, you can see for a given matrix, calculate eigenvalues and take the absolute sum of the sum of the absolute eigenvalues actually. Okay. For that, you should know this concept of diagonalization. And also in this case, this is a special case. It's a symmetric matrix. So I would like to tell you something actually. Okay. Normally we have something called row norm and column norms. And column norms actually. Okay. So what is this row norm and what is this column norm actually? Let's see in this case. So row norm and also the column norm, of course. So row norm tells you if you have this matrix 3, 2, 4, 0, then after 2, 2, 3. So if you take 2, 2, 3, what does the row norm tells you actually? Okay. So look, out of this first row, the maximum value is 4. Out of this, the maximum is 2, and out of this, the maximum is 4. If you add this, it is 10. This is the answer. That's it. Okay. So normally nuclear norm is equal to this row norms and column norms in case of symmetric matrices. Okay. So discuss please for real symmetric matrix, distinct eigenvalues is equal to linearly independent eigenvectors. Yeah, basically they become, for distinct eigenvalues, they form orthogonal eigenvectors. Okay. Yeah. Clear? So this forms this. Similarly, it's a symmetric matrix, and normally for any matrix, even if you take the maximum of this, it's 4, 2 and 4. Even if you add this, it becomes 10 because it's a symmetric matrix, and normally row norm and column norms, any norms basically is equal. That's why knowing the concept of diagonalization and also symmetric conditions is actually used in this question. Okay. And this question came somewhere in some time back in 𝐂𝐸, so I thought of using this question. Yeah, this is also a nice question. So please solve. I'll give you one formula which would help you actually. Rank of any matrix A is equal to n minus, it's a square matrix because we are dealing with eigenvalues. So n minus algebraic multiplicity of of 0 as an eigenvalue. Okay. Algebraic multiplicity of 0 as an eigenvalue actually. Come on, solve this. I'm giving you some time. Now rank of A minus I is dash. I have given you this formula. So I think this is some previous question. Single choice. So okay. So enter an integer type. I'm giving you 150 seconds to solve this. Solve. It's a identity matrix of order 7 I, and A be a 7 by 7 real matrix having characteristic polynomial C of lambda is equal to lambda square lambda minus 1 whole power alpha into lambda plus 2 whole power beta, where alpha gamma beta positive integers. If A is diagonalizable and rank of A is equal to rank of A plus 2i, then rank of A minus I is dash. Come on, solve this. This question is like a very nice question. Okay, you can see we are using the concepts of diagonalizations, then the rank, all these things. Come on, solve this. Okay, yeah. So some of you please try that. So let's see. I denote the identity matrix of order 7 and characteristic polynomial of A. So characteristic polynomial of A is given by lambda square into lambda minus 1 power alpha into lambda plus 2 power beta actually. Okay, so this is what we have. Now try to understand something. This is lambda plus 2 power beta and this is the characteristic polynomial. If I solve this equation, how many times I'll get 0 as a root? Can anyone of you tell me? If I solve this equation, how many times I would get lambda equal to 0 as a root of this equation? If I solve this equation, if I make this equal to 0, how many times lambda equal to 0 will be a root of this equation? It should have 7 roots, right? Out of those 7, how many of them will be zeros? That's the question. 2 roots, correct? So you can see because of this 2, this implies algebraic multiplicity of 0 as eigenvalue is 2. Okay, 2 times, right? Because there is lambda square here. So this actually tells you rank of A is equal to, it's a 7 size matrix minus this 2 is the algebraic multiplicity, so this is equal to 5. So rank of A is basically 5, of course. Okay, and also when this is a 7 by 7 matrix, then definitely this characteristic polynomial should also be of 7th degree. So here it is 2, so this implies alpha plus beta is equal to 5. Yes or no? So alpha plus beta should be 5 because clearly this is a 7 by 7 matrix. If you generate a characteristic polynomial for a 7 by 7 matrix, then definitely the degree of the characteristic polynomial should be 7. So 2 plus alpha plus beta should be 7. So alpha plus beta should be 5 actually. Okay, and rank of A is also 5 obviously because this is 2. Now let's see, this matrix is diagonalizable, so all eigenvectors are independent linearly. Rank of A is equal to rank of A plus 2i. Okay, so let's see, rank of A is equal to rank of A plus 2i, but just now we have observed this rank of A is equal to 5. Okay, so this tells you rank of A plus 2i is equal to 5. Can anyone tell me what would be the characteristic equation of A plus 2i? Look, can I find this awesome formulas? BS-Gravel, not in BS-Gravel, basically I have taken from Gilbert-Strang. Okay, and yeah, basically majority from Gilbert-Strang. Okay, so let's see. I want to ask you one question, guys. If you have f of x is equal to 0, for which you have roots alpha, beta, gamma, things like this. Okay, let's say it's a nth degree polynomial, you have n number of roots. Okay, you have alpha, beta, gamma. If I want to have a polynomial whose roots are alpha minus 1, beta minus 1, gamma minus 1, and so on, my equation will be, if roots has to be decreased by minus 1, then f of x plus 1 should be 0. Then definitely f of x plus 1 equal to 0 will have the roots alpha minus 1, beta minus 1, and so on like that. Okay, like I will explain you with a simple example. Like for example, you see x square minus 2x or minus 3x plus 2 minus 3x plus 2 is equal to 0, for example. Okay, then definitely x is equal to 1 comma 2 are the roots of this equation. Like let's say if I decrease the roots by 1, this is 0 and this is 1. If I form the equation, definitely I'll get x square minus x plus 1 is equal to 0 actually. Okay, so this would be the equation, correct? Yes or no? X square, sum of the roots is 1, product of the roots is 0. So x square minus x is equal to 0. This is the equation actually. X square minus x equal to 0. Actually, by looking at this roots, you have formed this equation. But if you are decreasing this roots by 1, if you calculate x plus 1, because if you are decreasing roots by 1, you should put x plus 1. These things you might have studied in your plus 1 or plus 2, but you might have forgotten. So let's see, if you simplify this, x square plus 2x plus 1 minus 3x minus 3 plus 2 is equal to 0. And obviously, if you simplify, 2 plus 1 cancels out this 3, then 2x minus 3x gives you 1 minus x. So x square minus x is equal to 0, which is same as this equation. Okay, so if you decrease the roots by an amount of k, then definitely f of x plus k is equal to alpha. Now why I have told you this background is basically rank of a plus 2y. If a has this characteristic polynomial and rank of a is basically, eigenvalues of a are lambda 1, lambda 2 and so on, lambda 7 for example, and these are the roots of this equation which is here, then a plus 2y, if these are eigenvalues of a, then definitely eigenvalues of a plus 2y will be lambda 1 plus 2, lambda 2 plus 2 and so on, lambda 7 plus 2. Yes or no? These will be the eigenvalues for this matrix a plus 2y. That means compared to these two, the roots are getting increased by a size of 2 actually. Okay, if roots are getting increased by a size of 2, that means the polynomial c a plus 2y of lambda should be something like, in place of lambdas here, we should replace lambda minus 2, because if you want to decrease the roots, then you have to do x plus 1. If you have to increase the roots, you should put minus. Okay, hence here you are increasing the eigenvalues, therefore lambda minus 2 square into then lambda plus minus 1 whole power alpha, so lambda minus 2 minus 1 whole power alpha into this third term is basically lambda plus 2, so lambda minus 2 plus 2 power beta actually. Okay, so this is what you get. Now clearly this 2 and this 2 gets cancelled, this equation becomes lambda minus 2 whole square, lambda minus 3 whole power alpha into lambda power beta, of course. Okay, now just try to observe, a rank of this matrix should be same as 5, so 5 is equal to 7 minus algebraic multiplicity of 0 as eigenvalue. If you see this characteristic polynomial which is corresponding to a plus 2y, this lambda equal to 0 turns out beta number of times. So beta is the algebraic multiplicity of 0 eigenvalue. So 5 is equal to 7 minus beta, so beta is equal to 2 actually. If beta is equal to 2, then definitely you know we have alpha plus beta equal to 5, so alpha is equal to 3. Okay, so alpha is equal to 3 in this case. So alpha is equal to 3. Now everything is sorted. Let's see what they are asking. Rank of a minus I. If you want rank of a minus I, then characteristic polynomial of a minus I should be, just put lambda is equal to lambda plus 1, because a minus I means eigenvalues will be lambda 1 minus 1, lambda 2 minus 1 and so on. So if you add the characteristic polynomial lambda plus 1 whole square into lambda plus 1 minus 1 whole power alpha, lambda plus 1 minus 1 whole power alpha into lambda plus 1 minus 2. Okay, lambda plus 1 minus 2 or plus 2, anything. So this is plus 2 actually, lambda plus 1 plus 2 power beta. Okay, so if you see the polynomial, this 1 and 1 gets cancelled, so lambda power alpha times lambda plus 1 whole square into lambda plus 3 whole power beta actually. So this is the equation, characteristic polynomial of this matrix a minus I. So definitely if you want to calculate a rank, seven minus algebraic multiplicity of 0. So here lambda power alpha is there, so alpha is the algebraic multiplicity of 0. So 7 minus alpha is 3, so this value is 4 actually. Okay, so the rank of a minus I is going to be 4 in this case. Clear? So rank of a minus I is basically 4 in this case. Got it? Yes or no? Clear? It basically depends on two things. One is knowing this condition, and second knowing this algebraic multiplicity subtraction. So in previous problems of forming characteristic equation for finding P inverse, How to write the equation? Look, I'll tell you. I got your doubt. See, normally if you have two roots, okay. So anyway, this answer is 4. I think majority of you might not have entered. If someone have entered, okay, fine. I understand because the question is very complicated. So if you see in this case, if you have alpha and beta, the equation is x square minus alpha plus beta times x plus alpha beta is equal to 0. This is anything known to you. If you have three roots, alpha, beta, gamma, this is going to be x cube minus alpha plus beta plus gamma x square. Then again, here you have used minus, so alternative, plus here in this term you have taken only one root at a time. Now you should take two at a time. Alpha beta plus beta gamma plus gamma alpha times x, then again sign change. Now take 3 at a time, so alpha beta gamma, only one combination is possible, is equal to 0. That's it. Okay, since I know lambda 1, lambda 2, lambda 3 in that equation, so I have used this case. Mechanical में characteristic polynomial and algebraic multiplicity, it's not there in exact thing, but if you want you can do it, okay, because knowing always properties could simplify the analysis. Okay, so this is how I have written. Okay, Yuvraj, is this fine? Did you understand how we have formed the equation? Because lambda 1, lambda 2, lambda 3 are known, so you can form the equation. That's it. Okay. So these are basically bits of diagonalization and algebraic concepts, algebraic multiplicity and geometric multiplicity concepts of matrices. Rest of the things could be majorly known to you actually. Okay, yeah, these things are known basically, I guess. So then we will move to the vector calculus, but before moving to the vector calculus, in calculus and this linear algebra, do you have any doubts? Any one of you? Do any one of you have any doubts? Do any one of you have any doubts actually? Are you all feeling this session helpful at least to some extent? Are you all feeling this session is useful to you? Okay, no doubts, no? How many of you have learned something new in this session today, especially in the linear algebra part when I am talking? Yes. So let's fine. We'll have break for 5 minutes. Okay. Because I think many of you have tired. So we'll start vector calculus after 5 minutes. So 5 minutes break. Okay. We'll again continue at basically the time is 10:10. 10:15 we'll start. Okay. How algebraic multiplicity and geometric multiplicity are useful in diagonalization of matrix rank. Okay, calculating rank actually. They are useful in calculating the rank. Okay, because if you can calculate rank, then we can say whether the eigenvectors of the matrix are linearly independent or not. So numerical methods be kal. Okay, because today we will try to finish up to complex calculus, because I think differential equations also I think time won't be sufficient. We have spent enough time on calculus and linear algebra. So after looking through this, because the syllabus for complex calculus is very small, to be honest, only differentiation is there, and we'll vector calculus also there is no surface and volume integrals. Okay, so only we have up to this vector line integrals. Okay, so that's what. Book for calculus. Calculus you can follow many books. There are n number of books. You can follow one by James Stewart. Okay, this is one good book for calculus. Then there is Thomas calculus, which is also again helpful a bit. So more than this, for calculus I suggest you 𝐂𝐤𝐿. It's applied actually, but since many of you are familiar with differentiations and integrations, so I think this could be, these two books could do much better. Okay, still these are the two books which are very helpful. Okay, actual sense. Okay, any questions? So we'll have some 2-3 minutes break and we'll join back. Okay, so join back at how much is the time? Okay, 1 minute is consumed, so 10:15 p.m. Okay, for XC purpose, Laplace transform is how much important? Actually, Laplace transforms are not directly asked, but few integrations and all, they can be solved very powerfully, very simply using Laplace transforms. Okay, fine. So just give me 3 minutes. We'll just join back. Okay, so yeah. चलो कंटिन्यू करेंगे. These are books for calculus anyway. Okay, so all of you, are you all back? Okay, fine. So let's start this vector calculus. You know, basically this differentiation of vector. So in vector calculus there is no excess part of the syllabus. Okay, so syllabus is same as that of ME, is same as mechanical, and no surface and volume integrals. And no surface and volume integrals. Okay, so basically there's no surface and volume integrals. Sir, can you spend 2 minutes on your MTech, sir? How's your journey in fluid and thermal from IITM? To be honest, actually I could, you know, I'll tell you openly and honestly, in my profile you will see only ex-IIT Madras. Okay, you never see MTech IIT Madras. Okay, because when I was in between my MTech there happened few issues and I was to leave my MTech at that point. Okay, and I joined jobs actually, and then after I went into HPCL, VRC, all these things. So I don't have a degree, but later, you know, recently I got admitted to masters at IISc Bangalore. Okay, yeah, in mechanical. Fine, because at that point of time even I finished the coursework and all, but I was not able to submit my project at the end of second year, and basically after 1 year 3 months roughly, yeah, 1 year 4 months I came out of the things. Okay, fine, but I hope that doesn't impact any of my teaching. Okay, fine. So let's see. Yeah, syllabus is same as ME basically here. So if you see, you have vector point functions. Vector point functions actually. Okay, so you have the vector point functions. So let's see, if you have this vector point functions, like you can say for example if a particle is moving, okay, in a space. If a particle is moving in space, you can always denote the position vector with x of t I cap plus y of t j cap plus z of t k cap. For example, let's say in a 2-dimensional plane you are talking. Okay, let's say in a 2-dimensional plane, for example, because I can show you a plane here. So let's see, if you have this x axis and also y axis, and here you have the horizon here in this case. Okay, and if the particles are actually moving, okay, so if the particles are actually moving, okay, let's say if the single particle which is moving at time t equal to 0, the particle is here. At time t equal to 1, let's say 5 seconds, 10 seconds, 15, 20, like that. Okay, then these coordinates at any point x comma y are defined with the help of time. So this x coordinate variation in the x coordinate depends on time, y coordinate depends on time, similarly z coordinate also depends on time. So you can call this for example x of t I cap plus y of t j cap plus z of t k cap actually here. Okay, then let's see in this case, whenever we have this x of t I cap plus y of t j cap plus z of t k cap, then differentiation of this, which gives you the velocity of course, x dash or dx of t by dt I cap, because here again it's product of two functions, but I bar is actually a constant vector. Okay, so when I bar is actually a constant vector, it has a fixed magnitude and fixed direction, so differentiation of I is actually 0 in this case. Okay, so I plus dy of t by dt j plus the dz of t by dt k actually here. Okay, so this is k in this case. So this is how we calculate the differentiation of this vectors. Okay, and I would like to give you one hint, one important thing actually. F bar of t, for example, if you take this vector cos ti plus sin tj, okay, plus maybe some constant, let's say you have, okay, let's deal in 2 dimensions because I can show you something actually. Even if the third dimension is there, I would like to put some constant plus some 3k 4k something like that. Okay, so here you can understand, for example at time t equal to 0, f bar of t at t equal to 0, this vector becomes I cap. Yes or no? Means sorry, means if you have this x and y coordinate system, the initial location at time t equal to 0, the particle is at this location 1 comma 0. Okay, now let's say at time t equal to pi by 6, t equal to pi by 6, then t equal to pi by 6. Pi by 6 is roughly 0.5 seconds. Okay, 3.14 divided by 6, 0.15 somewhere like that. Okay, so 0.51 somewhere. So cos pi by 2, 1 by root 2 I plus 1 by root 2 j. Maybe this particle has traveled somewhere here. 1 by root 2 is actually less than 1, so maybe somewhere here it started here. 1 by root 2 comma 1 by root 2 actually here. Okay, and at time t equal to pi by, sorry, this is pi by 4 actually. Okay, so this is pi by 4, t equal to pi by 4. At time t equal to pi by 3, let's say cos 60, 1 by 2 I plus root 3 by 2 j actually. Okay, so maybe the particle is somewhere here. Finally at t equal to 90 or t equal to pi by 2, it reaches somewhere here. Okay, you can understand one thing, the velocity, if you plot different vectors, so starting from origin, all these are starting from origin. So at time t equal to t1, it is like this, t2, t3, t4, maybe things like this. So the vector is changing its direction. Okay, but sorry, there's a big comment, very big comment. सर एमए का पेपर अच्छा नहीं गया, सोच रहा हूँ ड्रॉप ले लूँ, मेरी एज 20 है और 2022 में बीटेक कंप्लीट हुआ, 1 ईयर ड्रॉप वर्क करेगा एमटेक. आई एम जस्ट टेलिंग इफ यू जस्ट वांट टू गो फॉर एमटेक विश्वा, just focus on XC, you'll definitely go to MTech. Okay, because even though your preparation is good, but still because of some exam dynamics and all, if your exam didn't go fine, then please focus on XC. XC you can go to whatever IIT or IISc you want. Okay, so let's see, in this case this vector has a speciality actually. At different times these vectors are different, but the one common thing that lies in all these vectors is, if you calculate magnitude, this is cos square t plus sin square t, which is 1, means all these points will actually lie on a circle, something like this. Okay, so they all lie on a circle actually. Clear? So magnitude is 1, so all these points are basically present on a circle of radius 1 unit. Okay, so whenever you have a constant magnitude vector, the direction of these vectors are changing. You see, different vectors are in different orientations, but the magnitude of each and every vector is same. So for constant magnitude vector, vector point function, f bar of t dotted with df bar of t by dt is equal to 0 actually. Okay, so this is equal to 0, which means, for example, if you take a small inclination, like for example, you see this is the vector at time t. Okay, so this is the vector at time t, and this is the vector at time t plus dt, same magnitude but it got rotated by some small amount. Okay, so this is dt, this angle is theta, so theta is almost 90. Okay, sorry, theta is almost 0. Okay, so theta is very small, almost 0, very close to 0. Okay, because in a small time dt this slightly rotates. Now if you see, this is t dt, the difference in this vector, so basically this is vector f at time t plus dt, and this is vector f at time t. Now the difference between these two, if you take in this direction, you try to get this difference. If you mathematically see the triangle, this angle is almost 0, but this vector is a vector of constant magnitude, means these two sides are of equal magnitudes. Okay, if these two sides are of equal magnitudes, then definitely it's an isosceles triangle, these two angles should be same. Okay, but sum of these three angles is 180, but this angle is almost 90. That means, can I say this angle here and this angle here will form almost right angles? Yes or no? Can I say this? Is this clear to all of you? Did you understand? This is f bar of t plus dt and this is f bar of t. Then the resultant or basically the closing vector, let's say for example this is a. Okay, then you know f bar times t plus dt by vector addition is f bar of t plus a actually here. Okay, this is what you get, and a is actually f bar of t plus dt minus f bar of t. So this is nothing but the difference in these two vectors. So we can write this difference in f bar of t actually. If you divide with the dt, in a dt tends to 0, limit d2 tends to 0, limit dt tends to 0, of course, this is nothing but df by dt. So you can understand this f bar of t and df bar by dt, which is nothing but this df bar by dt, are actually at right angles to each other. So definitely if you take dot product, they'll become 0. You can also show this in another way, but this is the simple geometry which you can show. Understood? Similarly, if constant direction for f bar of t, or if f bar of t is a constant direction vector, is a constant direction vector, then f bar t cross df by dt will always be 0. Like for example, let's say I'll ask you this. See, if you have x-axis, okay, so if you have x-axis and also if you have y-axis, let's say you have f bar of t, maybe something like this. This is the vector at time t equal 2 seconds. Then if the vector has a constant direction, okay, so if the vector has a constant direction, so let's say this is the direction, for example. Now let's see, this is f bar of t at time t plus dt. This vector has got something like this, because only its magnitude can change, direction cannot change. Okay, if this magnitude can change but direction cannot change, whose name? My name is Vinay. Okay, look, in this case, if this is f bar of t and this is f bar of t plus dt, this is gain 1. Okay, the gain 1 is f bar of t plus dt. The difference between these two vectors is nothing but this guy, yes or no? So this small part is actually, like for example, if I mark A, O, A and B, then AB is actually the difference. Okay, if AB is actually the difference, then this AB and F are oriented along same directions. So if two vectors are along the same directions, then what could be the cross product? Can anyone tell me? See, if this is AB, where this is the vector, and if this vector and the actual vector are both oriented along the same direction, then what could be the cross product of those two? If A and B are parallel, A cross B, how much it is? You all have done, no? Didn't remember? If there is a flow line, okay, and if there is a tangent which you have done for calculating the streamline equation, okay, then v cross ds, this is velocity, and let's say this is the small part of the streamline. At this point you have made a tangent, okay, so ds 0, right? Multiplication of two vectors acting in the same direction, so that's 0. So similarly here, your f bar of t cross this change which is also along f bar of t, so you can calculate these two guys will form a 0 bar. Okay, so same thing we would see in fluid mechanics in streamlines. This is the basic funda for generating the streamline equation. Okay, so vds is equal to 0. That gives you, if you simplify ds, normally if you split in coordinates, you have dxi plus dyj plus dzk, and velocity normally you write by ui plus vj plus wk. Then this expression v cos ds is equal to 0 gives you dx by u is equal to dy by v is equal to dz by w. That's it, same thing. Okay, so anyway, these are the things. Now let's see like how you have chain rule in case of multivariable calculus. Similarly, whenever you take any vector point function, that vector point, or basically we take scalar point function first. Okay, so scalar point function change can be calculated in all directions. So we define an operator to deal in all the three directions simultaneously. This is called del operator. Okay, so this is called the del operator actually. So del, when you apply it on a scalar point function, this is nothing but dou by dou x. Of course, in Cartesian if you write dou by dou xi plus dou by j plus dou by dou z k actually here. Okay, so that's what you have. So dou by dou x of I plus dou by dou v of j plus dou by dou z of k. Okay, and normally what does this gradient tells you? Let's see. If you have a surface, for example, if this surface is given by some equation, phi of xyz is equal to 0 or constant maybe. Okay, so some function, basically because surface are given by z equal to x square plus y, z square plus 2xy, things like this. Okay, so let's say some equation is what you have. Then at a given point, so let's say this is a point P. Okay, So at this point P, if you calculate gradient of phi, let me write here. So if you calculate a gradient of phi, this value whatever you get will be a vector, because it's nothing but dou phi, phi and also phi here. So this gives you a vector, and that vector is nothing but the normal, outward normal in this direction. Okay, if you want this to be a unit vector, then simply you will manipulate, you will just divide this with the gradient, that's it. Okay, so depending at a particular point, you will have the point, and that's the n direction vector. Clear? साक्षी के पेपर में FM and Damo easy रहेगा या solid mechanics? Depends on year to year, Abdullah, actually. So last year thermodynamics was, to be honest, very easy, dead easy. Okay, so fluid was slightly, some 3-4 questions were some nice questions. Solid was also very easy last year. Okay, but normally so people, at least the toppers and like top 1 to at least 20-30, majority of them write solids and thermo combination. Okay, because fluids is slightly hectic in math, that's it. Okay, fine. So this is basically the unit vector. Now similarly, you know how to calculate divergence of a vector point function and curl of a vector point function, correct? You know these two things. So basically divergence calculation is nothing but, if I give you V is equal to Vxi plus Vyj plus Vzk actually here. Okay, so Vzk, then divergence of V is nothing but the scalar net flux which is going out, dou Vx by dou x plus dou Vy by dou y plus dou Vz by dou z actually. Okay, and how do you calculate the curl in this case? Del cos V is equal to, of course, I j k dou by dou x dou by dou y dou by dou z Vx Vy Vz. Okay, so this is how basically you calculate the curl. Okay, now let's see certain identities which could help you out. If curl V is equal to 0, then there exists a scalar function phi, such that this V is given by the gradient of phi actually. Okay, so this principle is very, very important actually. So whenever curl V is actually 0, this is called the conservative field. Okay, means whatever the work that's happening, that's acting within the conservative field. Like for example, I'll tell you, if you take gravitational force, okay, so gravity is a conservative field because it doesn't depend upon the path which I take the body. Okay, like for example, if I want to move this marker from here to say this height. Okay, so if I want to move this marker from this position to this position, it only matters how much displacement this marker is undergoing against the gravitational force. It doesn't depend on the path. Okay, so that's how when curls are 0, the things never depend upon the path, of course. Okay, and if it's a cyclic path, then definitely answer is 0. Let's say for example, if I take it here and again put it back here, I have done some work, but the net work is actually 0. Okay, so similarly V bar is equal to 0. And properties, if you see certain properties which could help you, even in civil paper 1 came in yesterday's class. If you have curl, okay, so curl of gradient of any function is always 0. Okay, you take any scalar point function, you take the gradient of it, then you take the curl, definitely you will end up with 0. Okay, I can show you this very easily. Grad phi dou phi by dou xi plus dou phi by dou by z plus dou phi by dou z k actually here. Okay, and if you take curl of this function, curl of gradient of phi actually, so this gives you I j k dou by dou x dou by dou y dou by dou z dou phi by dou x dou phi by dou y and dou phi by dou z actually. So clearly you can identify something. I bar times of this is dou square phi by dou z minus dou square phi by dou z. This gives you 0. Similarly, you calculate any component, you will end up with 0 actually. Okay, so this is actually 0 bar. The main reason being, if del cos f is 0, then that's called conservative. Okay, आप तो all-rounder हो, thank you. Okay, so this value, this guy is basically, V is called conservative vector field. Conservative vector field actually. Okay, so this is conservative vector field. Clear? So this is a conservative vector field. And also I would like to give you one thing. Divergence of curl. Divergence of curl is also 0. Okay, sorry, it's not a vector, it's a scalar. So divergence of curl is also 0, because whenever you take curl of any vector, like for example, I'll just show you using again this determinant. Del cos v, if you calculate, first of all, if you calculate del cos v, of course. Okay, so if you see epsilon I j k, fine, okay, it's okay, I'll do normally. I j k dou by dou x dou by dou y dou by dou z vx vy vz. Okay, if you see this, I cap times of dou vz by dou y minus dou vy by dou vz by dou y minus dou vy by dou z actually. Okay, minus j cap times of dou vz by dou x minus dou vx by dou z actually in this case, plus k cap times of dou vy by dou x minus dou vx by dou y actually. Now if you take the divergence of this field, then definitely the divergence of this field will be 0. Okay, because del dot del cos v, divergence of curl, let me tell you what it gives you. Dou by dou x of this quantity gives you dou square vz by dou x dou y minus dou square vy by dou x dou z minus dou square vz by dou x dou y plus, because minus of minus will be plus, so dou square vx by dou y dou z. Okay, plus similarly dou square vy by dou x dou z minus dou square vx by dou y dou z actually. So if you simplify these things, then definitely yz and yz, xy and xy, xz and xz, this ends up to be 0. Okay, so therefore sometimes to just to make your time wasted, what they give you, they'll give you some complicated function here. Okay, involving e power x, log x, all these things they'll give you, but they'll ask you these identities, divergence of curl, curl of grad, they'll ask you these things which are zeros basically. Okay, so आपने PhD करी है मैथ्स में? नहीं, मैं सिर्फ मैकेनिकल इंजीनियर हूँ. Okay, fine. So basically these are the divergence, and this is called, if divergence of v, this is called divergence, divergence, and this is curl. If curl v is 0, it's called conservative vector field or force field in general. Okay, and basically what is the meaning of, you can clearly actually see these meanings using for example, you see the divergence of curl is equal to 0. You can see this in fluid mechanics point of view. Like for example, if there is a flow field which is irrotational, okay, so let's say it has some only constant velocities, okay, then at this point there won't be any divergence for the, like for example you take a vortex flow, okay, at this point this particle will not move any radial locations. So at that point, and for example you take a free vortex now, or forced vortex, also doesn't matter, as long as it has a rotational field, then at this point this particle will only try to move in this direction, but it won't have any divergence at that particular location. Okay, so therefore definitely divergence of curl should turn out to be 0. Okay, आप मैथ्स कहाँ से सीखी? बहुत जगह से. I've learned part of calculus from MIT, Massachusetts Institute of Technology, and few from IIT Madras when I was there, then few from IISc, few from Stanford. There were some courses actually. Okay, and in India a lot of NPTEL has put up my knowledge. Okay, yeah. So chalo, solve this question. Let's see, we'll conduct a poll and see how many people are actually participating. The unit normal to the surface, this is the surface, this is the point, is given by this vector. The value of alpha plus beta plus gamma whole square is dash, round off to 1 decimal place, integer type. Okay, and I'm giving you 120 seconds, okay, to solve this. Start. Solve. just 1 week. Okay, you work hard, then 3 months you may relax, you will get admissions. Nobody is able to solve. Time is running up. Come on, fast. 1 decimal place. No? Okay. So let's see. There's a surface first of all. Okay. So there is a surface phi, and at this point on this surface 2 minus 2 3, you have to calculate the unit normal. Okay, that's it, which is equal to, if this point is P for example, grad phi at point P divided by modulus of grad phi. Sorry, not modulus, magnitude. Okay, so surface is given phi x square y plus 2xz minus 4 is equal to 0. So what's grad phi? Dou by dou x of this quantity, which is 2xy plus 2z I plus dou phi by dou y, say if x square j plus 2x k. Okay, so you put this point here. At what point you want? 2 minus 2 3. So put 2 minus 2 3 here in all the x y z places. So this turns you up to 2xy. So 2 into 2 4, 4 into 2 minus 2 minus 8 plus 6 minus 2i plus x square 4j plus 2x 4k actually. So if you take minus 2 common, then you have I plus 2j, no sorry, minus 2j minus 2k actually. Okay, or else let's take only 2, then minus plus plus. Okay, then if you calculate uncap, grad phi at P divided by mod grad phi at P actually. Okay, so this gives you 2 times of minus I plus 2j plus 2k divided by, if you take the magnitude of this vector, this 2 will be outside because square root of 2 square will again give you 2, root of 1 square minus 1 square, okay, plus 4 plus 4, then definitely this is 3, 2 gets cancelled, and this value is equal to 3 of course. So minus 1 by 3 I cap plus 2/3 j cap plus 2/3 k cap, that's all. Okay, so this implies alpha equal to minus 1, alpha is equal to minus 1, beta is equal to 2, and gamma is equal to 2 of course. Okay, so that's what, right, because this is the vector which is given there. So alpha is minus 1, beta is 2, and gamma is also 2 then in that case. Then alpha plus beta plus gamma whole square is dash. Alpha plus beta plus gamma whole square is 1 plus 2 square plus 2 square, which is 9. Correct? 9 is the correct answer. Maybe you can enter 9.0 if needed. Okay, but anyway, 9 is the correct answer straight away. Okay, yeah, 9 is the correct answer in this case. So let's go to the next question. Chalo, vector integration. Okay, so we'll go to the vector integration. We have discussed enough on loss and all. So in vector integration we have only line integrals. So let's see line integrals. Line integrals. So let's say you have a path, maybe some path like this, A to B along C. Okay, then the small elemental work done by any force. Okay, so let's say you have a force F bar. Yeah, 9 is the correct answer. Okay, time could be the constraint, I understand. So this is a path C, for example. Okay, now how do you calculate the line integral? Okay, so let's see. For example, you all know if there is a smooth surface. Okay, let's say if there is a smooth surface, if there is a block like this, for example. Okay, let's say if this block is moving in this direction at velocity u because of some force F, then definitely you for calculating work you cannot multiply F into u directly. Okay, because force is in some different direction, motion is some different direction. So if you want to calculate work done, what you will do, you will resolve this force. If this angle is theta, for example, then this is F cos theta. You will resolve the force along the velocity and you will actually multiply F cos theta times u. Correct? This is what you will do. Yes or no? Please type in the chat box. You might have seen this in your technical. F cos theta into u. So this is nothing but F dot u actually. Okay, because if this is u and this is F, and if the angle between these two is theta, then definitely F dot u is the work done. Okay, now what is this expression actually? Okay, so basically doing the dot product gives you F dot w, F dot u, this is power actually. Okay, so this is power. Power is equal to force into velocity, so this is power. So if you want to have work done, this velocity can be written as, correct? If you divide this with dt, we'll have work done. Sorry, if you multiply this with power is equal to work done by time, so work done is equal to power into dt. So into dt, if you multiply, so elemental work is equal to F bar dot dr bar, where r is the, of course here it's linear dimension, in single direction it's going, but normally in space in 3D you can have any change between two vectors actually. Okay, so let's say for example particle started here, and let's say from here it's moving maybe somewhere here. Okay, then it's not a straight line, maybe some curve. So this expression gives you the work done calculation, that's all. Okay, F bar dot dr bar. So let's see. So for small amount of dr, let's say if this is your small amount of dr actually, okay, then del w is equal to, let's say some vector field is acting on this particle, maybe this is F bar actually. So F bar dot dr bar gives the work in that direction. So dr bar, okay, where this smaller is normal 3D vector xi plus yj plus zk actually here in this case. Okay, so xi plus yj plus zk. So integral from a to b along the path C. Okay, this is the path C. So this gives you total work into action, integral F bar dot dr bar along C, of course. Okay, so let's see what we can have actually. If F is equal to fxi plus fyj, and dr is of course dxi plus dyj, in 3D you can have fzk and also dzk, that's all. Okay, then F bar integral over a to b, F bar dot di, if you do the dot product of these two vectors, fx dx plus fy dy plus fz dz, this is what we have. And along the path x, y, z are related by certain variables, so definitely you can solve. Okay, so let's see. Anyway, let us solve this question. I think this question is given, yeah, here. Okay, so this question, if the work done in moving the particle once around the circle x square plus y square is equal to 4 under the force field, this is the force field, is 16 times of pi, then modulus of a is basically here and here. So the modulus of a is dash, absolute value of a is dash actually. Come on, solve this question. I would like to give you some time, integer, and I'm giving you 20 seconds. Okay, solve. It's like an easy question, so you can solve quickly. You want to apply Gain's theorem? Okay, apply. 2. Anyway, let's see. Meanwhile, let's people do that. So as one of you told, because this is a closed path actually, because once around the circle, so we will apply Gain's theorem. Okay, so let's see what is this Gain's theorem first of all. Clear? So when you have its cyclic path, f bar dot d r bar, and most importantly, this f is dealing only with two variables. Okay, f is involving only two variables. If there is three, then instead of Gain's, you should go for Stokes theorem actually. And this Gain's theorem is actually some special part of the Stokes theorem. First of all, I'll tell you what is Stokes theorem, which you may see. Stokes theorem. Cyclic integral over C when there is a closed path C which is enclosing some area A. Of course, let's say for example this is the plane, it's a path, and A is the area which is enclosed. Then f, of course, not plane, in 3D in general. Okay, so f bar dot dr bar, this is actually given by integral over the area A, surface integral, curl f dot, if this is a vector, if this is the region, then definitely it has got some unit vector n cap at any given direction. Let's say for example if this is dA, small elemental dA, okay, then at that dA if you have n cap, curl f bar dot n cap dA is what you have actually. Okay, curl f bar dot n cap dA is what you have, where n cap is the surface integral of this, sorry, n cap is the unit normal vector to this surface actually. Okay, so n cap is the unit normal vector. Then let's understand something. If you take curl V, for example, okay, if you take curl f bar dot dr bar, okay, in a 3D case, so if I take curl, let's see what happens. I, j, k, dou by dou x, dou by dou y, dou by dou z, and dou by dou z actually, and this is fx, fy, fz. Okay, now let's see if this is the function that you have, then is equal to, let me write something, dou fz by dou y minus dou fy by dou z, okay, minus j times of dou by dou fz by dou x minus dou fx by dou z, plus k times of dou fy by dou x minus dou fx by dou y. Okay, so this is what you have. Now tell me one thing, if you do partial differential, if you do dot product with n cap, what is n cap actually? N cap is given by, to this area you have n cap which is gradient of A basically. Okay, so you can see n cap is equal to gradient of phi. Let's say for example if this surface is generated by some phi, then if you do this, then this n dot, this curl f dot n cap is given by this area, and you can calculate the integral. But now if you have only xy components, let's say for example there is no z component, then what happens here is there won't be any variation in z, and there is also no variation in z. Then definitely this first two terms will go to 0. You will have only one term which is k times of dou fx minus dou fx by dou y actually. Okay, now let's say this is xy plane, for example this is xy plane, this board is xy plane, okay, x and y, so this is some area. Can anyone tell me, if I take a small area dA, the outward normal will be along k, yes or no? So the outward normal will be k cap, unit outward normal at any point on that surface will be k cap actually, correct? Yes or no? Can you understand? If I take an xy plane, at any point the unit outward normal will be in the direction of z, and that's nothing but k cap actually. Okay, so if you apply the Stokes theorem here, what you will get is integral over C fx I cap plus fy j cap dot dr bar, which is dxi plus dyj. Now if you apply the Stokes theorem, this value is equal to integral over the region A, which is bounded here, curl f. So curl f will be k times dou fy by dou x minus dou fx by dou y. This is what you have. Okay, dot, of course, k cap into k cap dot, the unit outward normal will be k cap times dA, and this k dot k is 1. Okay, so k dot k is 1. So therefore you will see cyclic integral over C f bar dot dr bar in case of 2 dimensions, or in general if you write this as fx dx plus fy dy. If I write that as m dx plus n dy, for example, okay, m dx plus n dy. So this will be equal to the integral over the region bounded n by x minus m by y dx dy, maybe dy dx depending on the limits what you write. Okay, so this is how we have the Gheen's theorem, which is actually one part of Stokes theorem. Okay, whenever Stokes is general for the three variables, but whenever the things are restricted to one plane, okay, then definitely Gheen's theorem can actually help you. But actually this is derived from Stokes. Okay, and here you don't, in XC you don't have the divergence theorems and basically volume and surface integrals. Surface integrals only at this small portion to calculate. Okay, so this is the Gheen's theorem. Gheen's theorem. Okay, I want to tell you one more thing actually. For example, if this curl F is 0, let's say if the force field in which the work is happening is conservative force field, if curl F is actually 0, then definitely this guy is also 0. Okay, which means if the flow field is irrotational, then curl F is 0, cyclic integral f bar dot dr, maybe in 2 dimensions or 3 dimensions, doesn't matter, this is definitely 0 actually. Okay, clear? Maybe many of you might be remembering this in this format, so I have used m and n, otherwise normally whatever fx or fy, I normally just do this in this Stokes always, because when I'm doing fluid mechanics, to calculate the circulation of the fluid elements I go with Stokes. Okay, that's what. Clear to all of you? Okay, how many of you, all of you are enjoying it? Nice. Yeah, because people unnecessarily people feel things are complicated and all, but actually if you know the funda, then writing the things is very easy. Okay, so anyway, so why we are doing all this job? We are doing for something, no? To solve this. So let's see. X, y, then there is a circle, so let me draw a circle also, a good circle, fine. So this is x square plus y square is equal to 4. Okay, so x square plus y square is equal to 4. So there is a force field, this, so work done. So directly I am writing integral, cyclic integral over C, 2x minus ay I plus 2y plus ax j dot dxi plus dy j. Now things are only in a plane, so let's go with Gheen's directly. So this is equal to integral over the region R dou by dou x of this n 2y plus ax. Guys, sometimes in exams they change this I and j, so please be careful. Okay, because this is just addition. Even if I write this term second and this term first, vector remains same, so please be careful. Minus dou by dou y of 2x minus ay times dA actually. Okay, then integral over the region R, where R is this guy, total region which is bounded by a circle. Okay, dou by dou x of this gives you a minus of minus a times dA. So this is a minus of minus a is 2a into double integral over the region a dA. So this directly gives you integral over differentiation, total operation gets cancelled, and this is area of region R. That's it. Okay, so area of the region R. So 2a times, what is the area? Pi r square. So pi into r square is 4. So total this is 8 pi a. That's all. Okay, so 8 pi a is the work interaction. So if this is 8 pi a, then definitely 8 pi a is equal to this guy is equal to 16 pi. Okay, so if this is equal to 16 pi, then obviously a is equal to 2. Okay, so 2 is the correct answer. Normally when we ask this integrations, we don't bother about the sign conventions. Okay, so we don't bother about the sign conventions. Normally anti-clock is taken as positive. Okay, because force and the change in what do you say, this dr bar, both should be in the positive directions. Okay, so that's why any anti-clock is taken as positive, clockwise is taken as negative. That's it. Okay, if there is a clockwise, then do the same story, that just put a minus sign in front of the answer. That's all. Okay, टाइम स्टेप दे देना, मतलब किसका टाइम स्टेप, किस चीज का? Okay, yeah. So there's just one important point I want to tell you. I forgot actually. This is anyhow 0. If this vector field f, if curl f is 0, then definitely this cyclic integral along any closed path, this will be 0, of course. Okay, I want to tell you using another way also. See, for example, in conservative force fields, in conservative vector fields, whatever, force is a vector. Okay, so in conservative vector fields, let us write because it's more generalized statement. Conservative vector fields. Okay, so if you take the conservative vector fields, then curl f is 0, of course. Curl f is 0. Now see carefully. If I calculate integral over c f bar dot dr bar, I've told you when curl f is 0, f can always be written as gradient of some scalar function phi. Okay, so gradient of some scalar function phi. कब कौन सा वीडियो में रिवीजन के लिए टाइम स्टैम्प, टाइम स्टैम्प्स देता हूँ, ठीक है, टाइम स्टैम्प्स, ओके फाइन, टाइम स्टेप देख के थोड़ा सा कंफ्यूज हुआ मैंने, लेकिन टाइम स्टैम्प्स देता हूँ, ठीक है, नो इश्यूज. सो लेट्स सी conservative vector field. If f bar is equal to gradient of phi, actually this line integral can be written as integral over c grad phi dot dr bar. This actually gives you phi, let's say for example at points a to b. Okay, then gradient of phi dot dr bar, if you take this del phi is basically in the normal direction to this, and this is the space. If you see, this value is nothing but phi b minus phi a. Okay, it's like this is something like integral of derivative of x square, something like this. Okay, so that's what, so these two operations gets cancelled and finally you'll have x square. So something similar to that, you have this. Okay, now one interesting thing here is if path is closed, that is cyclic process, for example in thermodynamics. Okay, if a and b are same, a and b are identical, this implies phi at b minus phi at a are equal because function is same. If points are same, then phi at a and phi at b has to be same actually. So this gives you phi b minus phi a is equal to 0. Okay, this happens for a closed path. This implies if path is closed, then definitely if the conservative force field is integrated, you will get a 0. That's what. Okay, this is basically from integration or differentiation, that's basically from curl operator. Okay, using Stokes, both are same. And very important point here, this depends only on value, depends only on initial and final states. Initial and final states actually. Okay, so it depends only on the initial and final states, it don't depend upon the path. I would like to give you an example, maybe you can work out with the help of an example. Let's see. Yeah, better. Anyhow, we have a p by q. So solve this question. I'll tell you. Round off to a couple of decimal places. C1 be the line segment joining from 0, 1 to 4.4 by 5, 3 by 5. And let C to be the arc of the circle x square plus y square equal to 1 from 0, 1 to 4 by 5, 3 by 5. If alpha is equal to integral over C1, this integration, and beta is equal to C2 over the same function with along some different path, r is equal to xi plus yj, the value of alpha square plus beta square. Come on, do this. What is the value of alpha square plus beta square? Do this question. So see, first of all, alpha is integral over C1 along path C1 2x by y I cap plus 1 minus x square by y square j cap actually. Okay, this is what you have. Beta is equal to integral over C2, same function. Okay, I plus 1 minus x square by y square j cap dr bar. Okay, so there is dr bar in this case, dr bar. where this position vector is xi plus yj as usual. What are the values of alpha square plus beta square? Alpha square plus beta square. So first of all, if you see the paths C1 and C2, let's integrate that. X axis and this is y axis. Now what is C1? Let's see. C1 will be the line segment from 0, 1 to 4 by 5, 3 by 5. Okay. So let's say 4 by 5, 3 by 5, maybe somewhere here. 4 by 5, 3 by 5, of course. Okay. So this is the line segment from 0, 1, from 0, 1 means it is in this direction. Okay. So this is in this direction. Clear? So along this direction. And C2 be the arc of the circle x square plus y square equal to 1 from 0, 1 to 4 by 5, 3 by 5. So this is a circular arc along the circle x square plus y square is equal to 1 unit circle. Okay. So this is C1 and this is C2 actually. Okay. Now let's see the value of alpha square plus beta square. So first of all, try to understand one thing. If you consider f bar, this is 2xy I cap plus 1 minus x square by y square j cap actually. Okay. So we have 2x by I cap. Okay. This is I cap actually. So 2x by y I cap plus 1 minus x square by y square j cap. Practically speaking, this path is very complicated path, yes or no? Using the line segment or basically the line segment path or basically this circular path. Evaluating through the circular path is not very comfortable, easy. So let us first check whether if these integrations are independent of the path, for example. Okay, if these integrations are independent of the path, then let's see calculating curl. Instead of calculating curl, you can also do it another way. If this is m, check the exactness and this is n. Okay, then dou n by dou x and dou m by dou y. If you calculate this, let's see what you're getting. Dou n by dou x gives you minus 2x by y square. Dou m by dou y gives you 2x into minus 1 by y square. Yes, these two are equal. That means curl is actually 0. Okay, so curl f is actually 0. That means it's independent of the path actually. Okay, so alpha and beta both are same. Clear? So this is nothing but 2 times of alpha square or maybe 2 times of beta square. But line segment is generally easy to evaluate. So let us solve basically using the line segment. Okay. So since curl f is 0, integral over c f bar dot dr bar is independent of path. Okay. So this is independent of path actually. So this implies alpha is same as beta, and alpha square plus beta square can be just written as maybe 2 times of alpha square. That's it. Okay. So 2 times of alpha square. So one thing we observed by inspecting the curl of this vector point function, we came to know that the curl is 0. So you integrate along any given path, the answer is same. Now what is the value of alpha? How do we find out alpha value? So let's see what is the equation here. What is the equation here? In this case, the equation is of course curl f is 0 in this case. So curl f is 0. The equation is, it is 0, 1, right? So y minus, or better, what shall we do? Shall we calculate alpha or beta? Which do you feel is easier to evaluate? Tell me. You might have done now. So out of alpha and beta, which could be easy to proceed with? Along which path we shall integrate? Because anyhow both the paths are same. Okay. So along line segment and also along the circular path. So if we can evaluate one, then definitely you can get the other value. Okay. So along which path we shall do? Shall we do along line segment? Okay, because it's easy now comparatively. So let's see C1. Let us consider alpha. Along the path C1, along the path C1 actually, 2x by y dx, 2x by y dx plus 1 minus x square by y square dy actually along this. Okay, so this is the integration. Okay, Yeah, it is alpha. Fine. Beta will continue with alpha. Okay. So let's see. What is the path now? C. Let us identify. Path C. What is C1? This is basically passing the 2 points. Y minus y1. Y minus y1 is equal to y2 minus y1 by x2 minus x1 times x minus x1 actually. Okay. So if you simplify this, y minus 1 is equal to, okay, so y minus 1 is equal to 4 minus 5 minus 1 by minus 2 times x actually. So x is equal to 2 times of y minus 1, better. Okay. So x is equal to 2 times of y minus 1, which is dx is equal to 2 times of dy actually. Okay. So dx is equal to 2 times of dy. Last time same question you done by alpha. Acha, I have done by alpha. Fine. It's okay then. Okay, because anyhow that's in the first quadrant. So you want me to do it by beta? It's fine. If okay, let's do it by beta if you want. Because someone is telling last time, I think last year I think I have solved by alpha. So maybe this time we'll do by beta, no issue. So C2 is x square plus y square is equal to 1. So y is equal to root of 1 minus x square. Okay, so y is equal to root of 1 minus x square. So what is dy? Dy is equal to minus 2x by root of 1 minus x square into dx. Okay, so this is how we can replace dy. So therefore along C2 doing this expression, so beta is equal to along that path 2x by y dx. Okay, so 2x by y dx plus 1 minus x square by y square. Along that path y square is this, and dy is minus 2x by root of 1 minus x square dx is what it's coming. Correct? Yes or no? But it's in anti-clockwise. I mean it's in clockwise of course. Okay, so this is in clockwise. Anyway, value could be negative. Integral over c 2x by y. Y could be root of 1 minus x square. So y I am replacing with root of 1 minus x square dx plus 1 minus x square I am keeping as it is. Y square can be written as 1 minus x square into dy is, if you differentiate this with respect to y, 1 by 2 root of 1 minus x square into minus 2x. So 2 gets cancelled. So I think there is no 2 here in this case. Okay, so this 2 is not there because that gets eliminated, because differentiation of this one by 2 root of 1 minus x square. No? So 2 and this 2 gets cancelled. So minus x by root of 1 minus x square dx. Fine, let's see. And what are the limits of x? X is changing from 0 to 4 by 5. No, 4 by 5 or 3 by 5? X is changing up to what point? X is changing up to 4 by 5. Okay, fine. 4 by 5. Let us calculate this. X is changing up to. Okay, x is changing up to 4 by 5. Okay, so if you simplify this, undoubtedly this value is 1. Okay, and 2x by root of 1 minus x square minus x by root of 1 minus x square. So beta is equal to integral 0 to 4 by 5 2x minus x by root of 1 minus x square dx actually. That's all. Okay, so this is a simple integration which you can do. So 1 minus x square. So if you put a minus 2 and minus 1 by 2 of course. Okay, then this numerator is the differentiation of denominator. So beta is equal to minus 1 by 2 into 2 times root 1 minus x square within the limits 0 to 4 by 5 of course. 2 gets cancelled, and this is in the clockwise loop. So I am putting a plus sign. Okay, this minus became plus, minus to plus because of clockwise path. Okay, so this is clockwise. So if you simplify this value, how much it is? Root of 1 minus 4 by 5 square minus 1. Here you have to just simplify. 25 minus 16, this is 3 by 5. 3 by 5 minus 1 is 2 by 5. Okay, so beta value is minus 2 by 5 of course. So therefore 2 times of beta square is equal to, because 2 alpha square is same as 2 beta square, 2 times of 4 by 25, 8 by 25. How much is the value? So 8 by 25, how much it is? 8 by 25.32. Yeah, this is 0.32. Is that the answer? What you are getting? Because you can do it anyway. Okay. Hi Mitesh. Yeah, because last year I think one of you are telling I have done it by alpha, now I have done with beta, it's okay. Even this is also fine. Any technique, okay, doesn't matter. Basically you can calculate any one of those two integrals, that's it. Till here it's purely understanding, and yeah, some bit of converting double integration to converting integration of two variables into single variable gives you the correct answer. Yeah, 0.32 is the correct answer. Okay, so 0.32 is the correct answer in this case. Okay, so these are line integrals, and this question, it gives you a beautiful insight of understanding. Whenever the vector field is irrotational, means basically if the vector field is conservative, then it doesn't depend upon the path. Okay, yeah. So let's see what else we have. Consider the function f of xyz is equal to x cube e power y sin z and the point p 1, 0, 2. The value of f not changed due to a small displacement of p along the direction of. Nice question. Come on, solve this. If you have a function, okay, so this is the function f of xyz, for example. It's not a curve, actually. Some, you know, some maybe temperature or pressure field, something is there. At point p, at this point, even if you change your dx by some small amount, means if you move along that direction, there won't be any change in this f. That's what. Okay, means let's say for example, it's a plane, for example. Okay, assume it's a space. Okay, there is one point here and there is another point. Let's say even if you are moving in this direction, there should not be any change in the, let's say for example, if the pressure is p, here also the pressure should be p. That means if vector calculus over, yeah, one thing, it's very simple. If you find the scalar function of f vector, yeah, we can find the scalar function of f vector also, because, but normally in solving partial differential equations, because it's in this question it may be very simple that we can observe that it's 2x by y and all, but in general you cannot just by looking at the vector you cannot pick directly. Okay, okay Vivek, so let's see, can anyone tell me, in a particular direction, even if you are changing displacement, if property is not changing, what is the gradient of p in this direction? Can anyone tell me? In this particular direction, what should be the gradient of p? In that direction, it's directional derivative basically. So direction of p in that, gradient of p in that direction. See, between 2 points, let's say for example if a temperature field is there, okay, if I am walking along this direction, let's say temperature is changing, then definitely in that direction there should be some temperature gradient, yes or no? Because if I am shifting my displacement, then definitely I am feeling some effect of temperature change. That can happen only because of having some gradient. So this tells you, you should identify this direction a bar, where if you have a, for example you have some field, so this is the field, in this case grad f dot a by mod a, this is the directional derivative gradient in the change of f in that direction a, and this is at point p, of course. Okay, so this has to be 0 actually, and anyhow this is just a scalar, so this is just a scalar, even if you throw it this side it will be 0. So gradient of f at p dot a, this should be 0 actually. Okay, so that's what you have, that dot product should be 0 because the change of the function in a particular direction. Okay, so directional derivative concept. Now gradient of f, so let's see, gradient of f, 3x square e power y sin z plus x cube e power y sin z plus x cube e power y cos z, k. Okay, this is j, this is I. Okay, and this vector you have to calculate at 1, 0, pi by 2, because at this point you want. Okay, so if you put y equal to 0, all these values are 1, exponential gives 1, x also gives 1, wherever there is x involvement it gives 1, and sin pi by 2, so this cos z is 0 anyhow, then sin z is 1, this sin z is also 1, so 3i plus j, that's it. Okay, so this is the vector. Now you have to check out of these vectors which vector when you do dot product with this will give you 0, that's it. Okay, because if you have axi plus ayj plus azk, so this in this direction it should be 0, so you have 3ax plus ay is equal to 0 actually. So let's see in which direction we have 3ax plus ay is equal to 0. 3ax plus ay, no, this is not 0, 3ax plus ay, 3ax plus ay. Yes, this is 0. This is also not 0. So C is the correct answer. Okay, that's it. The vector component should be in such a way that 3 times of x plus ay should be 0, so that whenever you take the change in a particular direction, then in that direction you won't experience any change of the function. Okay, that's it. Clear to all? Yes. Okay, so complex is there now, I guess. Yeah, fine. Okay, so I think it's slightly concept heavy because we have done 2 very big modules, linear algebra and also linear algebra and also calculus. Okay, so calculus is the biggest module, of course. Okay, so we will stop here for today. Okay, because even if I go beyond, but it's just like syllabus completion, but I know majority of you will be already feeling hectic because of 5.5 hours continuous things. So we will stop here for today. Okay, and we will start from tomorrow. Tomorrow at 6 p.m. again we will start with complex numbers, then differential equations, both ordinary and partial, and then probability and statistics, then numerical methods with sequences and series. Okay, so these are the things which we'll cover in tomorrow's session basically. So I think because it's a long session by now already, so even if I teach, I can continue, but it's like teaching, feeding the same lot of content on the same day, it's not very good. Okay, so we'll stop here for today, and okay, so we have some nice questions of differential equations and all, but anyway we'll solve tomorrow. So yeah, we'll talk tomorrow about this complex calculus, then probability and stat. Okay, numerical methods. So one more question from calculus. We have some more questions from calculus. No, we have finished everything. But anyway, tomorrow when I'm trying to come, I'll try to put some more questions. Okay, because I think we have solved all the questions. No empty slides in between. Okay. Yeah, no empty slides. We have solved all questions. Okay. Any series for 𝐂𝐚𝐿 you want for 𝐂𝐚𝐿, because my plan is like today and tomorrow maths, then on Wednesday we'll talk about some excess topics of fluid mechanics like Reynolds transport theorem. Okay, and potential flows completely in complex numbers. I thought of giving basics of complex today, but anyway tomorrow I'll give you, no issue, because it's a slightly lengthy session. So, and yeah, complex numbers, this potential flows, RTT, boundary layer equations we'll see in detail, and we'll also talk about Navier-Stokes equations for thin film flows and all such sort of things. Okay, if you want for demo, I'll take one on Thursday. Yeah, only that day I have to take, because Friday again I'll be in travel, and Saturday exam. Are you all, have you all seen some nice points, some nice explanations and all? Okay, so basically you not mug up anything, you keep using these things daily in day-to-day life in your technical subjects. Like for example, vector calculus, I teach very easily. In general, anything in all these concepts you have seen, I've explained you very easy, because we keep using these things day-to-day in day-to-day life. Okay, so for example, if you want to calculate maximum efficiency, use differentiation, concept of maxima and minima. Okay, if you want to integrate something, we'll do an integrations a number of times in our mechanical or basically in civil or any other branches. Okay, so integration is nothing to worry. So things like that. Colleagues, FM session you want interchange, but then people will lose the continuity. So tomorrow we'll finish off maths, then using these mathematical concepts we'll solve fluids. Okay, because if I take fluids now, again complex numbers, principles and all, I have to teach you again and again for 2 times. Okay, that won't be good. So whether for bar curtain exam I'll concentrate on interview or parallel introducer. First of all, focus on technical this exam, bar curtain exam. Okay, once it's done, then you'll get time, around 1.5 month time you'll get, or 40 days, 40-45 days you'll get easily, so that within that time you can just pick 4 or 5 subjects and try to get expertise in that. Okay, fine. So thank you all. If some of you wish to contact me, you can just contact me here on this Telegram channel. It's managed by majority by my students and me, so you can maybe drop in there. Okay, yeah, so thank you. We'll meet tomorrow again at 6 p.m. We'll start with complex numbers. Okay, sequences and series, then ordinary differential equations, some nice parts are there. Okay, so we'll touch up all these things. Thank you, bye.